I think now's a good time more than ever to start Space News up, huh? Yeah? Should we start Space News now? What does that sound? There we go. Put it back? Oh. Oh, nice, drummer. There you go. Are these engines going to be on Artemis too? Not this particular one, Ryan, but it could. It's a developmental engine. It's an extremely inefficient. Well, actually, it's very efficient. Hydrogen motors. The person in the email also died today. It sucks. Look at the gimbal. Oh, that's awesome. Let it flow, let yourself go, slow and low, that is the tempo. Let it flow, slow and low, that is the tempo. What's your opinion, what's your take on warp bubbles? Some scientists say it's possible to create one and travel faster. Whatever you do, you're gonna need a lot of energy to do that. Who cares if we kind of can't do it? There's no way we're ever gonna generate enough power to do it. Oh, look at that. Well, at least not right now. Legit, dude. Oh, look at it. Look at you can see it gimbling. That's cool. Whoa! Oh! Oh! That's awesome! Bring it around town. Bring it around town. Oh, that's so cool. Whoa! Dude. That's amazing. That is amazing. What? I'll try spinning. That's a good trick. Judo, you could touch the outside of that rocket motor. If you touch the outside, your hand would freeze off. If you touch the inside, you'd have no hand left. Yeah, it would melt. That's the difference in thermal there. It's freaking ridiculous. I would not want my car parked in that lot. Yep. It's crazy. Gary, what was your question? What's the difference between the RS-25E and the RS-25s? The RS-25Es are modern versions of the shuttle motors. The RS-25s are converted space shuttle main engines, were engines that flew on the shuttle that have been upgraded with RS-25E parts. RS-25Es out of the box are restarted production. They restarted the shuttle's production line. Restarted the shuttle, well, RS-25 production line, I should say. So it doesn't use nitrogen for cooling and combustion. Well, you can't use nitrogen for combustion because nitrogen is an inert gas, Bagel. No, it's using hydrogen. It's using the fuel. That's liquid hydrogen that's cooling the nozzle. That's part of the stage combustion cycle. Because this thing does a fuel-rich stage combustion. I don't know, Ryan. I don't. If I knew the answer to that, I would be working for NASA. But it's more about the new manufacturing techniques, Raj. Yeah, Melvis already said it. But yeah. Is this the same engine as the last test? No, this is a new one. Or at least I think it is. At least I think this is a new one. How many tanks are they going through? Just those 2 tanks at the top, dude. This is the LOX tank, that's the hydrogen tank. Yeah. So, this is the A2 test stand, Judo, and how this thing works is that the A2 test stand can be reached by barge. There are canals that bring it in. It's actually way inland in Mississippi, right? That's where most of the Stennis Space Center is. So what they do is they tow the liquid oxygen and liquid hydrogen in on barges. See them back there? They have their barges with big tanks on them. And then they'll flow, they drain the propellants into here. That's the fuel tanks for the engine test. The fuel tanks are optimized in shape and size to be able to do a full duration burn on one RS-25. So keep in mind, like, if those tanks look small compared to like an external tank on the shuttle or an SLS core stage, well, the external tank is designed for 3 RS-25s. The core stage is designed for 4 RS-25s. That's designed for 1. Hey, B. How are you? It's just that it's running forever. Should be shutting down sometime soon. And that's hydrogen, man. Hydrogen's freaking cheating, man. It's freaking cheating. It should be shutting down very soon. They're going for a full 8-minute burn here. My last or no? 500 seconds would be much more than it would actually burn, right? No. Well, this... They're at 598. They're really pushing this engine. 605 is like beyond full duration. The SLS core stage will burn for about 8 minutes. Yeah, this is like way out there. They should be shutting it off soon. Oh, they throttled it back. Stand by for shutdown. They throttled it down. They should be shutting it off here in a second. Is it stuck on? God, I hope not. That would really suck. Yep, there we go. All right, 649 seconds. That or 650 basically. Wow. Yeah, look at it. Watch the outside of the engine. It'll cool off, and then it'll start to thaw, which is just nuts. That's 11, almost 11 minutes. That's ridiculous, man. I'm telling you guys. People knock on the shuttle engines. The shuttle engines are friggin' cheating, dude. I'll say it once, I'll say it again. It is an insane piece of kit right there. What they can do. It's just frankly a shame that we're gonna toss them into the water. Because they're friggin' cheating, dude. Like, I mean, the application here is insane. The application is SSTO territory all day. Who knocks on shuttle engines? Only everyone. Closures posted for tomorrow and Friday for SN15's flight. They are really expensive engines, aren't they? Yeah, but you get what you pay for. How long did they burn for the shuttle? About 8 minutes, drummer, give or take. Could you explain the difference between this test and the last test? Rycrom, this is testing a new engine. The last engine test was an RS-25, and this one is an RS-25E. The difference is that this is brand new. They built that entire engine very recently. How deep can they throttle these things? 60%. Did the shuttle have any problems with the RS-25s during ascent? No, not really. There was one time when Challenger had an abort to orbit, and that's because the sensor picked up a over pressurization, I think, somewhere in the RS-25 or the SSME's plumbing, and it aborted to orbit. But it turns out that the sensor was bad. So no, not really. They're great engines. They really are. They're great. They're fantastic pieces of equipment. I mean, yeah, they're a little bit on the expensive side, but if you buy them in bulk, it's really not a big deal. And if you're reusing them, it's even more not of a big, well, more of a not big deal. All right, guys, I'm gonna take a break. I'm gonna go grab something to eat. I'll be back in probably, I don't know. I'll make this a quick one. Just grab a bowl of cereal or something. Give me like 5-10 minutes. Yeah, Steven, hey, great test, man. Great test. Really fun. Fun to watch. Always. Okay, I'll be back in a moment. The song's over, but I'm not finished eating, damn it. Uh, Repeat? Alright. We can have it your way. All right, dudes. Hey, starting off with a Cosmo Quest raid. What's going on? And we're coming down here on the Eric Johnson Radio Show. It's currently 35 past the hour. Isn't that right, Mr. Scream? Great. Thank you for the Cosmo Quest raid here. Now we're going to get into the Space and Rocket Review. No, I didn't mean to rhyme there, but we did anyway. Yeah, DJ SA is back. That's right, we're back, but we cannot play any music at all. So here, I'm just gonna hit you with this sweet lick right here. Hi. Oh, Lord, yeah, that's right. I forget how to play it. Who let DJ out of his cage? He was all locked away. Did someone give him the keys to the straitjacket? Maybe. Tessa, do you like Huey Lewis in the news? Tessa, you know, the early work was a little too new wave for my taste. But when Sports came out in '83, I think they really came into their own commercially and artistically. The whole album has a clear, crisp sound and a new sheen of consummate professionalism that gives the songs a really big boost. He's been compared to Elvis Costello, but I think Huey has a far more bitter, cynical sense of humor. In '87, Huey released this, 4, their most accomplished album. I think their undisputed masterpiece is Hip to Be Square, a song so catchy, most people probably don't listen to the lyrics. But they should, because it's not just about the pleasures of conformity and the importance of trends, it's also a personal statement from the band itself. Hey, Paul! Ah! Try landing dirt on the runway again, you stupid bum! Ah! Sorry. I'm still mad about that. I'm working out most every day. I'm watching what I eat. Oh, man. Is that a raincoat? Yes, it is! I am screwed in the head because I think that scene is really funny. I start laughing every time I watch it. That's probably not a good thing. Oh, boy. Through the fire and the flames? No. Hey, Exit, what's going on? So, anyway, welcome. You like Huey Lewis in the new? Oh, man, I'm going to beat that joke into the ground, aren't I? Yeah, probably shouldn't. All right, anyway. All right, dude. Yeah, no, that movie's supposed to be a comedy, which is it's dark. It's dark. It's a dark comedy. The book is even better. Still bummed about the landing gears? Say it ain't so. Yeah, it sucks. But for you kids who want context, oh, maybe we shouldn't link that. Yeah, most books are. It's just a different medium where you can tell more of the story. I think people don't actually go and read the book for movies, but they should, because it's not just a person. No, sorry. Do you ever consider adding more planets to mission mode? What? I am a banana. No, I think, Wookie, you're talking about like going to other planets? Yeah, well, the idea was that we would go to other planets after we went to the moon, but I'm pretty sure my moon program is on hold right now. Yeah, I'm pretty sure the moon program is on hold. Oh. Alright. Should we start? Hey guys, do you like my coffee mug? Do you like Boeing's Rocket SLS? The first designs for SLS were a little too painted core stage for me. But it really came into its own when they decided to paint the core stage orange by taking the paint off. And then, in 2021, SLS launched Artemis 1, a rocket launch so catchy. No, sorry. Why is it so small? Guys, this is a regular, well, not regular, it's a little tall. This is a regular size coffee mug. This Ford mug is, see, that looks normal size for me. Do you guys want me to go get a normal sized coffee cup and show you? Here, I'll go get a normal sized coffee cup. I'll be right back. Okay, so this is the Ford mug. This is the Boeing mug. This is a regular sized coffee cup for me. Here. Crush it with your bare hand. Jesus, your hand's huge, I tell you. Yeah, the big guy over here, yeah. Come with me if you want to lift, yeah. I've gone my whole life without seeing American Psycho. That scene, wow, it's hip to be square. Mason, that movie's dope. It's such a good movie. What is American Psycho just a dark noir version of Office Space? Are all Americans like that? I mean, Ando, what do you expect with a steady diet of freaking red meat? Like red meat and protein, dude. I'm telling you, man, the food over here is hefty. We got some biggins around, dude. Remind me not to anger you in a dark alley. I mean, I don't know, dude. Like, 6 feet is pretty average for an American. Like, that's, what is that, 190 centimeters? Like, we're all Thomas Pesquet sized. I mean, that's kind of what I grew up with because I played American football. You need to be a big dude to play football. 6 feet wide. I mean, also that, Geeson, I don't think Americans have quite grasped the concept that, you know, if you keep eating, you stop growing vertically and you start growing horizontally. Secret USSR space project. Is that a porta potty? Why does it have the American flag on it? I mean, we're pretty big over here, dudes. 5'10" is the American male average. I mean, Torby, you know, big. Got a lot of big dudes. Yeah, exactly, 95. Mm-hmm. And then sometimes even on the Z-axis as well. I gotta sneeze again. It's a turbo. American, I'm 5'9". Still times. Apollo Soyuz test project simulator. Colorized. Yep. Mm-hmm. Mm-hmm. I know I do because I'm also the same height as American male. What is it with women from Michigan? Why are you so tall? Bremo's tall too. What the hell's that about? The hell are they feeding you up there? It's the Dutch. Yeah, Dutch people are tall too. I noticed that. It's because they got to keep their heads above the water. No? Too soon? Alright, too soon. I strongly disagree with your definition of football and coffee. Well, Swishio, American coffee is not for enjoyment, okay? It's a tool. It works a lot like a hammer. It's an ends to a means. You use the hammer for purpose. We use our coffee for purpose. The coffee is not meant to be enjoyed, okay? Don't ask why I have a hammer. This is a nice hammer, though. I use it to hang pictures in the apartment. You're a means to an end, Hellfish. Got him. Today I learned EJ keeps a hammer under his desk. Halt! Hammersite! Halt! Hammersite! That was loud. Okay. I also have this under my desk, just in case. I pray that I really never have to use that, especially on stream. That would suck. I also have WD-40, some duct tape, some super glue. You don't have this on your desk? Gotta have more cowbell. Mm-hmm. We have blinker fluid. I also have Jim. Now, that's the coffee part, Swishio. The football part, I don't know how you guys haven't realized that we just call it football just to piss you off. Like, is that not the most American thing to do? Get a sport where you're using your feet for like maybe 5% of the game and call it football. Why? Because screw you. That's kind of what we do over here. Like, I mean, like, why don't we just call tennis? Why don't we? Let's see, not tennis. Why don't we call soccer handball? Why don't we call tennis, foot stick? I mean, that's basically hockey, but. So you ready for them to extract Jupiter 4's core from Pegasus tomorrow? Jupiter 4? Go Habs. No. Canadiens is merde. Merde! Canadiens merde! Merde! Why do you call meters inches? What? Hey. All right. Measuring systems are like different languages, okay? Measuring systems are like different languages. I don't hear anybody here saying that one language is more efficient than another, okay? All right? Oh, yeah, there are some languages that are easier than others. Does that mean you can't have a conversation in Russian because it's inefficient? Don't be a languagist. Don't be a measurist, okay? It's 2021. Don't hate on different people because they use a different measuring system than you. Stop measuring system hate. It's funny how German is inefficient. I know, right? That you think you're so smart with your nice Germanic language. No, nein, your language is inefficient. English is needlessly complicated. Yeah, but everybody speaks it. So, I mean, it's part and parcel. Overcomplicated measuring system, overcomplicated language. It's science. American is the most efficient. That's right, you dang right, Novus. Why use more words when few do trick, boy? German here. Why have 4 words when you can have 1? More efficient. Did you hear that? Yeah, Neo, I'm trying to keep spirits up.
You see, Ernak, words are like bullets. And I just let them bounce off of me. I just rise above it.
Everybody speaks English because of the British Empire. Yeah, but see, Kem, you know what the most metal thing is? When people hear people speaking English, they don't think you're from England. When people hear you speak English, they think you're from the United States. The United States was so metal that we rebelled against the English and we took their language. We took your language from you. Boom. Boom. We took it. We're saying, no, this is ours now. You can't have it anymore.
Discovery.
No, oh, he gave it to you? Yeah, just like you gave the tea to us too, you prick. Never heard of that in the EU. Yeah, because you're hearing biased opinions. You took it and destroyed it? Yeah, I know. That's the idea. We don't like them, remember? Repost. That's what the SLS community started calling SLS recently. Even a Rule 8 person acknowledged it. Boston is basically the UK. No. Do you like freedom, Draco? Do you like freedom? Do you like freedom? Do you like freedom? Do you like that? Do you like freedom? Do you like taxation with representation? Not sure? Communists detected. I think it's time 1776 commenced again up in here. Do you like Huey Lewis in the news? Sincerely, I like America more than British because America's much more like the European pronunciation. We hate them too. It's quite easy to know on those folk. Nah, they're alright, Switch. They're just doing their thing. Just let them do their thing. Wind eruption. Give me 1 second. Here you go.
I'm here for you, though.
I know what you might be thinking. No, I didn't play that. That's from a Twitch streamer called The Do. I know. It's hard to believe. Hard to believe that wasn't me. What was the end of that? He was playing it for a girl. So The Do is this streamer and YouTuber that goes on Omegle, and he just blows people's minds with like awesome guitar solos and stuff. And yeah, he decided to do an automaton round a little while back. But I tell you, I am not that big of a fan of The Do. I tell you who I like the best. Slap! OMG. I think that Davey 504 is the best guitar player ever. You know why? Because guitars do not exist. It is only bass. Slap. OMG. Like and subscribe to this video. Yeah, Pink, that's right. Mm-hmm. Epic style. Yeah, that's another YouTuber, Davey504, who does what The Do does, but with bass, and he's a disgustingly good bass player. You have Italian bias. I do not have Italian bias. Davey is the best. He's better than The Do. But secretly, there is no Davey. There is just Seth Everman, just bald, like me. You found our house, okay? You can now own a home on a private island in Rhode Island for $399,900. The house may need some renovations, but is a please. Okay. Want to buy it? What is this? The secluded seasonal cottage with an approximate address of 0 Patience Way is off the electrical grid and has approximately 600 square feet of living area, which includes 2 bedrooms, a half bath, a kitchenette, and screened-in picturesque front porch. A single solar panel will provide some electrical services according to the listing. I mean, Brimo, we could buy that. And we could play Stationeers. And actually, it'd be more playing Icarus at that point, huh? I mean, is there a bridge to it? Hang on. Now I gotta look. You've piqued my curiosity. OMG. You have piqued my curiosity. T-Man, what's that? An RGV picture? Yeah, we gotta get into space news in a moment. Streamer Island. Whoever goes there survive. No, you know what I'll do? I'll retire to that island, and then I'll just make remote control ducks and fly them, or remote control pterodactyls, and then just fly them around. You imagine what it looked like? There must have been thousands of them. Here's a path. Follow path. Path, follow path. Closed door. Open door, closed door. Follow path. You'll miss the ferry back. I don't think anyone? Yeah, there's no bridge to that. That's unacceptable. Is there a ferry to it or something? Welcome to my secret underground lair. So build your own? I'm pretty sure that you can't do that. Here, hold on. Let's take a look. Well, there it is. There's the cottage right there. We need to build a bridge here. That's 1,000 feet. So, yep, we're immediately bankrupt. That's good to know. And then even if we connect into this other island, there's no paved roads to it. Oh, there's some paved roads. That's good. I see some guy already has his compound over there. There's the ferry. Okay. Underground secret tunnel. Rhode Island terrain is, especially around here, is a little bit on the swampy side. That's Prudence Island? OMG. Slap. I just, you know, if there was a bridge, is it bad if there was if like there was a bridge there, I'd actually consider this because there's a ferry dock. Clearly. There's a ferry dock you can take. You could drive out there. There's clearly roads and there's clearly a boat that goes, you know, like clearly people live on these other islands and there's clearly a way to drive on there. Roads. Roads. You know how fast you were going? I'd say like 65. 7 miles an hour. Build a huge dam. Yeah. I mean, you know, you're kind of close to Fall River. You know what's in Fall River, guys. Oh, yeah. Where's the front? Oh, the front fell off. Can I? Okay, new plan. Can I just make this my house? No, the front fell off. Yeah, Tessa, that'd be fine. Iowa? No, Jim, that's a South Dakota. It's a little mini Iowa. Instead of 16-inch cal 50 Mark 7s, this has 16-inch cal 45 Mark 6, slightly shorter barrel. And then there's, yo, check it out. This is like actually a really awesome nautical museum, just on a side note. They have the Joseph P. Kennedy Jr., which is a gearing. They have a Belau-class submarine. And then, get this, Hidden Sea. Hidden Sea was an East German frigate. It was manufactured in, I think this was made in St. Petersburg. I have no freaking clue how it found its way over here. Yeah, look, it's got the Russian Sea Whiz on it. The close weapon system, see it? And then it's got the anti-ship missiles that the Soviet Union used a lot of. Yeah, Vasya, this sucker was made in St. Petersburg, I'm pretty sure, if I'm remembering correctly, just on a side note here. Check it out. That's in Massachusetts. I still have no idea how it got here. Yeah, see? Petrovsky Shipyard. St. Petersburg, dude. Alright. I have no idea how this thing made it over here. But it's got, it's got everything, dude. It's full of, like, the East Germans, when Germany reunified, they just gave it, they were just like, yeah, we don't need this anymore. Seriously. Weirdest thing. It's an awesome ship. It's cool. You know, actually, I'd like to go back and I'd like to freaking go around because all the inscriptions on everything is in Cyrillic. So I could actually probably go and read that. Probably go in there and be like, yeah, I know what that does. Parzival, no, no, not the right thing. St. Petersburg, Florida? No. No. No, there's no Petrovsky Shipyard in St. Petersburg, man. Florida. I'm talking about this St. Petersburg. The one where you hear, like, mandolin music going. And then a bunch of guys singing going, oh, you know what I mean? Teach astronomy, hey. 12 viewer raid. Thank you very much. Where's Petrovsky Shipyard? I'm gonna go ahead and guess it's down here. Oil, natural gas, export for sure. That's a big one. Look at this thing. That's a big one. We should make something like this in Minecraft. Import, export for sure. Man, look at that bridge. Ooh. Oh, like. It's a nice bridge. Hey, Astro, what's up? Shipyards are to the north a bit. Spasiba. You know what? I remember now, Vasya. I remember now because we were talking about the Aurora. And I went and looked to figure out where the heck it was made. Or where it was moored. And I remember you showing me this, but I'm blanking on it now. Check out Teach Astronomy. They're great. Oh, I'm sure. Teach Astronomy, thank you very much for the raid. I'm going to go ahead and guess that you were teaching people about astronomy. Am I wrong? No? Oh. No, you're a painting streamer. Oh, okay. I'm just kidding. Nobody said that. I brought some raiders over for here from Teach Astronomy. They're a relatively new space channel that you found. Awesome. Squishton, tell me. Tell me what Teach is about. Or if Teacher here, tell me what you're about. Astrology is better than astronomy. Niet. Well, yes, but actually no. Shipyards are here. Let me see, Vasya. Yeah, it's weird, dude. I don't know how that ship got here, but it's still cool. I mean, I always appreciate other folks' hardware. You know what I'm saying? Check Severomorsk. Okay. Yeah, I see it. Canals, man. Canals everywhere, dude. Oh, yeah. Nope. This screams shipyard right here. Look at this sucker. Look at all the dry docks. Yep. They have multiple hosts, and they are from Arizona, from what I know. They have worked with folks at the Lowell Observatory, just kind of a casual space chatting stream. Well, I can get behind that. That's awesome.
Keep going.
What the heck is this?
Keep going. There we go.
Ooh. Chevy owners, am I right? It's from the University of Arizona Astronomy Department. Cool. Wonder when you come here, I'll show you around all the open ships. I'd love to, Vasya. When the world isn't crazy, dude, I'm in, dude. You know that. That in the expo in Moscow. I'd like to see that. That would be cool. That'd be sick. Teach, let me see. We work with Professor Impey from the University of Arizona Stewart Observatory, and we love to do astronomy outreach. Huh. Well, Teach, first of all, how you doing? I'm EJ. Squishton referred you over here. I am a space nutcase. I don't know if you knew. I don't know what gave it away. So, like, the type of space that I like over here teaches, basically, if you know what NASA's Launch Services Program is, or NASA LSP, that's basically what I love to look at. I love to understand the launch vehicles and why you use different launch vehicles for different missions, and I focus more on the rocket side of things and the human spaceflight side of stuff. But I'm not that big into astronomy. However, I understand it like why we need that, you know. Let me just go out there and say that during a lot of the Gemini missions, they had to use the stars to navigate, and they had to bring a sextant up there, and they had to look at the stars to figure out where their spacecraft was in space. Turns out that when you're in low Earth orbit, 270 miles that way, the star patterns don't really change from when you're on the water down here, so you can use the stars to navigate. Yeah, in one of the Gemini missions, Buzz Aldrin used the stars to navigate, and then another of the Gemini missions with John Young sitting left seat, Michael Collins used the stars to navigate to an Atlas Agena. Yeah, that was Buzz Aldrin's idea. He's the one that figured that one out. I can't believe you're out of your own mission control. Sounds like you got a really cool channel. Yeah, I mean, I have a really weird obsession with space. I don't know what that's about. But yeah, I do a lot of STEM outreach here, and astronomy is part of that. I know I gotta introduce you to my buddy Greg. There's a streamer called Econ Greg, E-C-O-N, Greg, all one word. He does daily astronomy streams and teaches people all about all the different types of stars. It's cool, man. It's really cool. I'm on the side of wanting to go and see that. Like, I'd love to see the pillars of creation with my own eyes. That's probably never going to happen. Even if we did have a way to get there, it's probably still not going to happen because it's probably gone, if I'm remembering correctly. But yeah, it's cool. I like it because astronomy's kind of leading the way. It's showing us what's out there. It's showing us where we could go, what we could do. But yeah, you know, thank you for the raid, guys. If you guys want to, I mean, I'm always for more space stuff here on Twitch, always. So, yeah, the pillars are gone, if I'm remembering right. The Horsehead Nebula, I don't think is a thing anymore. I'm pretty sure that's decayed. It's just the universe is so ridiculously big, guys. It takes light a long time to travel across. So the funny thing is that the star patterns that we're seeing now, that's not what they look like now. That's for sure. I mean, there could be another sentient species on the other side of the, on the other side of the galaxy. They wouldn't even know we exist. You know why? Because, like, radio signals didn't start being a thing until, like, the last 150 years. That is a millisecond on a cosmic scale. It's nothing. Sounds great. We'll definitely check them out. Astronomy and spaceflight go hand in hand. So glad we found another space nerd. We are aplenty around here, don't you worry. Especially in this stream. But yeah, no, thank you. Thank you for the raid. That's awesome. I'll definitely be sure to tell people about the channel. Let's get it going. Space is hot right now. We need to capitalize on it. The kids love this one. The kids love this one. Merchandising, where the real money from the space is made. Where the real money from the space is made. We got everything. We put the names on everything. NASA the baseball cap. NASA the rocket. NASA the flamethrower. The kids love this one. Sorry, I use movie quotes to teach because movies are funny. And last but not least, Elon Musk the doll. Space the doll.
May the Schwartz be with you.
And teacher's like, okay, leaving now. Bye. No, don't leave, I swear. No, I'll be all right. Yep, they're gone. Okay, no. But yeah, that's cool. Awesome. I'm gonna have to go check out the VODs, dude. I will give a follow right now. Right now. Let's go over there. Squish, thanks for finding that, dude. Thanks for hooking us up, my guy. Oh, I like this. I like what I see. Oh, yes. Wait, in the last VOD, were you talking about how they did helicopter on Mars? They did yeah, you were. You were talking about how they did helicopter on Mars. They did helicopter on Mars. Actually, that's a good time to transition over into space news. Because we do have pictures. We do have pictures from the latest drone flight, and there are pictures of Perseverance just chilling. Here, check this out, guys. Take a look. How's that? Just Percy, just chilling over there. Talk about the third flight yet? What, that one? They are helicoptering on Mars. What always, and you know what? I always talk about this every freaking time, every single time we see a picture from Mars. Like, And I know that a lot of these pictures are color corrected and whatnot. Like, I get it. I understand. But also at the same time, even with color correction, these pictures look... It doesn't... It looks very, very strange. Because it looks normal. This looks like a desert, right? But it's not. You notice that there's... You start noticing things. This looks like, okay, you could have taken this picture in the Sierra Nevada mountains. Like, that's what this looks like, right? But also at the same time, you start noticing stuff. There's little things here and there. You're like, that's not Earth. It's very...
Listen, Tranquility Base here. The Eagle has landed.
It's very uncanny Mariner Valley. Huh? See, I don't need a pun. Yeah, it's very familiar and very distant at the same time. And it blows my mind every time. Like that, okay, that looks like a bunch of rocks and some sand. Sure. But then you start looking around and you're like, huh. What's that? Oh, that's the rover. Okay. That's always what got me about this. Quite a long setup for that joke. They're going to try killing Ingenuity on the last flight. Ingenuity performs third flight as final most challenging tests await. Yep. Japan will be asking Twitch for you to stop. Huh? And also, Teach, we have people that like tipping and leaving messages with puns, like this one. Not sure how that added to the discussion, but sure. Just, all right. We do not name these people. Teach Geeson is the one that's doing it, and he's a horrible person because he knows it jars on me a little bit. See last, please. Something odd about the interior of Dragon. What? What are we looking at? I mean, guys, I already have a metric ton of stuff over here. Do not clean windows with hydrogen peroxide or acetone. Yeah. You know why? Because both of those are flammable. Yeah. Yeah, how about we don't do that? How about we don't use Windex in here? That's a bad idea. Yeah, hydrogen peroxide and acetone. Nope. I don't think I need to know. I don't think I need to say why you shouldn't do that. Yeah, Shane. What a beast shot. Oh, man, that's cool. Shane's just like, yeah, what up? You wish you could have sunglasses like that. That looks like an airplane window. There's Thomas. Monsieur Pesquet. Also, acetone dissolves plastic. Oh. Yeah, we saw the toilet already. That's good. A nice little... I see you're trying to use the bathroom. Can I help? No. No, Dragon Clippy, go away. It's okay, guys. Dragon is... its back-end code is in Linux, so you don't have to worry about Clippy. I see you're trying to poop. You need help? And the toilet literally has a poo emoji on it. Just sense of humor. There's being cool, and then there's being Thomas Pesquet cool. You will never be as cool as Thomas Pesquet. The Dragon Clippy is called Poopy. Yep. Okay. Yeah, the Pima Air and Space Museum has an incredible collection. Definitely worth a visit. I've been to Pima. I was at Space Fest in 2019 before the world went crazy, and I got to interview a bunch of flight controllers, and then I may or may not have just put a couple of extra days into the budget because I knew that Pima was there and Davis Monthan is there. Yeah, I like Arizona a lot. Arizona, and museum and Space Fest notwithstanding, I like the desert a lot. I grew up in the literal opposite of that, but yeah, desert's beautiful. I really like it. I'm also a car nutcase, so I don't like rust. The desert, that doesn't happen. Yeah. So yeah, no, seriously, Tucson's beautiful, beautiful city, and I like Pima a lot. So I did a very East Coast thing to do, and when Saber and I went there, I didn't drink water, and I went and toured the entire museum. I had the worst heat stroke by the end of the day I think I've ever gotten. I literally had a headache for like the next day and a half. Yeah, and I just had to chug water. Yep. I'm sorry. There was too much stuff. There's too much. We didn't even get to see everything. You cannot cover the entirety of Pima in one day. It's literally impossible. There's so many frigging planes there. I could spend days in Pima. Days. And then they were really nice. They let us go into the back part of Pima teach. They let us go into the back part, and as a car nutcase, let me just say that they were working on airport tugs back there. They bought a lot of surplus military airport tugs, like the things that tow the planes around. And the trucks that tow the planes around were had very sought after engines in the car nut community. Like so I was yeah, that's the part we didn't get to stream. I opened up a room in a warehouse at Pima in the back, and it was like Raiders of the Lost Ark with like all these engines from the airport tugs. Now, for the car nerds, they're 6BT Cummins engines. The Dodge had a huge contract to make Dodge Rams in the 90s airport tugs for the military to move around like big cargo planes. And what did the heavy duty versions of Dodge have? 6BT Cummins. I opened up a door into a shed at Pima, and we didn't get to stream this part, that had 50, I kid you not, about 50 6BT Cummins in it. I went, I just shut the door. I'm like, nope, I can't go in there. They were 12 valve and 24 valves, Gaw. They were the 5.7 and the 5.9. They're all different types of motor. It was nuts. It was nuts. Yeah, farm, it was awesome. So they use those for airport tugs and stuff. They use them for parts. Because Pima has airport tugs because they need to tow around some big frigging planes. Please tell me that was prefaced by someone saying, hey, I heard you like cars. There was no crew around when we popped into that building, Blueland. But I knew, I could tell that the guys there that restore planes at Pima, they're all car nutcases because they had their cars on the tarmac in the maintenance hangar and they were working on them. Yeah. Thanks for the shout out. Hey, Red, thank you for the raid, dude. And Beltbox for the 55-month resub. Red, what were you up to? Were you playing KSP? The VODs of the visits are on DOS's YouTube channel. Yeah, they're, yep, They are? Oh, nice. So there is a place where you can see those. I also got to hug an LR87 on that tour. A Titan 2 and Titan 3 and Titan 4 first stage engine. Yeah. Yeah, I got to hug one. What? You wouldn't hug a rocket engine? Don't judge me. The Pima VODs are, but that's it. Got it. Portal 2 today. First time playing it. Physics in action. Oh, you're in for a treat. Portal 2 is fantastic. Cave Johnson is my uncle. Eric Johnson, Cave Johnson, he's my uncle, you know. That's why I build all the crazy stuff that I do in KSP, because it runs in the family. Not sure if you want more links, but here are some. Sure. Of course. But anyway. There's a lot of... I love these types of space news, yeah. There's a lot of different raids coming all in at once, guys, and I'm trying to... What I try to do, and this is just on a side note, the reason why I'm, like, not getting into space news like I normally do is because when we get raids, I don't just want to be like, hey, this person raided me. Be sure to go give them a follow. They're a great streamer. I like to have conversations, just a short conversation with the people that are raiding, so they can get a little bit to talk about themselves in chat. And so I get to know them, because first world streamer problems, man. I'm too busy streaming to have time to go watch other people's streams, and that sucks, because there's so much good stuff out there. Have a lemon. I don't want your damn lemons. So, yeah. You know, Red comes in with a raid. Teach Astronomy comes in with a raid. I try to talk with these folks. You know? I try to talk with these folks to give them a little bit of word and edgewise, you know? Instead of just saying, hey, follow this person, bye, next news. You know, I don't like doing that. I used to do that all the time. I'd rather have a conversation so we can get to know each other. Will NASA's next extravehicular mobility unit be used on the ISS as well as lunar missions? Ryan, I think those are two different programs, if I'm remembering correctly, but NASA shuffled it around the other day. I don't know. Next news. Yeah, right. Hey, Racing, what's going on? All right. So, let's pop in. I covered the helicopter stuff, and I have so much space news on here. Car salesman, you could fit so much space news in here. You know what? Let's start with this. All the Pima vids. Cool. Okay. Cam, I have all the Russian news. Spasibo. All right, so we should start here. So, NASA EGS is tweeting here. Pegasus with the SLS core stage for Artemis 1 is at the VAB. They should start doing unloading operations very soon. This thing came, actually, I think they might be doing it now. That's no SLS, that's Jupiter 4. Yeah, okay, Thomas, everybody wants to call it Jupiter 4. Who started that? I'll bet you, I think I saw it. I think I saw it when you said what started it. It's Dave Willis, isn't it? David started that, didn't he? You like the tall tugs? Vasya, those tugs are designed for shallow water. They're shallow water tugs because they go up the rivers and stuff and canals. I prefer Mars 3. David started it. Reason for Jupiter 4. Okay. Alright, let's see. What did David say? The Jupiter 4 is named after the Roman king of the gods and ruler of the sky. In Roman mythology, Jupiter 4 was the successor to Saturn, just as Jupiter 4 will be the successor to the Saturn V. Jupiter was also the god who placed Orion into the sky, just as Jupiter 4 will place the Orion spacecraft into the sky for the Artemis missions. The 4 is a reference to the 4RS-25 engines that power the core stage of this mighty rocket. The use of Roman numerals as opposed to Arabic numerals is an homage to the Saturn V of the Apollo program. Sold. Good enough for me. And a Rule 8 person acknowledged it. Who acknowledged it, Thomas? Actually, let me just go read the thread. Someone from Texas? Is it that someone from Texas? Is it that guy? Let me pull it up, Steven. Do it. I was gonna say, well, I mean, you know, we'll take what we can get as space fans, right? Am I right? Randy Weber. He's a rep from the 14th Congressional District, Texas. Okay. It'd be funny if this turned into another Enterprise situation. I mean, Demo, the rocket needs a name. It needs a name. So he's rep for the 14th Congressional District of Texas. Now, here. I'm going to go ahead and guess that the 14th District of Texas is somewhere near Houston. Just putting it out there. I mean, is that am I in the ballpark here? I don't know Texas's districts. Let's see. I'm gonna go ahead and guess that it. Oh yeah. Okay. Yep. Yeah. 14th. Texas's 14th district. Okay. All right. Yeah. That. Fellas, ladies and fellas. Yeah. Let's see. So 14th district. Yeah. So, okay, if you don't know what you're looking at, that's Mission Control right there. Mission Control Houston. There it is. Right there. Specifically, it's that building. I think it's that one. It's either that one or it's that one. It's one or the other. So, hey, you know, also 905 is there with a mock-up of the space shuttle. That's the 747 shuttle carrier. That's the real one. So, I mean, also Ellington Field, which is where NASA astronauts train and fly out of. And also WB-57s, too. And then, also over here, as long as we're taking the tour, is this building. Snake, don't say it. Anybody else know what this building is? I thought SLS was the rocket's name. Well, it is a white building. That is the Neutral Buoyancy Lab. That's where so in here, there's a swimming pool that's the size of the ISS. And it's the size of the ISS minus the Russian modules. There's no Zarya and there's no Zvezda. So from the Unity module, all the way to Node 2, and then the entire truss segment is underwater here. And that's where the astronauts train for doing EVAs. The Vomit Comet is down here. Let's see. NASA's got a couple of Gulf Streams chilling. These are the private hangars down here. I think that it might be here. Well, there's those. Man, they gotta pressure wash that runway. It's all dirty. Yeah, there's a bunch of stuff. It's in the hangars though. That's where all the NASA's T-38s are as well. Hot off the 747 press. Mojave, Cornwall, Oida, Guam, and now Alcantara. The Brazilian Space Agency and Brazilian Air Force officially announced that Virgin Orbit has been selected to bring orbital launches to Brazil. Boa sorte. Cool. All right. Well, anyway, that's pretty cool. Oh. We'll call it Jupiter 4 from now on. Their business model is really quite nice. I wonder how they handle ITAR. Rocket guy, I suppose as long as the engines aren't manufactured there and you have kind of close arms control on it, you know, like not tagging stuff out, I don't think it's going to be an issue. And what is this news? You guys are... We're going through space news fast. You guys are coming in with new space news links faster than I can cover it. We haven't even gotten into any of this stuff yet. Can we get a quick rendition of Jim's theme? Now NASA is contemplating a sole source extension to continue to acquire CRS-2 services to January 1st, 2025 to December 31st, 2026. SpaceX, Northrop Grumman, and Sierra Nevada are the current CRS-2 participants for cargo resupply to the space station. Essentially, these companies will be able to compete for future missions, but nobody else. What's the whole Jupiter 4 thing about? Well, David Willis, the Twitter's resident SLS nut job, and I mean nut job in an endearing way. Actually, I know David watches the stream. Hi, buddy. I too like SLS, so, it's a term of endearment. I'm not like everyone else, trust me. He said on Twitter that we should call it Jupiter 4 because Jupiter in mythology lofted Orion to the heavens. And 4 because 4 engines. And Jupiter, Saturn, you know what I mean? I'll call it that from now on. I don't have a problem calling it that. Jupiter 4 is better than SLS, that's for sure. Yeah, Steven, I like David. He gets too much flack. But then again, he does like poking the hive too, so... I've watched many of his exploits from afar. He does like poking the hive. Is that an SLS mug? Yeah. Yeah, it seems to be par for the course. Stirring the pot. Speaking of SLS, core stage 1 is at Kennedy Space Center, right? It's definitely there. It will be unloaded and put in, and it will be unloaded and put into the VAB's transfer aisle, which is that big doorway right there. And then the transfer aisle goes from here to the other side. It's a big hallway. And when I say hallway, I mean just big open area. And then there's gantry cranes up here that can lift stuff up and stack them in the different high bays. The VAB has 4 high bays in it. There's high bay 1, high bay 1, high bay 2, high bay 3, and high bay 4. So 2 and 4 are on the west side of the VAB, and then 1 and 3 are on the east side of the VAB. SLS, for the Artemis 1 mission, is being stacked in high bay 3, which is this one right here. If we could open up this door, you'd see 2 5-segment SRBs right next to each other. Core stage will go in here like this. They'll take it vertical right here, lift it up, lift it over, and put it down onto the mobile launcher. Well, actually, they'll hang it on the SRBs and go from there. So there would be a Jupiter 4B and then Jupiter 4 Block 2 or something. Sure. Pegasus went Ever Given in Port Canaveral. I know. Why aren't you using the Ford mug? But yeah, my buddy Kyle got a picture of it, and I retweeted it. He got a picture right when Pegasus came in. This is Kyle Montgomery. Kyle's he's a photographer. That's what I was about to say. He's a photographer for Next Horizons, but he comes in here from time to time, and I like showing his pictures off because I like doing my due diligence. All these folks that go down there and take these pictures, figure we show them. How about the Apollo Cup? That's around somewhere. Are the 2 doors on the VAB? Do the 2 doors on the VAB go to pad 39A and B? No. No. The doors on the VAB, there's 4 high bays, and how they originally conceived it was that the 4 bays could all build Saturn V's. And if you look, Ryan, so there's high bay 1, 2, 3, and 4. So 2 and 4 over here, 1 and 3 over here. So how they originally conceived this is that, so NASA built 3 mobile launchers. They built mobile launcher 1, 2, and 3 right here. And then they built the 2 crawler transports right here. And then they have a track for the crawler transports. Now, the crawler transporters could move into 3 operational VABs. Now, during the Apollo program, or 4 operational VAB high bays. During the Apollo program, they only did 2. They only ended up doing 2 high bays, but they did build 4 because there were eventually 39A had Complex 39 had plans to build more pads, but they ended up never doing it because they ran out of funding. So high bays 1 and 3 were used for the Apollo program. They never used 2 and 4. They used them to stage parts. And then during the shuttle program, they redid High Bay 1 and 3, and High Bay 1 and 3 were used to integrate all shuttle stacks. They all go down one crawlerway, and then the crawlerway, about a mile down the road, splits. It splits between 39A and B. All Saturn V and all shuttle missions were launched from these. Every single human space flight from 1968 to now has gone out of Complex 39 for the United States. The last flight to go out of something that wasn't Complex 39 was Apollo 7 out of Complex 34 in 1968. That was the last human-rated space flight that didn't go out of 39. Pretty much up until the point where people fly on Starliner, which should be soon, early next year at the very latest. That will be the first time since then that people have not flown out of Complex 39. Little bit of a trivia question, though, or a trivia thing, not a question. Trivia thing for the people that don't know. Even though Starliner is going to fly from Slick 41, every single human space flight will still be out of Kennedy Space Center. Do you know why? 41 is on KSC property. Funny story. Not a lot of people know that. Yeah, Cape Canaveral Space Force Station ends like somewhere right here. KSC property goes up here, and then it takes a right there. So Slick 41 is actually on Kennedy Space Center property. It's on NASA property, not Space Force, which is interesting. I knew that. You took it away from me. But you can see that just like the VAB has additional high bays, they had planned to do an extension for the Apollo program. If they wanted to ramp up the Apollo program, they had planned to do an extension for complex or for 39C, and they ended up not doing it. There were originally plans to build 5 Saturn V pads, 1 for each high bay, and then 1 redundant pad. So there was originally supposed to be 39C was supposed to be right here, 39D was supposed to be right here, and then 39E was supposed to be right here. So it was A, B, C, D, and E. And believe it or not, the naming convention was completely different. It was going top to bottom, so it was like A, B, C, D, and E, or something weird like that. But there was supposed to be 3 more pads here. Another one right here in line with 39A and B. Another one straight on the crawlerway, so it would have been right here. And then there was another one that was going to angle off in this direction and be right here. That's kind of the reason why the Launch Control Center, if you've ever looked at the LCC, the Launch Control Center is kind of facing towards 39B, and there are 4 firing rooms inside of the Launch Control Center. It's not facing towards 39A. It's facing kind of just somewhere near 39B. Right here at the Launch Control Center is where they control launching the rockets. After the rocket leaves the pad, they transfer control over to Houston, where we saw a little bit earlier. But if you look, the 4 firing rooms were designed to operate supporting 4 pads and then 1 in redundancy. Yeah, they really had plans to scale up the Apollo program, guys. Yeah. Everything on the Apollo program was built anticipating a gigantic human push in human spaceflight, not just after going to the moon. I attribute that to von Braun's project management. The guy saw the macro game. Very good. I mean, kind of like that guy. You see, he kind of predicts what's going to happen, but didn't predict it getting canceled, I guess. Oops. Anyway, moving on. So SLS is there. The core stage is there. We have all the parts. Like, I want to just be very clear. Why did we stop Apollo anyway? Money. Shifting national priorities. Remember, NASA's budget, guys, is directly tied to public perception. If we the people and then the people that represent us don't see it as worth it, then they're not going to do it. It's that simple. So, I mean, I'm not about to say get Rule 8 rowdy, you know what I mean? Don't do that, but make sure that if you're old enough to vote, call your representative. I'm dead serious about this. You have to let them know. They're not mind readers, okay? it very much seems like in this day and age that, you know, representatives kind of see what's going on Twitter and use that as a pulse for what's going on in the world. No. Don't do that. Call them. I'm serious. Even if there's no NASA facilities in your area, call them. Tell them. What are they going to say? You're an idiot? No. I mean, the worst they're going to say is, yeah, I understand you, and then hang up the phone. But, I think you got to tell them, at least plant the seed there. Who's the representative for Stroop people? You're not part of the U.S. You don't have representation here. You're not part of this equation, Mr. Cowboy. Even if you're not old enough to vote, it's worth... Yeah, I mean, someone actually, if you're younger, that would be good because, I mean, you know, it shows you're interested. Copy that, calling the ESA directly. I mean, they'll probably pick up the phone and say this phone costs too much money, canceled, and then hang up the phone in your face. That's a joke, by the way. So, yeah, I mean, did you hear about Collins? Of course, Big Star. I knew about that the minute it happened, man. But we're not talking about that just yet. So, yeah, I mean, NASA's... The big reason why we stopped doing the Apollo program is because we didn't see it as a national priority anymore. And yeah, that actually was a mistake. So, you know, make sure that this time around, even though it's a frigging half century later, make sure that this time around we make sure that we're supporting every type of space flight right now, because you never know when it'll just be gone. You know, you got to remember these. You know, as much as we like to rag on politicians, they can't read our damn minds. You got to tell them. How are they going to know? Don't just go and whine about it on Twitter. Do something about it. Or on Reddit or on wherever your choice of social media is. Call Rogozin. I mean, if you're Russian, maybe. It's the politicians' fault that they don't read Twitter. Oh. Reveril, I know you're kidding. That honestly hurt inside a little bit to say. Why do I want this? I don't know. All right, anyway, so here's some more pictures, guys. This is back at Michoud in Louisiana. Boeing is getting ready for the forward join on Core Stage 2. Core Stage 2 is entering final assembly here. Which, I'm going to go ahead and say that doesn't suck. So this is the Core Stage 2 liquid oxygen tank and Core Stage 2 inner tank here. This is starting the forward join. The forward join is when you, take the forward parts of the SLS core stage and you put them together. They're going to take the liquid oxygen tank here, and they're going to stack it on top of the inner tank, and then they're going to put the forward skirt on the front. Couple of cool things to see here. Let me just take a look and make sure I'm looking at this correctly. So there's your autogenous pressurization lines right there. There's the hydrogen ground umbilical carrier plate right there. That's the GUP. That's the for venting hydrogen gas during fueling operations. This is the liquid oxygen tank over here. I'm not sure what those three things are for the LOX tank. Michoud, sir. Yeah, there's a D in it. Learn to speak English. Wrecked. All right, anyway. I think this is a... So that's the open port for the LOX downcomer. Because SLS uses an inner tank design, there's a pipe that comes out of the bottom of the liquid oxygen tank, and then it Y's off into two separate lines. And one of the lines goes out the side and around the hydrogen tank on this side, and then there's another one on the other side. The hydrogen tank. Those two liquid oxygen lines feed two of the SLS engines on the bottom. So you can see the downcomer, and then you can also see right here, that's the forward SRB attachment point right there. And then you can see it over there, just barely. So the SRBs, the front of the SRBs will be right here, the two nose cones. So yeah, we're starting to see some really, really good progress coming out of Michoud. Hey, been looking at the extended Cygnus contract. What are the chances it flies on Neutron? I don't know. When will everything be built for Artemis 2? What? All the parts are built. They just got to put it together. Ryan, seriously. They have all the parts for core stage 1 and 2. SLS's contract right now stipulates a bunch of test articles, a prototype, which is core stage 1, and then a full development baseline configuration in core stage 2. The idea is that you use what you learned when you put core stage 1 together, and it does take a long time. You use what you learned when you put core stage 1 together to write the manual for how you put the rest of the boosters together. And then, once core stage 2 flies, or maybe between now and, Artemis 2, right? That's when you should hit with a block buy, meaning that you buy a bunch of SLS cores. The more we buy in bulk, the more the price would go down, believe it or not. But right now, the contract is for 2 functioning core stages, with the long lead items for a third being made right now. So core stage 3, or CS3 for short, is not on the books officially, but Boeing is hedging their bets that NASA's probably gonna buy more of these core stages to support their lunar programs, and NASA did pay them to get the engines for core stage 3. That's called a long lead item. Long lead items are items in production that take a little bit of a longer lead time to procure. So in rocket science, engines are your long lead items. So we do have parts of core stage 3 being made right now, but they're not on the books officially. There's another reason for that. Another reason why core stage 3 isn't on the books is because Boeing made core stage 3 out of spare parts. Seriously, that's what they're doing. The third core stage, Boeing is not getting paid to make that. What they did was during fabrication testing for SLS, or for Jupiter 4, I should say, for SLS, they had a defective LOX and hydrogen tank, and they're like, okay, this is a defect, make another one. And they kind of put a spare liquid oxygen and a spare liquid hydrogen tank off to the side. And through working on core stage 1 and working on all the functional test articles for the SLS program, all the tanks that they sent up to Michoud to crush in a huge hydraulic press to test tank pressure and whatnot, the huge load cells at Marshall, they figured out ways to actually repair the defect tanks. They figured out ways to repair them, and they're using those spare parts, those spare tanks, to build core stage 3. What happened to the hydrogen tank that they dropped? I'm not sure. NASA's doing the sole source thing again now with CRS-2 for 2025 to 2026. It's not it's a sole source with 3 providers though, so I mean, usually I'm against sole sourcing stuff like that, but also at the same time, Green, why would you pay somebody to develop a new resupply vehicle right now when by the time they have it done, the ISS is going to be gone? Let's go with what we know for now. That I understand that, and I kind of get it. Actually, here's another look at the liquid oxygen tank. See the 2 downcomers on either side? How many SLSs do you think NASA should buy in bulk? Which one would launch Gateway? By the way, Artemis 4 core stuff is underway. They have long lead items on it, Thomas. That aerospace aluminum is stupid expensive, especially when you mix it with lithium, Steven. Yeah, the aluminum lithium that SLS uses is... Does NASA have an ISS replacement in the works? They have a commercial low Earth orbit destination program, Jack. So basically they're going to pay people to come up with new station prototypes for low Earth orbit destinations, and they're going to pay people to launch these laboratories up into space. They also have the Axiom space program. Axiom is actually going to, in 2022, next year, at least that's what we think, next year they're going to add modules, new modules added to the ISS. Believe it or not, the ISS is getting an increase in size. And then when the ISS program ends, whenever that may be, I don't know when that's going to be. When the ISS program ends, they'll detach the Axiom modules and they'll make it, Axiom will be its own station. Commercial low Earth orbit destinations is looking to shift operations of stations toward commercial. I thought it was just in 2024. Well, it seems like we have commercial resupply through 2025, so that should be a pretty good indicator. Or 2026. Here, take a look. Mike Baylor from NASA Space or from Next Space Flight and live stream producer for NSF said that NASA is contemplating a sole source extension to continue to acquire CRS-2 services from January 1st, 2025 to December 31st, 2026. SpaceX, Northrop Grumman, and Sierra Nevada are the current CRS-2 participants for cargo resupply to the space station. An Axiom astronaut was at the last NLS race, the Nuremberg Nürburgring endurance case. Cool. Yeah, a lot of astronauts and a lot of people that like space also like racing cars. Your boy included. I don't know why. The not more in place for Friday, okay? So yeah, we got a lot of SLS news going on here, guys. Core Stage 2 is like, I'd say probably 20 to 30% complete right now. All the parts have been fabricated. They just got to put it together. So the second SLS core stage is going to be done by the end of this year. And I know what people are going to say. People are going to say, SLS is really expensive. And the truth is, you're not wrong. But what people fail to tell you is that the prices for the SLS program, because of government accountability, are what's called TCI, or total cost involved. That means that's the price for everything. Everything. So just keep that into account the next time somebody spouts off and said SLS is going to cost $1 billion per launch. That is the entire price involved, from having a bunch of raw aluminum on the floor all the way through the entire pipeline, all the maintenance to all the facilities, all the integration facilities, all the testing, everything. That's from having raw materials on the floor all the way to vehicle launching off the pad and mission operations. Remember, and don't let anybody tell you anything differently, SLS is TCI. It's total cost involved. You're getting the price tag for the entire program. Now, if you're a commercial company, you don't tell people total cost involved. So, and once again, this isn't a jab at SpaceX. They're a commercial company. Why the hell would they tell you total cost involved? That makes no sense. You tell the price per. So keep in mind that the price points that you hear for a commercial rocket, like Atlas V, like Delta IV, like Falcon 9, like Soyuz, like Progress, like Ariane 5, those are not total cost involved prices, because we're talking about commercial launches here. SLS, by design, is going to cost more by design because it's a big frigging rocket. And also because of government accountability, they have to be transparent about pricing. So there's no shady stuff going on. That's the reason why SLS seems to cost a lot of money. At the end of the day, it's a total cost involved. If it cost $1 billion per SLS launch TCI, yeah, that's actually really frigging good, by the way. Yeah, that's really good. That's actually quite low considering what you're getting. Just thought I'd point that out. That also includes engineering and design, correct? All the research, everything. $1 billion per launch is total cost involved. So that means, like I said, that's the price from having a blank blueprint and raw materials sitting out in front of you all the way through the entire pipeline to launch. And that's a very important thing to understand. NASA isn't as inefficient as people think it is. They're really not. Actually, $1 to $2 billion total cost involved per launch is actually pretty damn good. That's pretty friggin' good. Now, Ryan, in terms of what you're saying, how many should SLS buy? If it was me, and I had control of NASA's purse strings and direction of the program, which that doesn't exist. Congress controls the purse strings. The Senate ratifies the budget, and the executive branch comes up with NASA's goal. All right, so that would be like having two branches of government in one. Just, that's not a thing in real life, unless you're Sergei Korolev, but that's another story. So if it was me, what I would do right now is I'd probably buy 20. I'd say 20. 20 SLS cores, launching 2 times a year over the next 10 years. So actually, if it was me, I'd ramp to 3. I'd do 3 SLS missions and launch an SLS basically every 4 months for the next 10 years. Now, don't get me wrong, the price tag associated with that would be insane. It would be insanely high, but it's important to not get sticker shock from this thing because, yeah, once again, total cost involved. You know, when you buy, if you're a car person, if you buy a project car, you know, even if you got the car for a good price, you need to spend like that. Say you bought a car, like a Porsche, for $5,000, which is unheard of, and that Porsche needs $10,000 worth of work. You didn't buy it for $5,000 to get what you want. You spent 15, right? That's total cost involved. I would want 20 SLS cores over the next 10 years, or 30 over the next 10, launching 3 times a year, 3 times to the gateway, and then also on top of that, I would want SpaceX to demonstrate a lunar lander in 2023, demonstrate an unmanned lunar lander in 2023 with a manned lunar mission in 2024. And then have Starship and SLS work together to move people to and from the lunar surface, basically from 2024 to 2030, 3 times a year. That would be my thing. NASA wouldn't. You know what the crazy thing is? NASA wouldn't need that much of a bump to get that done. I'm not even talking like doubling the budget. If NASA had, let's see. I mean, this isn't how pricing works, but if an SLS launch costs $1 billion, and keep in mind that's $1 billion for launching 2 launches based off of all the research and development that SLS has done. The more you launch, the price goes down. If you buy in bulk with rockets, just like anything else, the price goes down, right? It's the Walmart principle. It applies to rockets. It absolutely does. Keep in mind that the more you launch, the more that price per launch goes down. So let's just say that it doesn't. Let's say that it's fixed. Sure, why not? Say SLS is $1 billion. You want to buy 20 cores, right? So that's $20 billion over the next 10 years. So what is that? $2 billion increase to HEOMD per year? And then that actually goes down over time because you work on a bell curve, right? You'd need a lot of funding to ramp up the factory to get all the long lead items, and then as you launch more and more, the price per launch goes down. So it would be parabolic, and then by the end of the mission, by the end of the 2030s, right? SLS cores would cost, I don't know, $300-400 million a pop, total cost involved. That's part of the reason why Saturn V was so expensive, guys. We launched it, 16, 17 times? So there's Apollo 4, Apollo 6, Apollo 9, Apollo 10, Apollo 11, 12, 13, 14, 15, 16, 17, and then there was Skylab, and then there was a bunch of test articles. So, 14 times? That's the reason why it was so expensive. Because we spent billions of dollars in the 60s engineering this rocket and then only launched it 13 times. If you launch the Saturn V 100 times, TCI price goes down. Saturn V pricing could have gotten reduced to maybe $200 to $300 million a pop. And that's in today's money, and I am napkin mathing this, so just bear with me. After the first 10 years, will we need to buy more cores? Yeah, of course. But by the end of the 2030s, the goals of the space program would change, Ryan. And keep in mind that $2 billion budget increase for NASA wouldn't all go to SLS either. In order to have sustained lunar presence, keep in mind, I'm proposing $2 billion to human exploration operations. So that means money for SpaceX. You know why? They have the sole lander contract. So you're great with a bunch of SLS cores. You ain't getting anywhere near the moon. You need Starship to go with it. And that $2 billion would go to Starship and SLS as well. And I don't know about you guys, but the system that I would want to deliver humans, it might be a little more expensive, but I would want it to make sure that you could get them back in one shot. You don't want to have your way to get into space for lunar missions be compromised, even though your lunar architecture is really good. like having Starship for a lander. You think someone would do that? Have the way to get into low Earth orbit for lunar missions just not be safe? And then have literally landing on the moon be safer than coming back down to Earth? Yes, but still, you could argue that Starship will only cost a few millions of maintenance plus fuel, which is the cheapest part of any rocket. Yes, Wishio, after how many billions of dollars in development? So two things, guys. You know that Starship... Now, Elon Musk says that Starship's going to cost $2 million, as cheap as $2 million a flight, right? Do you know why? Do you know why? Yeah, it's going to cost $2 million a flight after throwing billions of dollars at the program to get it to be that reliable. You get what you freaking pay for. Once again, you guys are comparing price per launch to total cost involved. You can't do that. That's not how that works. You're comparing feet to meters. That's not how that works. That's like saying 100 feet is as long as 100 meters. No, it's about a third as long. That's not how that works. You're comparing on different scales. That's something I don't think people understand. They already made more Starships than they made Saturns. But okay, I'm just gonna pretend I didn't hear that. Hey, Hinks, 14-month resub. You love steak, but you're only pricing the side salad. My man. What up, Church? How you doing? And Sneaky Snake had a 9-month resub in there, and then Mink had a 23 in there, and then Capybara had a 45 in there as well. So, wasn't the Saturn V like $1 billion for just the rocket? Once again, Ryan, that's total cost involved. Ryan, okay, so let me give you another example of what TCI means. You want to buy a new car. Say you want to go buy a smart car, or let's say a Tesla. Let's say a Model 3, all right? Now, keep in mind, Tesla's total cost involved is actually quite low. The reason why is because, well, you don't need to fill it up with gas, but you do need to charge it. Now, if you're charging it at your house, well, now you're roping your electricity bill into your car's maintenance costs, right? Total cost involved isn't just the sticker price for an item. It's all the stuff that you need to do, all the money involved to keep that running for however long you have the car. I'll use like Tesla has a really low TCI, but let's take like my Mustang. All right, we'll take my Ford for instance. All right, the Mustang I have to pay for fuel, I have to pay for oil changes, I have to pay for new brakes, I have to pay for new bushings, new tie rods, over time, new tires. That is TCI over time. And with rockets, you're paying for all the development too. But I'd assume with cars that's taken into account with the sticker price, but that's another story. You have to pay for insurance, yeah. Depending on where you are, you have to pay taxes on the car. You have to pay an excise tax for storing the car. That's total cost involved, guys. That's why SLS's prices seem so steep compared to everything else. So just take that into account when we're talking about TCI. The next time you see somebody spouting off like, oh, SLS is so expensive, well, that tells me that they did about 5 minutes of research and looked at sticker prices on Wikipedia. You know, you don't know what you're talking about. And take it from somebody that's self-taught going into one of the hardest freaking types of industries that I could possibly figure out. Like, I didn't choose to like space, all right? Like, and I'm coming in from the outside looking in. Dude, it is always more complicated than it seems. You know, like, if you do like 2 seconds of critical thinking, SLS looks like it's way more expensive and it's not sustainable. And you look at that and you say, oh yeah, no, that's no good. But if you actually go in and dig and actually do your due diligence and look, it actually makes sense. You know, it makes sense a little bit more than just, oh, SLS is a jobs program. You're comparing TCI to sticker price, which is that's not right. It's not correct. Can't do that way. And if you look at total cost involved, now we'll never know the total cost involved for like Falcon 9 because SpaceX underbids people, which is fine. That's okay. And don't get me wrong, like I'm not defending SLS because of some sympathy thing or out of the goodness of my heart. I want more rockets, not less. With that being said, I'm also a gigantic SpaceX fanboy. I think Elon is absolutely right in saying that, like if I have a criticism of SLS, right, I think it should be reusable. Yeah, that's right. I said it. I think the space shuttle would be better at building out a lunar program right now than a heavy lift rocket. Yeah, you heard it from me. Gateway needs to be assembled. There are lunar programs. The 2 lunar landers, Starship notwithstanding, have to be assembled in space. Oh, geez, it's almost like we had a vehicle that's good at building things in space. I think the shuttle would be a great idea. I think NASA moving away from reusability was a mistake. However, that doesn't necessarily mean that down the road NASA wouldn't go back to it. The reason is because, well, there's this thing in engineering called a diminishing return. Okay? Diminishing returns are nightmare fuel for engineers. Basically, if you put, like, long story short, if you put 100 liters of water in the bucket and you want the bucket to do something, you're never gonna get, like, that 100 liters of water back. You know what I mean? I mean, that's thermo. Well, if you heat it up into steam, you're definitely never getting all of it back. That's thermodynamics for you. It's a real big pain in the butt. It's a really cynical outlook on things, but that's the world, you know. The reason why NASA has moved away from reusability is because the amount of energy that you need to put something useful that has humans going out to the moon, the amount of energy that you need, you have to sack reusability for that. Because now you're not just building a rocket that can get into low Earth orbit. You're building a rocket that can get into low Earth and a half orbits, right? Now what is that? What are you talking about? Well, to get to the moon, you need another 50% of the delta V that you'd use to get into orbit. A lunar rocket needs 150% of the energy that you would need to get into low Earth orbit. So if you need 100% of a rocket to get into low Earth orbit, you need 150% to get to low lunar. All right? So I understand why they sacked reusability for boots on the ground on the moon proverbially. That's a good idea in the short term. But you got to also understand when the SLS program came around, reusable rockets were a myth. Nice, Flykin. Very cool. Rocket Lab somehow overcame that. I still can't believe they're making Electron reusable and not much of a hit on their payload to orbit. Well, Phil, the reason is because that Rocket Lab, because they're using carbon fiber and carbon composite in their rocket, was able to lower the mass fraction where, because the rocket is so small, you can add a parachute to it and it's not that big of a deal. In Kerbal, parachutes don't weigh that much. They don't have that much mass, but in reality, parachutes are really frigging heavy. They're really heavy. That's a lot of mass and a lot of cable and a lot of cloth to pull around with you. But not SLS, but Electron, because it's already super light for what it does, doesn't take that much of a hit, because one parachute on that thing is not screwing your mass fraction too much. Comparatively, because parachutes basically don't scale linearly, they scale exponentially. So Electron in its current form, Phil, needs one parachute. They have one big Apollo-style parachute, right? If you made the rocket twice as big, as Electron, it would not need 2 chutes, it would need 3. And if you made it 4 times as big, it wouldn't need 3 chutes, it would need 9. You see what I'm talking about? It's exponential. So for a small rocket, that makes a lot of sense. But for something like a Saturn V, the chutes would need to be insane, and they would need to be so ridiculously big, and the rigging system would weigh so much that you would end up cutting your payload capacity to orbit in half. Look at Freedom 10 in my program with the reuse stuff versus not with the reuse stuff. It's a big difference. I would really like to see Saturn V's reusability concept tested. Which one, Rocket Guy? The parachutes into the ground, or the parachutes into the water from the back of the rocket, or the flyback booster? I always thought the flyback S1C was a great idea. And I would like to do it in our program eventually, if I can actually launch someone into space reliably for a change. Popping the forward tank dome off and using the natural compression of air in the tank when hitting the water to act as a gigantic shock absorber. Agreed. Agreed. Great idea, actually. I mean, flyback, you're taking a huge hit to your mass fraction. Now, for the people that don't understand, what the heck is mass fraction? Well, that's what's called dry mass versus wet mass, or initial mass and final mass. So, how much your rocket weighs with a full tank of gas versus how much your rocket weighs with nothing in it, with no fuel in it, all right? So, that's the fraction there. So, how much of your rocket is fuel and how much of your rocket is rocket? In the delta V equation, your mass fraction is very, very, very important. It works on a logarithmic scale. Okay, so what does that mean? In plain English? The more fuel you have on your rocket, the less rocket you have on your rocket, the further you're going to go. Simple as that. If you can achieve a higher mass fraction, your rocket will have more delta V. But the problem is that if you start adding stuff like wings to your rocket, or a body flap, or a gigantic payload bay, or room for 7 astronauts, for instance, you're increasing your mass fraction, thereby decreasing delta V. And that doesn't necessarily mean you're decreasing energy, right? The space shuttle has enough thrust at liftoff to be on par with like N1, Saturn V, the Buran Energia. It has enough energy. It exposes enough energy as a heavy lifter does, right? But it doesn't get any further than low Earth orbit because you're taking up all that extra stuff. You're taking up all the wings. You're taking up all the extra rocket engines, the body flap, all the wings, all the tiles, all that other stuff. All those stuff to keep those stupid meat bags alive inside of it, right? So you gotta be like this. This is what I mean. Like with Electron, because the thing is so ridiculously light and so ridiculously small, you could put a parachute on it. Doesn't really make a difference. But with something bigger, like a first stage, or like a Saturn V first stage, parachutes become a diminishing return. You would need like 100 parachutes to get the Saturn V first stage to come down at a reasonable speed so it doesn't destroy itself when it hits the water, for instance. Rocket Guy talked about a different way to do that. You know? Saturn IX. Yeah, I wish. What was the Saturn V total cost involved adjusted for inflation? I'd have to go look at the numbers offhand, Ryan, but because we launched it so low, it's an exorbitantly high price. Savage Grab Shark. Starship doesn't care about mass fraction. Well, see, Starship is going down the same path as the space shuttle. The reason is because if you make it out of simpler materials that are not as exotic, like stainless steel, for instance, if you're making it out of simpler materials and you make it absurdly reliable and it can go to space like basically 2 to 3 times a day like an airplane, you can theoretically, it doesn't matter how much mass you can move to space, because over time you'll just end up moving more mass than everybody else into space. That's why Starship is built the way that it is. That's why it's so ridiculously big, and that's also the reason why Elon chose to make it out of stainless steel, right? Dang it, Streams keeps pausing at the worst facial expression moments. Well, here, let me just fix that. There you go. It's like 200 billion, I think, for total program costs involved for all launches and development. Those numbers are somewhat old. 200 billion sounds about right, Rocket. Considering we didn't know how to do it before, I'll take 200 billion. Name another industry that's figuratively and literally got off the ground for 200 billion and accomplished so much in so little time like the Apollo program did. There's frankly no industry like that. From 1962 to 1970, the change in capability and the change to society and the changes of how we go about doing things, from the Apollo program, there's been no other progress period in human history where so much has been done with so little. It's really ridiculous, actually. Anyway, so yeah, I mean, the whole moral of the story here is that Starship is not a bad idea to go about looking at this problem, and SLS, believe it or not, despite it being expendable, is also not a bad way to go about looking at this problem. You know how you get around the SLS heavy cost is you launch more of it, just like what we did with the Saturn V, but where the Saturn V failed after, well, not failed, but where the Apollo program was capped after like 15 launches, if we do 20, 30, 40, 50 SLS launches, that price goes down over time. It goes way down. You could 10 years down the road, if we launch 30 SLS cores, the price could be as cheap as a Falcon Heavy if you launch a lot of them. And another thing to take into account, guys, is that building a bigger rocket, your cost doesn't scale linearly. Your cost scales exponentially again. So what does that mean? If you want to build a rocket that moves 10 tons into space, okay? Say that costs $500 million to make. We're talking about $500 million for the whole project. So you start with $500 million, and then on the other end, you have $0 left, and you have a rocket that can move 10 tons into space, right? If you want to move 20 tons into space, that price is not going to be $1 billion. That price is going to be $2 billion. Okay? Now, that rocket that moves 10 tons, say you want to shift it and you want to move 40 tons into space. You think it's going to cost 4 times as much? Nope. It'll cost 9 times as much. And keep in mind, my scales are made up. But that's the gist of it. 50 SLS launches, that's optimistic. Kem, if I had it my way, I'd do that. Seriously. Kem, if I had it my way, I would not only pay for those, I would pay for SpaceX's launches, and then I would also go over to Dimitri and be like, hey, come to the moon with us. And he'd be like, no, I don't want to. And I'd be like, I'll pay you $10 billion to launch modules on Angara over the next 10 years. And he'd be like, okay, that's a deal. China? Who's that? Capability is capability, man. I don't care who has it. He'd be like, I'm not going with you. I'll be like, I'll pay you $10 billion. You launch 20 Angara rockets on me with a bunch of FGBs that we dump out around the moon. Now do you want to go? He'd be like, Da. Это хорошо. Da. Money talks, man. But that's if I had my way. I'm sure if I had my way, we'd just have some weird, like, 1984 spaceflight empire thing going on. It probably wouldn't be healthy. So we're calling Rogozin? I wish we would, Steven. I wish someone would man up. I wish someone would man up and throw the Russians a friggin' bone here. I mean, we're the ones that decided to use their capsules for 10 years to get to the ISS. I wish somebody would throw them a friggin' bone for Christ's sake. Anyway. No. Big Rocket Corporation. Yes. Gotta stop Big Rocket. No. 50 SLS launches in total over the next 10 years. It was a hypothetical number, Ryan. It was a hypothetical. Money speaks, Lewis Hamilton. Hey, Cloudy, Lewis is a lot of things. He ain't stupid. He's one of the smartest freaking people around. And you could sit here and say, it's just a Formula One. Okay, sure. All right, yeah. Yeah, he's really stupid. He's crying all the way to the bank, guys. And I don't like Lewis Hamilton, for what it's worth. I'm a salty Ferrari fan. I can't stand that guy. I've hated him since 2008, man. Friggin' Glock. Ugh. Oh, God, it hurts. It still hurts. It still hurts. It still hurts. It still hurts. Help. Damn you, Lewis. You son of a bitch. Anyway. I'm a suffering McLaren fan. Oh, I see you too have decided to share in the pain of failure. Do you know any cool stories about Michael Collins? Absolutely. I could tell you about it if you want. So, on a little bit more of a somber note, guys, we lost Michael Collins today. Michael Collins was the command module pilot on the Apollo 11 mission. Where Neil and Buzz went down to the moon, Mike stayed up on the command module in orbit and watched over them while they were down on the surface of the moon. Mike was also on a Gemini mission with John Young. I think it was Gemini 10. It was Gemini 10 or Gemini 12. It was one of the later Gemini missions, right? I said Gemini and Gemini in the same sentence. Nice. Now, a cool story, Hydro, that not a lot of people know is that during the Gemini mission with Michael Collins, the Agena target vehicle, the fairing on the Agena target vehicle, which housed the docking port, didn't deploy correctly. Here, I'll show you. So, everybody knows about Apollo 11, but not a lot of folks know about Gemini 10. Gemini 10 was one of the ballsiest EVAs up until that point. The only times I can think EVAs were more crazy is the Solar Maximum repair mission or the deep space EVAs that were done on on Apollo 17. Now, this doesn't look like that crazy of a thing, right? But what happened is Gemini went up there, and the Agena target vehicle's fairing didn't deploy. The Agena target vehicle's fairing did not deploy. And they went and they freaking Michael Collins. You should see the here. I wonder if they talk about it in here in the wiki part. Which one was it? Was it Gemini 9A? No, maybe 11. No, 12? See, I forget which one now. Nope. I think it was 10, was it? Yeah, okay, I did click on it. It was the right one. Sorry, I can't read. So, check this out. Gemini 10 was designed to achieve rendezvous and docking with the Agena target vehicle and extravehicular activity. It was also planned to dock with the ATV from the Gemini 8 mission. This Agena's battery power had failed months earlier, and an approach and docking would demonstrate the ability to rendezvous with a passive object. It would also be the first mission to fire the Agena's own rocket, allowing them to reach higher orbits. Gemini 10 established that radiation at high altitude was not a problem. After docking with the Agena booster in orbit, Young and Collins used it to climb temporarily to 412 nautical miles, about 763 kilometers. That's almost twice the height of the ISS. After leaving the first Agena, they rendezvoused with the derelict Agena from the aborted Gemini 8 flight, thus executing the program's first double rendezvous. With no electricity on board the second Agena, the rendezvous was accomplished with eyes only, no radar. It's one of the reasons why I love John Young, because he's crazy. Michael Collins is crazy too. Listen to this. After the rendezvous, Michael Collins spacewalked over to the dormant Agena at the end of a 50-foot tether, making him the first person to meet another spacecraft on orbit. Collins then retrieved a cosmic dust collecting panel from the side of the Agena as he was concentrating on keeping his tether clear of Gemini and Agena. Collins' Hasselblad camera worked itself free and drifted away, so he was unable to take photographs during the spacewalk. Guy went over to the Gemini 8 Agena and took parts off of it from an EVA. The Gemini 8 Agena target vehicle didn't have its fairing deploy. So he went over there to a busted up spacecraft with no fairing, and he went and took parts off of it. Did the first spacecraft to spacecraft EVA. I don't think that ever had been done before, except for Gemini 6 and 7, but that was craft to craft, you know? How do they use to fly? Compressed air. EVA, you guys ever seen WALL-E? The end of WALL-E with the fire extinguisher? Yeah, that's how they EVA during the Gemini program. Yeah, they gave him a little squirt gun with compressed air, like the kind of gun that you'd use to shoot compressed air at your keyboard. Yeah, that was how they EVA'd during the Gemini program. And if I'm remembering correctly, with the Vostok program as well. Yeah, Kem, it's pretty ballsy, man. These are ballsy freaking missions. There's got to be more pictures, but let me go look around. Let's take a look. Because I know the fairing didn't deploy on this sucker. He had to go and like mess with the fairing, if I'm remembering correctly. There may have been a different mission. I could be. I mean, guys, you got to remember, I'm recalling this off the top of my head. Yeah, look. Oops. They're still tethered, right? Yeah, the Gemini suits didn't have. They weren't extravehicular mobility units, Swishio. They didn't have that figured out yet. Dude, here, I'll show you. You know how you went outside with the Gemini during, you know how you EVA'd? So first of all, there's no airlock on the Gemini capsule. So you had to depress the entire capsule. Second of all, you go outside with a freaking can of compressed air and then an air line that's connected to the spacecraft. That's how you EVA'd. Now, this is Gemini 4. That's Ed White. That's not Michael Collins. Ed White was the first American to do an EVA, the second person to do an EVA behind Alexei Leonov. Leonov was the first one to do an EVA. I think that was Voskhod 1, if I'm remembering right. Yep, here, have a can of compressed air with a nozzle and then a tether line. Talk about ballsy. Look behind him. You gotta be kidding me. So this was taken by, who went up with Ed White on 4, I forget. Yeah, you've seen this picture. This picture, they like using this picture on synthwave album covers and whatnot. Crazy picture. Yeah, the Gemini capsule was a T-top. Yeah, him and Jim McDivitt. There you go. That's how the Gemini opened. It has a T-top, like basically the reverse of gull wing doors on a DeLorean. That'd make a really good album cover. People have used this for an album cover before, Judo. I'm positive. I've seen it on synthwave album covers and stuff. It's a freaking Banff picture, dude. Look at that thing. So, you know, Hydro, tell you a story about Michael Collins. Michael Collins had, I mean, I don't know how, you know, as an old man, how he could walk around toting around some freaking brass cojones, man. There's your story. Yeah, crazy. One of the craziest EVAs, dude. Did you guys hear what that Gemini mission did? They rendezvoused with their own Agena. And then they boosted up to 800, an 800-kilometer orbit. You got to be kidding me. That's skirting the Van Allen belts. You're nuts. And then proceeded to EVA out there. And take parts off of a broken spacecraft and then come back down. Yeah, he must have needed a friggin' wheelbarrow. So, I mean, that's a story about Mike that I don't think a lot of folks know about. And just shameless call for the Gemini missions as well. The Gemini missions were insane. Friggin' sane. Without those Gemini missions, we don't go to the moon. It's as simple as that. Yeah, pretty much go suck. Yep. Here, have a can of compressed air and an airline. Go outside. What? I mean, Leonov was the same way. Alexei Leonov, when he did his EVA, he just went outside with a tether. Now, keep in mind, the Vostok spacecraft did have an airlock, but it was an inflatable air tank. That part is in KSP, that expandable airlock. That's what it was from. Nice. Nice, Forge. So, yeah, it's... You know, unfortunately, we lost Mike today. But, you know, hey, look, guy went out to the moon. He's one of like 20, let's see. There's Apollo 8, there's Apollo 10, there's 11, there's 12, 13, 14, 15, 16, and 17. So, 9 times 3. One of 27 guys that got to leave low Earth orbit. Well, it's a little less than that because of Gene Cernan, John Young, and Jim Lovell. So, 25. 24, I can't do math. Those are the 3 people that have been out of low Earth orbit 2 times. Well, Fred Hayes? No, Fred Hayes once, but that's another story. That's Mike. I mean, dude, he lived a freaking long life. Like, you know, I want to sit here and get sad, but I'm not going to get sad. You know, you can't beat Father Time. You just can't. You're not going to. Don't even try. Well, some people are trying. But, you know, I don't generally get upset when people die of old age. I don't. I don't get upset about that. I celebrate what they've done and their accomplishments, especially when we lose an astronaut or a cosmonaut. I was not happy when Alexei Leonov died. I didn't even know he was alive until like a year before he passed. Alexei Leonov was the first person to step out of a spacecraft. And he died a couple of years ago. I like to celebrate what they did. People die of old age all the time. That happens. Mike was old and he was fighting cancer. And I'll bet you cancer is a little tired after this time around. He probably put up one hell of a fight. if I had to guess, he probably put up one hell of a fight. Kansas probably like, oh God, that was a hard one. Jeez, you know. But, you know, he unfortunately passed today and he's off to another mission. Yep. We have 10 Apollo astronauts left. Godspeed, sir. I wish you the happy trails on the next mission that you're flying, wherever that may be. It was a shame for Jim Lovell. He essentially did the same mission twice. I mean, you know, you can't take away from Jim, Frank, or Bill that they were the first people outside of low Earth orbit, Tessa. That's pretty freaking cool. Ad Astra, sir. So, yeah, it sucks that we lost them, but hey, when people die old, you celebrate what they did. What bothers me is when people die when they're young. That sucks. Because you never get to see what could have been. You never get to see someone to get to their maximum potential. Mike, I'd say, probably got to his maximum potential and then some. So, happy trails, and I wish you the best. All right. Next news. Let's see what we got. Let's go see what's going on. Let's see what's going on over in Russia here. We got some Russian news coming up here. And then I mean, we're kind of all fragmented all around because we talked about what was going on, you know, with SLS and stuff, and then we talked about total cost involved and whatnot. But we'll keep going here. I think I got everything here. He could have been on Apollo 17 if he didn't retire early. Hey man, once to the moon is enough. Hey, I mean, Neil did what he needed to do. He accomplished his goals, and he was like, yeah, I'm done. Hey, you know, guys, this takes an impeccable amount of discipline. It takes an impeccable amount of training and time to go to the moon. Look at how long it's taking the Artemis program to kind of really gain some steam. It is gaining steam. It's just slow. This stuff takes time. It's very taxing on astronauts. We shouldn't forget that. Something close was done by Soyuz that docked to Mir and then Salyut 7 and then back to Mir. Yeah, that's right, Kem. The Soviet Union and the Russians did that in the 80s. Awesome mission. I mean, the whole Salyut 7 mission is ballsy as hell. It's about as ballsy as that. For the people that don't know, the Salyut 7 or Salyut 7 mission in 1985 is where two guys with a bunch of repair parts went and docked to the unpowered and abandoned Salyut 7 space station. And unlike what Mike did, Mike just EVA'd and took some parts off of the thing and then brought it back. And then, you know, it was a broken fairing, so, you know, there's not much you could do with it. The guys at Salyut 7, there was only two of them. They launched and they manually docked to Salyut with a Soyuz using the damn periscope. And then on top of that, they they equalized the pressure in the space in the space station module, went inside and fixed it. They fixed Salyut 7 on orbit. And I'm talking about a module that is completely not completely depressurized. It was still holding pressure, but completely unpowered. No power, nothing. They plugged the Soyuz into it and charged its batteries that way and then fixed it. Now, I don't think I need to say how frigging dangerous that actually is. Now, think about it like this. All it's going to take is one short circuit, one spark in the wrong spot, the whole thing pops like a balloon. The Russians sent up two cosmonauts and they went up there and they fixed a broken space station like that was completely offline. They fixed Salyut 7 and then they took parts off of it and went to Mir and then went back to Salyut 7 and then came back down. It is one of the ballsiest missions that the Soviet Union ever ran. What was wrong with it? It malfunctioned. It ran out of power. It had some kind of short on it somewhere, if I'm remembering correct racing. But the Soviet Union, believe it or not, they were worried that the Americans were going to go and get it with the space shuttle. A Salyut module can fit inside of the space shuttle's payload bay with some adaptations to it. They were worried that the Americans were going to steal their space station module. So they sent up two guys to go and fix it. Which is Nuts. You think the movie does it justice? That's good enough. But yeah, Bill, great movie. I heard NASA only has 4 operational extravehicular mobility units left. Are there any plans for a replacement? They're working on it, Ryan. I don't know the exact details, but I know they are working on it. And he got to visit the Soviet Union in the middle of the Cold War. Yeah, that's right. I mean, a lot of folks, you guys, like, people think, the space race was, us versus them, they're evil. Yuri Gagarin toured the world. So did the Apollo 11 crew. Yuri came to the United States. The Apollo 11 crew went to the Soviet Union and walked around Red Square. It's like, They did. They went on international tours. The space program has always been something that everybody can get behind, man. Yeah, Kim. I always thought that was funny. In the real mission they docked on the first try. In the movie they did it a couple of times. Sometimes spaceflight is so unbelievable that if they make a movie about it, they have to like hype it up because people wouldn't believe it. People wouldn't believe it. Like Apollo 13, for instance. Tom Hanks, they stir the tanks and he's like, "Oh no, Houston, we've had a problem. This is terrible. Something's wrong. If you go listen to the exact communications that Jim Lovell said, they go, "All right, stir the tanks." And then you hear a pfft, just like it sounds like that, only with some crackling over it, like pfft, right? And then you hear Jim go, "Guys, I think we're leaking something. Houston, we've had a problem here. The spacecraft is leaking something out the back. I'm looking out the window. It's leaking. Yeah, that's probably not good. You should probably figure that one out. We've had a problem. Main bus undervolt. Yep. Yeah, they had to spice up Apollo 13 because if they just told the story, people wouldn't believe it. It's true. Speaking of ballsy missions, I am dreaming of a SpaceX cargo starship going up and bringing back down Hubble. I wish. I think a regular starship should do that, Kyron. SpaceX is going to use the money from the lunar lander to work on airlock technology. So Starship, the crew version with an airlock and a payload bay. So how I'm envisioning this, dudes, right? How crazy would this be? You have a Starship, right? Yeah. All right, here, let's do this. Right? Right, you have a Starship like this, right? I need the eraser. Thank you. Yeah, that nose cone's a little weird. It's not pointy enough. Right? And then you have your back wings, right? Please excuse the crudity of this model. I didn't have time to build it to scale or to paint it. Right? And then you have your methane tank, you have your oxidizer tank, you have that, you have your 3 rocket engines back here, and et cetera, right? With your cargo or whatever it's carrying, right? This is my Starship model, right? I know you guys love it, right? That's good enough. So, right? How about like right here on the Starship, right there, you have a payload bay. So we're talking... Let me just get rid of that so you can see the wing a little bit better. Right here, how about a Starship that has a payload bay, space shuttle style? Like that. And they take Hubble, right? You could take Hubble and you could either service it. You could put the Hubble right here. I don't think it would fit this way. Or if you have the chomper, right? Right, you have the chomper version like this, right? Yeah, it could open up and you could put the Hubble in that way if you really wanted to. It has a grapple fixture, but see, the way I'm thinking about this, you'd need a starship that has a payload bay and an airlock. So you'd either need you would need a crew and an uncrewed starship to do this. So you'd need to send up 2. There's no way one could do it by itself. How do you make a photorealistic render in so little time? I went to art school, Swishio. I know how to draw. I'm pretty good at it. Or Starship plus Dragon. I'm wondering if Hubble could even survive. The flip and burn would definitely break the mirrors, that's for sure, Rocket. It was never designed to do something like that, but then again, I suppose if it could survive the re-entry of a shuttle re-entering this way, you know what I mean? Maybe. But I'd assume we'd bring it back down and, you know, it would be inoperable either way. If we're bringing it back down, it would need maintenance of some type, which means it's already broken either way. So, like, how about a Starship variant that has, like, a gigantic payload bay in it and then a spot for people up in the front? Right? Like, something like this. Something like that, and then you could fit you'd have to like fold back the solar panels or something, but you could fit Hubble in there and then it just comes back down. Like basically take the front of a space shuttle and put it on Starship. They would never do it. SpaceX would never do that. That's way too complicated, but then again, you never know. They could secure it on orbit, stuff it with packing tape. Yep. A surfacing mission could remove the mirror, yeah, I suppose. But anyway, yeah, I mean, I think you guys aren't thinking about this enough. You know what I want? So, Discovery is sitting at the Smithsonian. I've talked about this before. Discovery is sitting at the Udvar-Hazy Center, the Dulles Annex for the Smithsonian, who Michael Collins kind of overseed. A lot of people don't know that. Michael Collins he was like the curator for the Air and Space Museum. Not the curator, I forget what his job title was, but he had a lot to do with it. The mirror shouldn't break. It has a honeycomb support structure. Oh, well, good to know. I don't want to know how you know that. Anyway, Discovery is sitting at the Udvar-Hazy Center with a TDRS satellite over it, a replica of a tracking data and relay satellite. Because the shuttle launched a lot of TDRS sats up into space, right? The NASA's communication satellites that they still use to this day. How about we have the ISS floating over it? And then how about we have Discovery docked to the ISS with its payload bay doors open, floating next to the ISS, with the Hubble Space Telescope below that. And Starship could bring that all down. The heck with deorbiting the ISS. Let's bring that sucker back down with Starship. You know, we could sit here and say, like, well, that's going to be too expensive. They'd never do that. Well, with Elon's price points per launch, why not? It'd be some pretty good. You get some pretty good material analysis on something that's been up there for 20 years. We could certainly learn a lot about how spacecraft survive long term in space. I'd think, don't you think? That might be a pretty good science mission to do. Just my 2 cents. I don't want the Hubble Space Telescope. I want the entire station and the Hubble. I think Starship can do it, if you really want my honest opinion. And it belongs in a museum. Yep. Or at least one module. One module would be nice, Joe. But you know what my old man told me? My old man told me the only thing better than one module is 2 modules. You know what the only thing better than 2 modules is? 3 modules. You know what the only thing better than 3 is? 5. All of them. You make that money back in no time at all. Yep. Put it in an exhibit at Kennedy and charge a small fee. Nah. It's like my old man told me one time, Lee, the only thing better than 1 crawfish dinner is 5 crawfish dinners. Anyway, let's keep going. Space news. I mean, the only thing would be, I don't know how we would get Zarya and Zvezda back. Personally, if you want my honest opinion, we should take Zarya and Zvezda and we should give them back to the Russians. Give them back to the Russians for them to put in a museum. And then put mock-ups next to the space station. That's fine. We'll take the mock-ups. I mean, we own Zarya, but it'd be a good thing to do. This is a long space news. Yeah, it's alright. Trying to get back into the groove, Shaw, because Monday screwed me up. You could charge for tours through the ISS. I could see that being super cool. Congress wouldn't fund this. If we convince them that it's worthwhile, they will. Of course they will. Okay, more HLS stuff. I'm sure that's good news to cover. Thank you. Can we add this while we're looking at Russian stuff? Sure. Alright, we'll jump right in. Russian news. Let's go. So, construction of the National Space Center to the new Khrunichev Center rocket plant in Philly, Moscow. Philly? It's in Philadelphia? No, right, anyway. New metro station, bridges over the Moscow River, and then a usable area of 250,000 square meters. Workplaces for 20,000 engineers and designers of Roscosmos will be completed in 2022. All right, let's see what we got. Yeah, this is next to Khrunichev. See the factory right there? Twitter, learn to balance audio, please. So, Khrunichev is where they make Soyuz parts, and they make Angara's third stage there as well. See that right there? They were going to make Angara there, but they decided to build this there, and they couldn't scale the factory correctly. That's the assembly line for Soyuz right there. See that? That building. So Roscosmos is building a new space center there, like a brand new space center. This was an abandoned lot, and they're building a new new headquarters for Roscosmos in Moscow, which is pretty cool. Pretty neat. Now, let's see what else do we got here. This is another tweet coming from Dmitry Rogozin. Huh, okay. Less than an hour before the start, there's a planned evacuation of the combat crew for starters. So, yeah, we got some good pictures of the Vostochny Cosmodrome launch site for Soyuz. Soyuz did launch a OneWeb. Another one had a OneWeb launch the other day. These are just really nice pictures. Speaking of new facilities, is SpaceX moving or expanding? Yeah, Boca Chica. They're expanding at Boca Chica. SpaceX pretty much owns all the buildings on Jack Northrop Avenue and Hawthorne. They took all that over for the most part. They also just leased a berthing port in Port of Long Beach, but I'll talk more about that later. No, I meant in California. Yeah, Jack Northrop Avenue is in California. Yes, that's Hawthorne. Why put the ISS in an Earth museum? Why not make it part of humanity's first museum in space? Because that's expensive. What about in Austin? Well, that's Tesla, Astro. That would be Tesla. The super gigafactory in Austin is Tesla, not SpaceX. There is a Starlink launch in a little bit. We have Vega. We have another Soyuz. And wait. We have 3 launches tonight. We have Vega. Hang on. I got to go to rocketlaunch.live. Vega's return to flight is now, and then there's Tianhe, and then there's Falcon 9. Yeah, there you go. That's your 3. Soyuz already launched. Yeah, I just said that Soyuz launched yesterday. I honestly, this isn't a bad problem to have. I'm literally losing track of the launches. But we do have a launch tonight. Let's see. Okay, what else do we have here? Ooh, what's this? They're testing an RD-0124 MV. RD-0124 So this is a static fire test, and it will be used on the Soyuz 5 carrier rocket. Cycling a firing test on a standard liquid propellant rocket engine chamber has been successfully completed in Vorozhne. The RD-0124MV, or MS, excuse me, not MV. It runs on liquid oxygen and naphthyl propellants and is intended for use in the launch vehicle of Soyuz 5. Naphthalene is an organic compound with a formula of C10H8. So that's RP1. That's a hydrocarbon, is it not? Am I looking at this? I mean, it's been a while since chemistry. When is Crew 1 undocking? Saturday. They'll be back on Saturday. They're undocking on Friday. Okay. So, if you want kerosene. Well, at least we got a picture of it, man. I wish they'd stream this. It's much lighter than RP1. It's close to gasoline. It's basically turpentine. Interesting. John Snofzer is the owner of the GITS VT and also training for Axiom 1. Cool. Neat. Alright, so we also got a video here. Space Wednesday, Baitarek and the Soyuz 5, new space station in the Vostochny Cosmodrome. Alright, let's see what we got here.
А также предложение по его дальнейшей реализации.
Готовность систем стартового комплекса выдана 55.
So this is the
26 апреля с космодрома
OneWeb
Восточный с
launch.
помощью ракеты-носителя «Союз-2-1Б» и разгонного блока «Фрегат» выведены 36 космических аппаратов компании OneWeb.
So he just said that from the Vostochny Cosmodrome, a Soyuz 2-1B with a Fregat upper stage with the launch satellites for the company OneWeb. This was from the other day.
Строительное отделение 9 групп спутников от российского разгонного блока прошло штатно в соответствии с заложенной циклограммой полета. Весь процесс выведения спутников фрегатом осуществлялся автономно, без вмешательства Земли.
The Fregat upper stage automatically put the satellites into the different orbits. Is that what I heard?
Спутники уже на своих орбитах и взяты под управление заказчиком. Данный пуск стал 6-м в рамках пусковой кампании OneWeb и 8-й с космодрома Восточный. Спутники OneWeb предназначены для создания космической системы связи, обеспечивающей предоставление...
He's talking about the OneWeb satellites, what they do, basically.
Высокоскоростного доступа в интернет в любой точке Земли. После состоявшегося запуска группировка OneWeb насчитывает 182 спутника на низкой околоземной орбите.
What was that last part? Oh, I didn't get it.
Точный. Спутники OneWeb предназначены для создания космической системы связи.
I need to translate that part. I didn't get it. OneWeb satellites are designed to create a space-based communication system. I got that part. That are providing high-speed internet access anywhere on Earth. After the launch, the OneWeb constellation has 182 satellites in low Earth orbit. Okay. Yeah, I didn't get the last part. The 182 sat part confused me, Vasya. I was like, I don't know. Yep. No, I don't know what that means. Okay.
3 апреля 2021 года на базе ракетно-космического центра «Прогресс»
On April 23rd,
заседание Координационного совета по
it
реализации
says what it says
российско-казахстанского проекта «Байтерек» с участием генерального директора госкорпорации «Роскосмос» Дмитрия Рогозина и министра цифрового развития, инноваций и аэрокосмической промышленности Республики Казахстан Багдата Мусина. Стороны обсудили текущее состояние работ по проекту, а также
Alright, 2020.
предложения по его дальнейшей реализации.
Algebra.
Весь эскизный проект и детали стартового комплекса будут утверждены
Soyuz
1
5 parts.
июля этого года.
Для казахстанской стороны немаловажно, чтобы это был экономически выгодный проект, потому что это наш первый стартовый комплекс, который
This is
действительно мы
Baghdad
вкладываемся как
Musin.
бы от А до
Is
Я
he from
в
Kazakhstan? No, he actually is. He's
И
Kazaki.
Это очень важно для Байконура самого. Байтерек — это основа, наверное, вот будущего Байконура.
Can I back up a little bit?
Текущее состояние работ по проекту, а также предложения по его дальнейшей реализации. Весь эскизный проект и детали стартового комплекса будут утверждены к 1 июля этого года.
Для
I'll check it out in a
казахстанской
second,
стороны
Steven.
немаловажно, чтобы это был экономически выгодный проект, потому что это наш первый стартовый комплекс, который действительно мы вкладываемся как бы от А до Я в инфраструктуру, и этого очень
Yeah, see, Baghdad knows. So Baghdad's Kazaki, and if you don't know, Baikonur and what they keep calling Baytarek is like the big Russian space center. It's actually in Kazakhstan, and Russia rents like it has an indeterminate lease on that area, so it's leased from Kazakhstan after, and it's been that way since pretty much the fall of the Soviet Union. What Baghdad is talking about is that how he basically wants Roscosmos to keep investing in pads because that brings money to Kazakhstan. So, yep, I understand that. Why I wanted to stop it is because what we're looking at right here, that is a Zenit pad. So the Zenit rocket was the Zenit rocket started as a Soyuz, or not Soyuz. It is a Buran Energia side booster.
Hey, babe.
Yeah.
There's a box here for you, and it's really heavy. Is it my 3rd birthday gift?
I don't know.
Okay.
Really heavy box.
I'll open it.
Huh. Okay. Baytarek is the name for the Soyuz 5 pad. Kazakhstan will invest money into the pad, not Roscosmos. Cool. So the Zenit rocket started as Buran Energia side boosters and then became its own rocket. The Zenit rocket, it would be like if we took a shuttle solid rocket booster and made it into its own rocket, like Ares 1, for instance.
I'm gonna take it as a no.
No,
not
that's
my-
not for you. I'll have to check on when your other present is coming in, unless you want some 16 gauge wire.
I think I'm good.
You sure?
Yeah. I just thought it was funny.
I bought a lot of spools of wire, so we can finish the wire harness on the truck. Sorry, babe.
It's alright.
Unless you want wire, in
I'm
which
good.
case, happy birthday!
I'm all good. Love you, baby.
Love you too. I ordered her birthday present. I ordered it like a week and a half ago. Half of it came, well, not half of it, 2/3 of it came in. We're waiting on the last friggin' part of it. It's 3 separate presents, so it's not that big of a deal. I ordered it a friggin' week and a half ago. I ordered that damn wire, so that it's a care package. It has a bunch of wire harness stuff in it for the truck, right? I ordered that last night. I ordered that less than 24 hours ago. You telling me Amazon can get some friggin' wire here quicker than whatever her present is? Believe me, whatever her present is, I'm not gonna say what it is, but whatever her damn present is, it is not as obscure as buying a couple of spools of 16 gauge friggin' wire. This is ridiculous. I did Prime Deliver it, man. I'm a Twitch streamer. I have like Prime Plus or Prime Preferred or whatever the hell it's called. The frick? It wasn't as obscure as that. Jeff, what the hell, man? No, it's fine. It's fine. It's just really awkward that stuff for me came in before her birthday present. You know, that's great. I'm sure that won't come back to haunt me later. Oh. Anyway.
неважно для Байконура самого. Байтерек — это основа, наверное.
So that's the Zenit pad that they're looking to convert for Soyuz 5.
Совершенно будет как бы новое оборудование применено.
It's
и
more
новые
expensive,
ракеты
Ryan.
будут оттуда взлетать.
Байтерек – ракетно-космический комплекс на космодроме
Yeah, you
Байконур,
don't care. Of course
совместный
you don't
проект России и Казахстана. Главная его особенность — использование в
That's
качестве
cool, man. Look down the flame trench. Cool.
основной ракеты-носителя новый «Союз-5», которую и разрабатывают в РКЦ
New
«Прогресс».
Soyuz 5 rocket.
Генеральный директор предприятия Дмитрий Баранов
Dmitry
продемонстрировал
Baronov
делегации, как
demonstrated to
идет
the delegation how the
создание
creation of a
перспективной
promising
ракеты.
rocket is
В
proceeding.
настоящее время практически завершено изготовление опытного образца для проведения динамических испытаний. Изготовлен бак для статических испытаний. Созданы хвостовой, верхний и
Freaking look at Dmitry.
изготовление
Guy's a
опытного
freaking
образца
chunker.
для
Look at him
проведения
compared to all these other
динамических
dudes.
испытаний. Изготовлен бак
There's
для
pictures of
статических
Soyuz 5.
испытаний.
Look, what the hell? Oh, he's walking on a step. I was like, how does what's going on over there? The guy is on a step. Oh, Dmitry is that kid. He was that kid that when you're walking around on like field trips, walks up on the yeah. Okay, all right, Dmitry, you're not fooling nobody. I'm telling my kids that's Dmitry and his son.
испытаний. Созданы хвостовой, верхний и межбаковые отсеки блока первой ступени.
So these are
также
Soyuz
головной
5 parts here.
обтекатель будущего носителя.
Ракета «Союз-5», я вижу ее большое будущее. Ну, во-первых, она использует уникальный двигатель, который мы практически сейчас провели его все.
Carried out all 8 burn-throughs of fire tests from Kamiki near Moscow. What the frick, dude?
Самый мощный жидкостной.
Holy shnikes, look at... Oh, I shouldn't show this. This is not safe for work. Look at that, an RD-171MV. So, guys, you're looking at the most powerful liquid fuel rocket engine ever devised by man right there. That thing here, I'll show you. The 171MV is a derivative of the famous RD-170. So, the RD-170 was what they used on Buran Energia. Check these numbers. Sea level thrust. 7,200 kilonewtons of thrust. In vacuum, almost 8,000 kilonewtons of thrust. That's 1.6 million pounds, or in vacuum, almost 1.8 million pounds of thrust. That's insane. That's approaching. It's more powerful than an F1 by about 100,000 pounds of thrust, or about, I don't know, 1,000 kilonewtons, give or take. And the only rocket engines that are more powerful than that are the Space Shuttle and SLS's SRBs. That's it. The RD-171 is the most powerful liquid fuel rocket engine and the third most powerful rocket engine ever flown. Yeah. Fourth most powerful rocket engine ever devised. So the only things that are more powerful than the 171 are the Castor 260, the 5-segment solid rocket booster, and the 4-segment solid rocket booster on SLS and the Space Shuttle. Those are the only things that are more powerful. In terms of liquid fuel, it's the most powerful rocket engine. And you could see it wiggling for you. It's wiggling for you. Guys, did you see it? It's happy to see you.
Химках это РД-171МВ, самый мощный жидкостной двигатель в мире. Ракета по своим характеристикам очень будет конкурентна.
Союз-5 Иртыш
So there's
ступенчатая ракета полутяжелого
Irtish is a
класса,
2-stage lightweight
способная
rocket
выводить
capable
на
of
низкую орбиту
capable of
17
launching 17 tons of payload into low Earth orbit.
тонн полезного груза. Система управления с быстродействующей бортовой вычислительной машиной
And then,
позволит минимизировать
so the second stage here on Soyuz 5 will have that 0124, the rocket in the previous Russian space news that we saw before this, the engine that they were test firing. Where's the other 2 cores?
связи между ракетой и
that'd be
оборудованием
cool.
технического и стартового комплексов, что упростит процесс
It's a
подготовки
much-
и удешевит наземное оборудование. Союз-5
Soyuz 5 is believe it or not, it's a much more Western styled rocket comparatively to like traditional Russian designs. Believe it or not, we're talking about aluminum friction stir welded here, and then like 5-axis CNC machined interstages that are stir welded, with the RD-171 in it at the bottom. It's much more, and then instead of like, you know, the traditional Soyuz engine that has the verniers. We're talking about much more kind of conventional design here, with like a single nozzle engine in the upper stage that wiggles like this, instead of Soyuz, which has its vernier engines on it. Like, see, these are all, that's all milled aluminum right there. See that? And then stir welded aluminum. You can tell it's stir welded because of the scuff marks on the seam right there. See how it looks like someone took a Sharpie and kind of like went. That's what friction stir welding looks like. Why is Russia breaking away? They're really not, dude. Ooh, that's a hell of a mandrel right there.
Ракету-носитель будут использовать при выведении модулей для российской орбитальной служебной станции, у которой предполагается больший угол наклонения.
Yeah. Yep, stir welded milled aluminum right there. So how they make these things, and don't get me wrong, the only reason I know is because how we make them. They take sheets of aluminum, thick sheets of aluminum, and they mill the stringers in with a huge freaking mill. So like a drill bit goes in there and then they take that flat plate and they punch it through a big metal brake, and punching it through a metal brake curves it, and then they take those panels and they put them into a mandrel and they stir weld them together. This is on the stir welding jig if I'm looking at this right. And then there's the dome at the top. They stir weld it to the dome. They put it on a big jig that's basically like a gigantic lathe, right? And it holds it from two sides. And then the stir welder goes in on the sides and zzz, while the thing turns. What was that about sea launch? Soyuz 5 is going to be launched from the sea launcher, Tessa. At least there's plans to do that. See, there's the mandrel right there. The inclination of the orbits require more powerful rockets, and Soyuz 5 fits this context. Therefore, we will see that it will be used. But one must bear in mind that in addition to Soyuz 5, there will be another rocket that appears in Samara. This is the Amur LNG with a recoverable, reusable first stage, and it will be in the same diameter as Soyuz.
Таким образом, сформированное производство в РКЦ «Прогресс» под «Союз-5» в дальнейшем будет использовано и под
So this is Samara right here. Yeah, this is the Soyuz factory. That's next to Roscosmos' state headquarters. That's a lot of rockets.
Природном газе и возвращаемой ступенью. Первые летные испытания «Союз-5» запланированы.
How long has Soyuz been used? Soyuz's design in its current form goes back to 1966. The carrier rocket, Ryan, of Soyuz goes back to 1957. Sputnik 1 was launched on a R-7 Semyorka, intercontinental ballistic missile. And just like with the Americans, with Atlas and with Titan, we ended up making bigger versions of them to launch people into space. Sergei Korolev, the guy that designed the R-7 Semyorka, instead of putting a nuclear warhead on top, he took that off and they put an upper stage and a capsule on top, and rolled out with Soyuz kind of in its modern iteration in 1966. Russia does it, build it in mass. Well, that's what you got to do to keep the costs low, and Russia's pretty damn good at doing that. At 3 minutes and 6 seconds behind and to the left, there's something that could look like a plane fuselage or something. Okay.
Головной обтекатель будущего носителя.
That's a fairing. That's the fairing right there. Now, keep in mind, Ryan, that's just the base design. The Russians have been upgrading the design over time. First it was Soyuz T, and then Soyuz TM, and then Soyuz TMA, and the current iteration is Soyuz MS. So Soyuz modernized, I think is what it stands for. Modernized something or other. I think modernized system or something. I might be pulling that out of my tail. MS has been flying for a number of years now. It's a good rocket. NASA astronauts launch on that thing. Mark Van He launched on that on MS-18 the other day. Yeah, that's just a fairing, dude. That's the jig that they use to make fairings. The fairings are just lightweight pieces of aluminum. Soyuz still uses aluminum fairings, but then again, so does Atlas. Atlas 5 uses aluminum fairings as well. Yeah, see, that's the big mandrel that they attach the sheets to. But anyway, let's keep going.
Вот это наклонение орбиты, оно требует гораздо более мощных ракет. Но «Союз-5» как раз ложится абсолютно вот в этом контексте. Поэтому вот мы видим, что она будет хорошо задействована. Но надо иметь в виду, что в Самаре помимо «Союз-5» потом появится еще одна ракета. Это «Амур-СПГ» с возвращаемой, со спасаемой первой ступенью. И она будет в том же самом диаметре, что и «Союз-5».
So the Amur rocket is a 10-ton to low Earth orbit reusable methane rocket that will have a reusable first stage. It's actually pretty cool. Pretty cool little rocket. Methane powered, reusable, 10 tons into LEO, which is pretty good with reuse. That's not bad. Keep in mind, if you guys heard what Dmitry said, that's 10 tons. So he said that Samara will have the Soyuz 5, and they need the Soyuz 5 to be able to get to a station at a high inclination, which is where Russia wants to build their new space station. So Soyuz 5 is more powerful, and then Amur is also more powerful. So keep in mind, Dmitry very well may be talking about 10 tons to polar orbit, to polar LEO. 10 tons to polar LEO with reuse is, well, that's nothing to scoff at. I mean, 10 tons reusable is still nothing to scoff at. I mean, it's not Falcon 9. Falcon 9 can do a little bit more than that. I think Falcon 9 with reuse is like 12 to 15 landing on the drone ship. And Falcon 9 with RTLS is a little bit below that. Soyuz is like a Chevy small block. Why scratch build a new design when you can upgrade the existing, pretty much? Yeah, Cam, I don't understand why you'd make Soyuz 5 and Amur at the same time, but my guess is that Roscosmos is hedging their bets against reusability if it doesn't work out. It's kind of like cautious optimism, I guess, kind of like what ULA does. Like, we want to try reuse, but we also want to have a backup just in case that doesn't work out. Good call, Russia. Bye. I mean, yeah, Rice, I mean, I don't know. I'm sure they have their reasons for not wanting to continue the ISS. I mean, they cited that the ISS modules are pretty old and they could enter a cascading failure past 2025, which would be not okay. I don't know, man. I want to keep working with them. I like working with the Russians. I mean, I say this almost once a stream now. I wish we could keep working. I mean, Russia hasn't like officially pulled out. They just said that we're planning on doing it, which doesn't mean that they pulled out of the project on paper. On paper, they're still involved. So, and even if they do pull out, they're still involved for another 3 years, which is that's cool. That's enough for us to figure out what the heck's going on with it, Energomash needs another supplier after the RD-180. Therefore, you have Soyuz 5 with the RD-171. I agree. You got to keep those lines going. Pulse, 56-month resub. I think they may have come to an agreement with the U.S. to end the ISS because of the ambitious Artemis Gateway. Yeah, maybe.
Россия планирует создать свою национальную орбитальную
Russia
станцию.
plans to create its own national orbit space station, which will be the scientific and energy, core will be the scientific and energy module, which was originally built for the ISS. Project of this dimension, I must say, in our country has not been done before. Therefore, we hope this module will serve as the basis of a new modular platform, on the basis which future Russian orbital station modules will be built. At the first stage, the station will consist of 4 modules: a base module, a scientific module, an energy module, all similar, and then a gateway module. At the second stage, target and production modules as well as spacecraft service platforms should be added to them. It is planned to fully deploy the Russian national station in orbit in 2 stages until 2035. One of the features will be scientific equipment will be located not inside but outside, and robots under the control of astronauts will be serviced. So they're working on an external platform similar to the Japanese external platform on the ISS. That's what they're talking about. This is Alexander Blashenko here. Let's see what he has to say.
посещаемая, как в формате таких командировок космонавтов.
Hold on, let me back it up. This station will already be periodically visited
Определенные изменения. Эта станция будет уже периодически посещаемая,
with,
как в формате
in the
таких
format of
командировок
astronauts' missions or cosmonauts' missions.
Она
It
не
will assume that the crew is not
предполагает
permanently staying on
постоянного
it.
пребывания на ней экипажа с учетом
Taking into
повышенного
account that the increased
наклонения,
inclination
с
and
учетом
taking into
того,
account the
что
fact that the station will be
в
more
этом случае
accessible
станция будет более доступна к внешнему космическому
to
излучению.
external cosmic
И где-то в
radiation
3
and will be
раза
about
будет
3 times higher.
воздействие этого излучения превышать то
The kind of
воздействие,
radiation the
которое
astronauts are now
космонавты сейчас
experiencing on the
испытывают на
ISS,
Международной космической станции. Но вместе
but
с
at the
тем
same
это
time, it's a necessary
необходимый
stage in
этап для
preparation for
подготовки
flights
к
into deep
дальнейшим
space.
полетам в дальний космос.
Not a bad idea. Okay, so that new Russian station that they want to build is going to fly through the boreals, north and south. It's going to fly through the boreals. What's the borealis? What is this? So this is solar radiation hitting Earth's atmosphere and parts of and it only happens on the North and South Pole. Or at the North and South Pole, there's the aurora borealis, and then I always forget what the southern one is called. Somebody's gonna type it in chat now. But basically, that's where the sun's exhaust plume is hitting Earth's atmosphere, and you always get some crazy, Australis borealis. That's right. Aurora Australis borealis. Nice. And this is where solar radiation actually hits Earth's atmosphere instead of being caught in the magnetic field, and it always causes this crazy kind of phenomenon going on over here, the boreals. Pauls, thanks for the 56, man. I appreciate it. So what Russia's proposing is that instead of building something like Gateway, you could to practice deep space research, you can have a station that skirts the boreals and learn about building space stations in deep space. Deep space is universally kind of universally understood by everybody to be something outside of Earth's magnetic field or Earth's Van Allen belts. Now, why is that such a big difference? What's the difference there? Well, the Van Allen belts that are generated by Earth's magnetic field catch a lot of solar radiation. And by a lot, I mean like 90% of the stuff. Some of it still gets through. That's why you get sunburned, for instance. But the place where the International Space Station is pretty much covered by the Van Allen belts, with the exception of the South Atlantic anomaly. That's where the Van Allen belts hits the atmosphere, and then the Australis Borealis is below that. But it looks like the Russians are going to use it as kind of a testing ground for going into deep space, which is actually a pretty good idea. Micah 69. Welcome to Mission Control. Your go at throttle up. This means they can fly more often. Instead of staying there for 6 months for each crew, they can do 2 to 3 crews with a smaller time on the station. Yeah, Kem, it's not a bad idea. Just wish we were working with you on it. Now, the converse to that is that the U.S. wants to build a similar station, but out around the moon. That's what Gateway is. It's interesting. I know, Swishio. EG. Yeah, Matt did. Matt's cool. The station's going to be in sun-synchronous orbit. It's something close to SSO username. I'm not sure why they chose to do that. They said it's so the station can see all of Russia. I'm not sure how that's particularly relevant, or what's... I mean, they said it was to monitor the Russian Arctic and stuff, so they could watch it. You can't really see it from the ISS right now. It's low on the horizon, so to speak. Sorry if this was previously covered. Have you talked about that Russia wants to pull out of the ISS and have their own station by 2025? I mean, Astro, that's pretty much what we're talking about right now. I don't know if you just popped back into the stream, but that's what we're talking about.
Станция будет летать на солнечно-синхронной орбите с наклонением 97 градусов
An inclination
к
97
экватору,
degrees to
на
the
которой
equator, where its solar
солнечные
panels
батареи
will always
будут
be
всегда
illuminated.
освещены, а запуски будет
Friday,
возможно
Jackery.
проводить с 3 космодромов – Байконур, Восточный и Плесецк. Орбита российской станции позволит каждые 1,5 часа видеть Арктику, а любую точку планеты раз в 2 суток. Обращенную к Земле часть станции планируется оснастить системами наблюдения в различных спектрах, от оптического до радиолокационного, а противоположную сторону – аппаратурой для мониторинга космического пространства.
Можно летать в плоскости экватора,
You
Можно
can
летать
fly in
под
the equatorial
определенным
plane, you
углом.
can fly at a
Вот
certain
если
angle.
мы
Now, if we increase
повышаем
the angle,
угол, смещая
shifting the orbit of the
орбиту
station
станции к приполярной
to
области,
the
то
circumpolar
получается,
region, then we get a different coverage of
другой
Earth's
охват
surface,
земной поверхности, которую может
Discovery,
станция
go at throttle up.
наблюдать. Интерес
which the station
и
can observe.
понимание международной
Interest and understanding of the
важности
international
Северного
importance of the
морского
North Sea
пути,
route
оно
has now
резко
risen
сейчас
sharply.
поднялось. Это
This is
наш
our strategic and national
национальный
project.
проект.
Beefcake!
Но чтобы
213 sub.
двигаться в этом коридоре, нужно твердо
To move this
понимать,
corridor, you need to firmly understand the climatic
климатические
conditions
условия и мониторить эти
and monitor all conditions. These circumpolar zones,
они могут
the
дублировать
circumpolar
и
zones have the
страховать
capability.
возможности
Hold on, I lost it.
условия и мониторить эти
These circumpolar zones, here the capabilities of the station can duplicate and ensure the capabilities of the orbital constellation of spacecraft and the crew of the station will be 2 to 4 people. The volume of the pressurized compartments will be 667 cubic meters. Smaller than the ISS. It's about the size of Mir, if I'm remembering correctly. What was that last part?
667 кубометров. Кроме того, станция будет использоваться и как промежуточный пункт для полетов и освоения Луны.
In addition, the station will be used as an intermediate point for flights and exploration of the moon. The Arctic trade route can bring a lot of money, but you need to monitor it from space. My question, Kem, is why is the Arctic route viable all of a sudden? I think I know the answer to it, but I'm curious. Why is the Arctic route viable? Why was Barents able to take, you know, parts from Severomorsk to Sovietskaya Gavan? Like I said, I think I know the answer. I'm just genuinely curious. Russia has icebreakers. Like I said, Wisp, I think I knew the answer, and I didn't. I'm more asking the Russian viewers here. Kem, I'm asking you. Yeah, I thought I knew the answer. I just wanted to be sure. Interesting. Huh. I mean, ships have been using the North Passage for the few summers. I know, Jim. I knew the answer. I just didn't really want to talk about it. That's why I asked. Big GSV orbital deposits in the north part. I mean, yeah, Disciple, I don't think it's just, you know, the ice caps are decreasing, you know? There's also been a yeah, Jaka. Okay, so Kem, they started to be interested in the Arctic region just recently. For the first time since the Soviet Union collapsed, it's more ambitious. Yeah, so the Soviet Union used it too. All right, cool. Just making that's why I wanted to hear that, guys. It's not just climate change. That's not the whole answer. The whole answer is that Russia didn't have the infrastructure to be able to do it, but they did do it in the past. Now, so a lot of folks said icebreakers. Russia has a lot of icebreakers. The reason why they have a lot of icebreakers is because Russia doesn't really have a warm water port. You know what I mean? Well, they do, but Russia's a big place. One warm water port is not going to be enough. You know, so if you have like up in the Kola Peninsula, right, you know, where it freezes over half of the year, having an icebreaker be able to break and make a sea route for you is good, but you need to have the money to be able to operate those things. Icebreakers are expensive. And if I recall correctly, the Russian icebreakers are nuclear powered. Those nuclear powered icebreakers are actually pretty neat. Obviously, they want to find new trade routes. Don't want another evergreen incident. Yeah, maybe. I mean, going through the Northern Passage is... That sounds dangerous because there's a lot of stuff up there that can get you. Like, some of them have 2 cores. I mean, those are cool, man. It's neat. Neat. The northern route reduces shipping times between Russia and its major trade partners. I mean, Jack, I still say that, Kem, you guys need a freaking national highway system. That's what you need. Got to build a highway. Like, this is just totally apolitical. You build a highway to China. I'm dead serious about that. Should build a big 8-lane mother trucker directly to Beijing, dude. That's what I would do. And I'm sure they'd be cool with it, you know. That's what I would do, man. Build a big highway. Screw the highway, build a rail line. They already did that. That was done a long time ago. The Trans-Siberian Railway, Tessa, what do you think it connects? You could take a train from Moscow to Beijing if you really want to. Yeah, they did that already. Trans-Siberian Railroad is one of the craziest engineering projects in human history. I mean, that's a long way. Build a faster railway. No, you need a big highway, dude. You need a big highway. Big highway. If you send ships from Asia to Europe, it should be closer via the Arctic route instead of the Suez Canal. I mean, a high-speed cargo line. I mean, that's all. Build it with the highway, right? You guys need a national highway system over there, man. That one stupid little road that connects east and west is some 2-lane kiddie highway stuff. Build a bigger highway. Anyway, these days all about cars. I like all forms of infrastructure. Just saying. We need more prisoners to build it. Just joking. I mean... Don't do that. That was a joke. Don't use prisoners to make road.
5 лет назад, 28 апреля 2016 года, в 5 часов 1 минуту по московскому времени состоялся первый
So that was the first launch from Vostochny. Man, was that really in 2016? I remember we watched this launch.
Ракета-носитель «Союз-2-1А» успешно
Soyuz
вывела на
2-1 carrier
орбиту 3
rocket
научных
successfully launched 3
спутника, в
scientific
разработке и
satellites into
создании
orbit.
которых приняли участие студенты и преподаватели МГУ имени Ломоносова и Самарского государственного аэрокосмического университета. Через 2 часа после старта космические аппараты «Самсат-218»,
nice.
Михаил Ломоносов и Аист-2D последовательно отделились от разгонного блока «Волга» и вышли на целевую орбиту. Это событие стало исторической вехой в истории страны. Новый, самый современный российский космодром начал работать.
Very clean. I like that. I like the cleanliness. Interesting. So, 5 years for Vostochny already. Oh, that's great, MGB. The other picture, dude, I couldn't really tell like what you're doing there, but that one looks really cool. I like that.
Новая система построения ориентации
The new attitude control system during the deorbit of the MS-14 cargo
грузового
spacecraft
космического корабля «Прогресс МС-14» будет испытано в ближайшие дни.
will be tested in the coming days. The braking engines will be switched on April 29th at 3 a.m. Moscow time and will work for 4 minutes for the deorbit burn. According to the calculations of specialists in Mission Control Center, Progress MS-14 will enter the dense layers of the atmosphere after 30 minutes. The re-entry of non-combustible elements of the ship's structure will occur in the non-navigable area of the Pacific Ocean. Yeah, they deorbit everything over the South Pacific. That's where Mir and everything is. The first navigation of a new generation of satellite, GLONASS K2, will be launched at the end of 2021. GLONASS is their global positioning satellites. Nikolai Testadov. MS-14 was at the station for over a year. The deliveries of onboard equipment have already been completed. Look at that. That's what their global positioning satellites use. And before you say, oh man, I don't use that, if you have an iPhone, your iPhone uses GLONASS and GPS and Galileo. Just thought I'd let you know. For location services. Yeah. Apple don't care. The computer animation shows how rays of light from the accretion disks and black holes. What does Android use? I don't know. This center of mass passing through extreme gravity. What are we talking about here? Whoa. Okay. I'm not sure what that was about. I mean, that's just shows how gravitational, or high masses that have gravitational pull can warp space and time. That's what it looks like. You're warping light because light is a part of space-time. This is it. The rest is the science part. Oh, that's cool. All right. Neat. Great video. I like those update videos. Those are pretty sweet. Okay, we can get rid of that. All right. Let's head back over to the States here. Can you see last? Sure, Gartox, what's up? Why are the bells painted inside on the red, or is it just the covering? That's just a FOD protector on Soyuz. It's just a cover. For the Russians, you know how, like, Gartox, you know how we use, like, high visibility? Like, we use orange, there's, like, high vis yellow and stuff. The red on any Russian spacecraft, and frankly, I mean, this is really more for aviation. Any red on the spacecraft here or over there, that means remove before flight. Yeah, that's why. It's not paint, it's just the cover to make sure that nothing gets in there. You don't want any dust getting inside of the rocket engine. You don't want any foreign object debris. It's called FOD. You don't want that anywhere near it. Foreign object debris, like hair and, dust and rocks and whatnot can introduce deviations into your engineering. Why? Well, your engineering and math didn't really take into account having a human hair inside of the spacecraft, right? And dust and hair and all this other stuff can float around inside of a spacecraft. And the second they float around and one finds a lead, one part of the hair finds a lead and the other part finds a lead, that's called a jumper. And a jumper can short circuit stuff. I don't think I need to say why that's bad for a spaceship. So you want to really prevent foreign object debris. That's why those covers are there. There is like a 500 nautical mile by 500 nautical mile. Yeah, the South Pacific is where, because there's no shipping lanes there, Jim. The shipping lanes follow, like, the islands, right? They follow the Pacific Island Hobbit, and then they go up through the Aleutians too. The South Pacific has no. We're talking like east of the Philippines and east of the Marshall Islands, like that area between like Australia and South America. There's nothing there. That's where they deorbit spacecraft. Every spacecraft that's been deorbited that's disposable has ended up over there. Mir is over there. All the Salyut modules are over there. Skylab tried to get over there, but ended up crashing into Australia instead. Yeah, they did. They determined that it had a higher ballistic coefficient than they thought, and it deorbited faster. The Russians use graphite pens. You think they care about hair? They don't use graphite pens anymore. They stopped doing that a long time ago. Because it creates foreign object debris. That's just some stupid myth that gets thrown around. The Russians don't have FOD with their writing implements. Yep, New Zealand is just nothing. Yeah, Bon, we don't care about you. It's fine. Anyway, let's head back over here, over to the United States, and let's see what other space news we have. I'm trying to kind of keep all this together. I'm saving all the SpaceX stuff for last because it's usually how we end up doing this. So we can go put that one over there, put that one over there, put that one over there. We don't need that one. I can get out of that. Okay. Did you cover Collins? Yep, already done. We use uranium pens. Yeah, with a graphite tip, obviously. It's less expensive.
Discovery, go at throttle up.
Rip the movie news. I still have it on there, dude, but yeah, Cam, I don't think we need to show that, dude. A lot of people that are thirsty. We don't need to show that. All right, so we got a picture. We got official pictures from ULA. Pacey, 24-month resub. Thanks for the 2 years, man. We got pictures from the NRL 82 or the L82 launch here from ULA on their Flickr. Check that out. That's a pretty cool picture of Delta 4 taking off. Remember, that command needs to be updated, huh? Oh. So what you're seeing here is the unburnt hydrogen that's a byproduct of engine ignition. One of the tough parts about using hydrogen in your first stage, or hydrogen at all, is that it gets freaking everywhere. Hydrogen is not coarse, it's very fine, it's not rough, it's annoying, and it gets everywhere. So what Delta 4 does is they have firing igniters in the flame trench that try to purge off all that hydrogen, and when they light the hydrogen on fire right during engine ignition, you get a big fireball coming out the bottom of the rocket. The Space Shuttle had this problem too. That's why the Space Shuttle has those sparkers all over the place. They didn't want that traveling up the back of the Space Shuttle. I don't think I need to tell you why that would be a bad idea. So the Space Shuttle had a way to get all the hydrogen away. With Delta 4, it's not as big of a deal. So you don't, I mean, it's not like you're getting this back. So yeah, they don't have to mitigate the fireball as much. Oh, okay, Tessa, I got you. Yeah, still awesome. Oh. Yeah, see? There's still some hydrogen caught in the low pockets behind the booster. See that? The shuttle had that same phenomenon. Hydrogen gets stuck right here in a low pressure pocket. The reason why it's low pressure is because the rocket's moving all the air out of the way, so you get a huge void that's right here. And fire can actually travel up the sides of the rocket. You can see on the outsides of the nozzles here, because the open cycle gas generator is lighting the gases on fire, they're getting trapped in here. Couldn't they take a vacuum cleaner and vacuum up all the hydrogen? What? The rocket engines create a sufficient enough vacuum to pull it all away. It's only for a second. So, T-Man, when the rocket engines fire, they move so much air that they actually accelerate the air around it, and they actually create vacuum in the flame trench. That's why all that fire only happens for a second. Most of it gets pulled back down into the flame trench. It's very easy to spot with something like here. I'll show you. Rockets actually create their own vacuum, dude.
We have been given the scientific knowledge, the technical ability, and the materials to pursue the exploration of the universe.
Headphone users.
To ignore these great resources would be a corruption of a God-given ability.
10, 9, ignition.
So watch when they ignite the engines. They'll create a cloud of soot that comes up the flame trench, and then it'll get sucked right back down. Watch.
0.
All engine running. Watch. See? Did you see it? It was real quick. See? And then it'll get sucked right back down to the flame trench. T-Man rockets make their own vacuum. See it getting sucked down in there? See that? mean, that's the dirty truth, Mutter. Am I right? Am I right? Am I right? Link. Oh, sure.
Discovery, go at throttle up.
Simba 1 year. Been a great ride. Godspeed, Mike. Wish him the best on his next mission. Can you explain the black on the exhaust? Sure. Just please hold. Okay. So you're talking about the sooty exhaust? So, Shaw, you tell me. Here, let's talk. I'll talk you through it. Talk you through it. Here, let me mute it so we don't blow people's eardrums out. So, what's that? What's we know that the Saturn V first stage is using Kerolox, right? Kerosene and liquid oxygen, right? So, what would create soot like this? It's just soot. Yeah? Where is it coming from? Well, what creates soot on Falcon 9? Like the Merlin 1D, it generates a lot of soot. So, the RP-1. Specifically, where is it coming from on the Merlin engine? You know this. I know you know this. Where does that unburnt kerosene fuel-rich mixture come from? The turbo pump. That's right. The Merlin 1D has an open cycle gas generator. So they have a jet engine strapped to the side, and the jet engine's turning a fuel pump. And the fuel pump has two impellers that move liquid fuel and liquid oxygen into the rocket motor through an injector plate. The F1 does the same thing. Why would the exhaust be sooty like that? Well, what they did was they figured out that that fuel-rich mixture is actually really cool. It is. It's cold. Anytime when you're combusting something, if you run fuel-rich, you run really cool. If you run lean, you run really hot. So, because the F1s make such a big frigging explosion, they figured out a way to take. Well, not figured out. What they did was they took the gas generator exhaust and they funneled it into the nozzle to keep it cool. That's why the Saturn V with the engines have this really black sooty part here. It's not that the entire exhaust coming out of this thing is black and sooty. What's happening here is that you're seeing a film. They inject the gas generator exhaust into the nozzle through this manifold right there. See that? And that is enough to keep the inside of the nozzle cool. It's film cooling. So that cold fuel mixture, and keep in mind, it's not cold by any means. Jet engine exhaust is not cold. It's just colder than that. It's just cool enough here to provide a film on the rocket nozzle to keep it from melting. It's just enough. All right? Now, once again, the exhaust from this, I wouldn't put your hand in there by any means. I wouldn't put your hand behind the gas generator and be like, oh, this is a nice stiff breeze. No. The exhaust coming out of the gas generator on the engine is still extremely hot. But it's not as hot as the rocket exhaust, so they use it for cooling. A lot of engines do that. That's regenerative film cooling. Now, an engine like the Merlin 1D on Falcon 9 does not use film cooling. They have a different way of cooling the engine. The gas generator on a Merlin 1D just dumps out the side, and that's why Falcon 9 has a lot of soot on it when it comes back down, because the exhaust from the turbo pump power pack is just being thrown overboard, and it covers the rocket in soot. With the Saturn V, they're using that same soot to cool the engines, and not even that was enough, believe it or not. Scott Manley actually has a video that talks about this pretty in depth, but not even that was enough to keep the engines from melting each other. They figured out on the test stand that having 5 of these engines so close to each other, even with the regenerative cooling, was not enough to keep these things from melting each other. Now, the inside of the nozzle was all fine and dandy because of the film cool, but the outside of the nozzle had some really bad problems. So what they ended up doing was, during the Apollo missions, wrap them in asbestos. Seriously, look. Look at the engines. They're wrapped in asbestos. All of them. Of course, Chief Funky. Yeah, that's asbestos. See? That, you know, if I wanted to, you know, activate the search bar, I would, but I don't want to do that. I want to scrub through this. There we go. See, they wrap the engines with asbestos. And even then, you're still getting a little bit of a performance hit because the engines melt each other. Having 5 of those engines so close to each other generates a ton of heat. And the pain in the butt about that is that the heat gets stuck. The heat gets stuck up in here. It gets stuck because of the rocket, well, moving the air out of the way. See these big nacelles right there? That's moving all the air away. And what happens is, now these are causing a vacuum, right? So the gases, the air that's coming down the side of this gets accelerated by the rocket gases coming out the side. So it just keeps going. It doesn't fill this area in. What is that called? Well, that's drag. That's aerodynamic drag. That's what drag does. Pressure changes. There's a lot of drag back here and there's a lot of low pressure. The problem is the damn heat gets stuck there. It gets stuck in there. And it creates a ton of heat and it basically melts everything up in there. I mean, you saw that same phenomenon happen. You saw the same phenomenon happen during the SLS green run. Same exact thing. And we saw the insulation get burned off on the stage here. Let me see if I can find the pictures. See? Look up at the top of the screen. See up there? Victory, nice, yeah. Did the piping on the exterior of the RS-25 replace asbestos when they went to the shuttle? Well, they're using liquid hydrogen to cool the nozzle on this. So on the shuttle motors, or the RS-25 engines, it's a fuel-rich stage combustion cycle. So what does that mean? That means that they take the fuel, it goes in through the turbo pumps, and then they light it on fire. They spray it with liquid oxygen, they light it on fire, and then they shoot that into the engine and hit it with liquid oxygen again. Anytime you hear stage combustion, it's like a small rocket motor, or it would be more like a jet engine with the afterburner on, shooting gases into the rocket engine. Yeah, it's kind of like that. So the shuttle engines use a fuel-rich stage combustion cycle. And the reason they do that is for cooling purposes because they're reusable. Some of that hydrogen coming into the thing goes down into the nozzle, keeps the nozzle cool, and then goes back up and gets staged, hit with liquid oxygen, ignited, and then that goes into the main combustion chamber. It goes from the main power head into the main combustion chamber, and then they hit it with liquid oxygen again, and then they shoot that out the bottom. That's what comes out of the back of these things. But they're using the fuel to keep this nice and cool. Now, liquid hydrogen is ridiculously cold at liquid temperature. It's like almost minus 500 Fahrenheit, which is really, it's like minus 283 centigrade. I always forget the numbers off the top of my head, guys. I'm sorry. I know it's like, it's almost near absolute zero. So it's about as cold as you can get without being in a vacuum. So that provides a great that provides a great thing to be able to cool the nozzle. That's why the shuttle engines don't melt. That's why that's part of the reason why they can fire for such a long period of time. Because as long as you have liquid hydrogen, you're good to go. You keep the thing nice and cool. Hey, everyone, sister. 273. Thanks, Carvik. How's SpaceX going to solve that problem with Super Heavy? Yeah, I don't have the answer to that one. A Raptor does have some kind of regenerative cooling, if I'm thinking about it right. Yeah, they have some kind of regenerative cooling, but it's not like the shuttles, because it's a little different because they're using methane. But yeah, in terms of the shuttle motors, you could still see the, I'm trying to get the shot of all the engines. you can still see that the, you know, part of the insulation caught on fire. Wigglies. Was that filmed at Stennis? Yeah, this was earlier this year, Complex. That's the B2 test stand at Stennis Space Center. This is the SLS core stage. That was the second, that was Green Run test number 2. The core stage is since gone. It's at Kennedy Space Center actually now. It arrived there yesterday. But yeah, that's Stennis, man. Yeah, but if you go back and look at that footage here, you can see, you can even see it in the little wigglies up there. See the flames at the top? Yeah, it creates a lot of low pressure up in there, and stuff likes to, fire and heat likes to get caught in there. Yeah, that's part of the reason why SLS ended up using shuttle engines in the first place, because shuttle engines are good at keeping themselves cool. Why? Well, they were designed to operate in close proximity to each other. Not every rocket engine is designed to do that. But yeah, anyway, let's see, what else do we got? It's 8 o'clock, holy crap. We might just, I mean, we're going to play Kerbal. I have to go do that rescue mission. I have to go get Bill and Bob and then the rest of the damn parts, but, good video of the burnt bottom in EGS handoff. Oh, there we go. Yeah, this is where Exploration Ground Systems handed the keys over to that's awesome. They handed it over. Yeah, look at the back, see? See all of that got burned? It got burned in the during the Green Run test. That's a little bit of refurb that they need, but they're gonna take the tape off anyway. Sus, what's that, Forge? That's very sus. Yeah, see the back of it? It caught on fire during the test. Now, don't get me wrong. You know, like, is it going to catch on fire that much during the launch? No, probably not that bad. The reason why is because, well, down here, the pressure in there would be a lot higher than it would be during an ascent. Well, why? Well, because you go up into space. So the flames will, there will still be some flames on the bottom of SLS during launch. There will be flames that travel up the vehicle like the Saturn V, but the flames won't be as bad as during the Green Run. Well, why is that? Well, that low pressure still does exist on SLS down here, but down here you have the entire weight of the atmosphere pushing in there. So you're getting a little bit more atmosphere in there than you normally would. So the flames won't be as bad on the real SLS flight. They talked about that in the Green Run press conference. I've been looking and can't find info to when Crew 1 is landing. They'll be undocking on Friday night and landing on Saturday. Sudden they pushed it back. Okay, let's keep going. So this is part of some of the news here is just quick stuff. This is an article coming from Space News. Intuitive Machines' first lunar landing mission slips to 2022. Intuitive Machines is a launch provider making lunar landers for the Commercial Lunar Payload Services program. These are small landers to basically go and set the stage for when humans will go and land later. Basically akin to the Surveyor missions for NASA during the Apollo program. The Surveyor missions were probes that NASA sent down on different spots on the moon to find Apollo landing sites, basically. That and the Ranger program. But we already have the Ranger program in the form of the Lunar Reconnaissance Orbiter. So this article's from Jeff Faust over at Space News. The first lunar lander mission by Intuitive Machines, which had been scheduled to launch late this year, has been delayed to early 2022 by its launch provider SpaceX. Intuitive Machines had planned to launch its Nova C lander on the IM-1 mission in the fourth quarter of this year on a Falcon 9, carrying a combination of commercial and NASA payloads. A March 24th news release about an agreement to use the Parkes Radio Telescope in Australia as a ground station for the mission mentioned a launch towards the end of 2021. However, on April 23rd, an application filed with the Federal Communications Commission to obtain an S-band spectrum for this mission. Intuitive Machines said that the lander was now scheduled for launch in early 2022. The company did not provide a more specific launch date or a reason why the delay for its FCC filing. Interesting. By the way, NASA spaceflight is live with nose cone testing in Boca. Oh, boy. I don't know what I'm looking at there, Forge. So, in other interesting news, this is another space news thing. And guys, once again, if anybody wants the links to this stuff, just tell me. I can always get you the links if you want to read more into it. The idea is that I only like for space news or for NASA spaceflight or any of the other thing, any of these other news sites, I'm only going to read a little bit of the article. If you want to learn more about the article, I want you to go to their website and go and read. We got to support these, you know, whoever we can that's going to do this awesome work. I don't want to just sit here and tell you the whole article, you know. SpaceX has a problem with the Nova Sea lander. It will use methalox. It will do cryoload inside the Falcon 9 fairing. That's the Nova Sea orbit parameters. Interesting. Well, that's going to be... you're going to have to modify the launch pad to be able to cryoload methalox into the lander. Interesting. So, another space news article here. Yeah, Bram, not everyone. Eutelsat buys a quarter of OneWeb to get a low Earth orbit broadband growth engine. French satellite operator Eutelsat is now paying $550 million to buy a portion of OneWeb, the startup that's deploying a broadband network in low Earth orbit. The company is buying a 24% stake to give it similar governance rights to the British government and Indian telecom company Bharti Global, which bought OneWeb out of bankruptcy last year. Part of the investment will be funded by the $507 million that Eutelsat is getting from clearing the C-band spectrum in the U.S. for terrestrial 5G networks. I'm not going to sit here and pretend that I understand what that says. I think the C-band spectrum is a frequency spectrum for terrestrial 5G networks. So they're basically clearing up the cell phone signals. I don't think the Strongback can do cryoload, to my knowledge. Username, I don't know. They're going to have to modify it or use a different... I don't know. I don't know how... I actually don't know how they're going to do that. I'm sure SpaceX knows, but I don't know in particularly. I mean, you'd have to add more infrastructure to the Strongback and then a cryofuel load umbilical that goes through the fairing. Interesting. I get something EJ doesn't. There's a first time for everything. Yeah, well, it's not like your job description has a lot to do with that or anything, huh? You jerk. No. I mean, yeah, I mean... That's cool, man. Yeah, I mean, yeah, well, you definitely understand this more than me, man. If I understood it more than you, then we'd have a problem. Toxic, toxic, toxic. Yep. I'm just the model for streamer toxicity, aren't I? Did you cover the sad news today? Yeah, about 4 times over, Rogue. It sucks, man. I had a whole thing, a whole segment. That's actually part of the reason why Space News is taking so long today. Basically think S-band, but a little higher. Yes. OneWeb is far from bankruptcy at this point. Yeah. Interesting. All right. Okay, so Axiom Space actually posted this here. Axiom Space is partnering with NASA to actually add commercial modules to the International Space Station. Let's see what they're up to. Courtesy of our partners, Thales Alenia Space, the first looked at the machining of an Axiom Station module's radial bulkheads. Together with the common berthing mechanisms that will affix to them, they will offer 4 ports to which other station elements, including docking adapters, can attach. That is a big 3-axis mill. Holy crap. How would you unplug the umbilical in the fairing so you wouldn't rip the upper stage? Have the umbilical attached to a wire with a weight on it, and then when it separates, the weight falls and it pulls the umbilical away. That's how most umbilicals work, Jam. Wow. Interesting. A radial CBM. Yeah, look at the broom for scale. That's big. That's so... okay, the radial CBMs are here. Let's take a look. Let's find pictures of their modules. The radial CBM, what you're looking at is that. See this white panel right here? This guy? That's the reason why that panel is so ridiculously thick, because they mill the curvature right into the panel, and that serves as one piece. It's one big chunk of aluminum. That's why it seems to be so ridiculously thick. Because if you look down here, you can see they already milled some of the curvature in. So this is going to be... This whole... They started with a big block of aluminum, and they milled the curvature right into the panel. Now, why? Why would you do that? Well, because you need it to be strong. You need the place where the docking port attaches to the station. If you want to dock another module or a spacecraft or whatever, you need that CBM to be structurally reinforced. How do they reinforce it? Make it out of one piece. So think if you guys are familiar with my KSP playthroughs, you know how I use SRBs? That was actually DAS's idea. You use an SRB over, if you want like a structural pillar, you use that for like the crane, for instance. I use the SRBs for structural pieces because they don't deform. Same concept going on there. You make that one big piece, and then you attach the CBM to that. So if you have another module docked to it, for instance, right? You have another module docked to it, it won't deform and bend as much because it's one frigging piece. So they're going to mill that out of a giant chunk of aluminum. That chunk of aluminum looks to be at least about a half meter long. It's big. And then, of course, there's the broom for scale. Now, I know what a lot of you are going to think. Man, that's so wasteful, machining that whole thing out of aluminum. You have so much extra aluminum. Why? What the heck's up with that? Well, the thing about aluminum is that it's very recyclable. So this is why, like, additive manufacturing at this point in time, doesn't have any inherent gains over subtractive manufacturing, right? Meaning 3D printing versus, you know, milling out of a big block here. Now, basically what they could do is they take all this aluminum, they sweep it up. See the broom over there? They sweep it all up into a crate, and then they ship that crate back to the, you know, probably Alcoa or something. American Aluminum Company of America, Alcoa, I think it is. They'll ship it back to an aluminum provider. They'll just make it into another chunk and send it back to them so they can make more. I don't know if they're using Alcoa for what it's worth. I have no idea. There's a lot of aluminum manufacturers in the U.S. Yeah, with subtractive manufacturing, all the stuff, all the chunks that they have, all these chunks that they mill out of it, they could just send back and just use it to make more. So because aluminum is super recyclable. Actually, most metals are like that. Steel is like that. That's why, you know, you recycle steel cans and tin cans and aluminum cans and all this other... most metals you can just reuse. To learn about it, there's a great Smarter Everyday video in the ULA Factory Tour. Oh, I know all about that, Bram. We watched that on stream. Well, parts of it. I don't want to watch the whole thing because out of respect for Destin. Now, keep in mind, with additive manufacturing, and this is kind of cutting edge stuff. This is what rocket companies like Relativity are working on. If you use like an additive manufacturing method, so like a 3D printed method using like laser sintered aluminum, you can avoid the whole chunk situation all in one shot. And all you need is aluminum powder, basically. You need aluminum that's ground into like a fine sand. And then you feed that into the machine and it'll just crap out a rocket fuel tank for you. Yeah, I know. You know, I say crap out and people are like, what? Wait, what do you mean? Well, here. There are companies that are working on this. A spaceflight small sat, or a spaceflight provider, they're not small sat anymore. A spaceflight provider called Relativity Space is working on additive manufacturing using what I would guess is sintered aluminum powder. Take a look. I mean, when I say crap out a fuel tank, I mean literally crap out a rocket's fuel tank. Look at that. Pretty crazy, huh? That's additive versus subtractive manufacturing. See, they're putting the bulkheads and the stringers literally right into the thing. Isn't that crazy? You know, I very much want to know how much this thing costs, but I have a feeling that if I have to ask how much this thing costs, I probably can't afford it. This looks to be a modified KUKA robotic arm. heavily modified with into a 5-axis machining, or, well, laser sintering thing here. How much does that cost? Well, yes. Yes, it does. It, in fact, does cost. I'll take one cost, please. Looks more like it's mounted on a forklift. Yeah, maybe. There was just an RS-25 test at Stennis. It just ended. No, there was an RS-25 test at Stennis like 3 hours ago, Ryan. It was a 11-minute burn on an RS-25E. 11 minutes. That's a direct... I think that they were testing direct TLI insertion there from an SLS core. That's ridiculous. An 11-minute duration burn on a shuttle motor is unbelievable. That's a lot. It was 11 minutes, Ryan. Yep. Power consumption will be the expensive part. I agree, Master. Yeah. You have a 3D printer at home. Yeah, but it can't laser sinter aluminum. It just melts some plastic. Why would they do that? Real quick, could you please link up the Halo soundtrack playlist you used to play? Okay. The gimbal profile they ran was ridiculous. I agree. Yeah, we watched that at the very beginning of Space News. Space News has taken a lot today because just like every other day on Tuesday when I decide to take my day off, a bunch of Space News comes out. So Space News is on Wednesdays and Mondays, usually go long on purpose, like, because I missed a day. Space News is coming at us that fast nowadays. There's so much to talk about. We haven't even talked about Starship yet. And now, don't get me wrong, guys. I don't mind letting Space News go a little bit long today because we got a lot of rocket launches, and I'll be honest, I need a day off from freaking KSP, man. I'm still trying to figure out what we should do with DART and everything. Now, I do need to do the rescue mission and go get Bill and Bob back to the launch site, but I might need a day here. We do have a lot of rocket launches coming up here, actually, very soon. When's the next one? So we have a Vega. There's three rocket launches tonight, guys. In about an hour and a half, we have Vega's return to flight. So this is Vega Flight 18 here, coming off of the 17 flight, which malfunctioned. And then China is going to launch a Long March 5, a Long March 5B, and they're going to launch their space station core module Tianhe. And then that's at 11:18, so that's in 3 hours, right? And then SpaceX is going to launch Starlink tonight at quarter till midnight Eastern time. There's 3 rocket launches tonight, so yeah, I mean, oh well. You're not planning on launching covering the red launch, are you? I'm pretty sure they aren't planning on doing it, John. Yeah, they don't usually do state broadcasts like this, so I mean, the one going out of, so okay, just to be 100% fair and in the interest of calling everything fair, the Tianhe launch is launching out of Wenchang. Wenchang is on Hainan Island. This is not the launch site where they drop stages on people. This is a launch site that is on the coast with an ocean to the east of it, so I don't have as big of a problem with it. If there's any footage of it, I'll probably end up watching it. But yeah, the rockets that I specifically don't cover and won't cover is Long March 2 and 3. Those 5 I don't really have a problem with. It launches out over the coast. Nobody's freaking perfect, dude. But yeah, 3 and 2 launching from Jinshang. I think it's called Jinshang. Yeah, I don't like that. Yeah, now to be 100% transparent here, Ian, that's exactly right. This Long March 5B puts the core stage into low Earth orbit, and then they deploy the space station module. Long March 5B core stages are about the size of a Delta IV CBC, and that's going to be in an uncontrolled orbit. Last time they launched a 5B like this, it almost landed in New York City. It was about maybe 2 or 3 meters a second short of landing in New York City. Now, 2 to 3 meters a second is the difference between landing in New York City or landing on a village in Africa, which is what happened last time. There was footage on Facebook and on Twitter of, folks out in various villages here, taking pictures of rocket parts that they found on the ground. Now, don't get me wrong. Like, I'm not just doing that to spit shade at the Chinese space program. Having debris come down and re-enter from uncontrolled stages is not right. That's not good space flight. That's not wise. You know why? All it's going to take is one booster coming down in the wrong spot and Donnie Darkoing somebody to really sound the alarm bells. Now, once again, I'm all for calling it completely fair. SpaceX had this problem with one of their Starlink launches the other day. A Starlink second stage failed to deorbit, and that Falcon 9 second stage came down in Oregon. And parts made it through, and they landed. Fortunately, they landed out in the sticks in the middle of nowhere, so it didn't hurt anybody. But, I got to call it fair. I got to call it like it is. I don't like it when SpaceX does it. I don't like it when China does it. I don't like it when anybody does that. Rockets that come up and come down and hurt people are not rockets. Those are missiles. You don't get confused. So, I don't mind if they go out of Wenchang. That's fine, because those don't fall on people. However, we gotta be careful about debris up in space. It doesn't matter if it's debris that could cause a collision up in space or debris that comes down over populated areas. None of it is okay. That's not good. Like I said, one thing coming down and Donnie Darkoing somebody in the wrong spot at the wrong time could really put a damper on human spaceflight operations. Seriously. Think about how bad that would actually be. Let's not do that. Even if it's China's. Can you imagine if one of China's Long March stages came down and landed in New York and hurt someone? That would be not good. I don't want to think of the repercussions there. Like, that's not a good idea. It's not a good idea. That's my biggest criticism of what the Chinese do over there. I don't like that. And I'm the only one that says anything. I don't know what the hell's up with that. TJ, that's what we're talking about. I don't know, Dunpeel, and I don't want to know. I don't want to imagine something like that happening. So, let's go down to Texas here and finish off space news with some Starlink, with some Starship stuff. The last Long March 5B core stage passed directly over Central Park 20 minutes before it landed in the Atlantic. Yep, I know. It almost hit. Dude, can you imagine if that came down on Manhattan? Like I said, in a couple of meters a second slower, that thing comes down in Manhattan. Heck, not even that. If it's tumbling and it hit re-entry in a different way, that comes down over New York. And then it lands in New York. That's not good. That's bad for business, man. That's bad. Something like that even spells bad news for us over here. Like, because now everyone's getting now because that happened, all the freaking Rule 8 people are going to be like, well, why doesn't every rocket, does every rocket do that? Oh my gosh, we got to make sure that every single rocket, see what I mean? You don't want that happening. Anyway, so let's go down to Texas and let's see what's going on here. So this is coming from Philip Botten here. He took some pictures of Raptor 59. Nice. SpaceX has rolled out with SN15 a new generation of Raptor. I don't know if we should call it version 1.1, Raptor 1.1, Raptor Block 1, Block 0, Block, I don't know, 1B, I don't know. They rolled out with a new generation of them on SN15. And so far, with the 2 static fires that they did with Starship yesterday and the day before, everything looks to be okay. Hey, Thorin, what's going on? Yeah, Tessa, that would really suck. Wenchang is for Long March 5 and 7. Zishang, the bad one. Jinshang is Long March 2 and 3. 4 and 6 are out of Tijuan. Tijuan. I can't Chinese, man. I really should probably work on that. So, yeah, I mean, there's Yeah, Green, it's not good when anybody does it. It doesn't matter if it's SpaceX, it doesn't matter if it's China. But that's not good. That could be bad for business, man. We don't want that. So yeah, they do have a newest version of Raptor that is flying on SN15, and those are some pictures of it. Now, in terms of SpaceX news here, the next thing is coming from Mike Sheets, who's the reporter for CNBC. I'm actually not familiar with what's going on here, so this is the first time reading it for me. NASA's Human Landing System program today issued a request for information for the Lunar Exploration Transport Services acquisition. They promised to follow up contract opportunity after the agency's SpaceX HLS award earlier this month. Lunar Exploration Transport Services. So, a NASA RFI is basically when NASA has an announcement. They announce this RFI, and the RFI in this particular application, it's basically NASA fishing for information. The RFI is, in this particular case, NASA's basically saying, if you were going to move cargo to the moon, how would you do it? Give us some proposals. Actually, here, let's read before I make any comments here. Man, space news has gone on for a while. Yeah, I know. Are you not into trains? Do you not like it? Can you tell us what upgrade changes they made to the Raptor? Kuro, I have no idea. I really don't know. I don't think anybody knows that. I think the only people that know are the people that work at SpaceX. We know, dude, the only reason we know that it's a new version of Raptor is because the plumbing looks different. And dude, I'm not gonna sit here and stare at a Raptor and try to figure out what all that plumbing does. There's a ton of pipes on that thing. We know that they're upgraded from what Elon said on Twitter, and we know that they're upgraded from looking like comparing pictures. That's about it, dude. I don't know what this new version fixes or changes or whatever. I know that Starship SN15 does have an upgraded plumbing structure because we watched it go together via NASA Spaceflight's videos. The plumbing is different. So, like, how the LOX and methane gets distributed into the thrust puck is completely different. So, I mean, hopefully that and the Raptor upgrades fixes some of the problems so it actually can do this for a change correctly. Dude, Michael Collins passed away today. Bummer. Snap, he's old, man. He's old, dude. Like, what do you want? The guy's old. He made it up there. He lived a full life. I think to say he didn't have a fulfilling existence, I think would be an understatement, right? Like, I mean, hey, people get old. They die, dude. It sucks, but what can we do? The only thing I hope for, dude, and I wish him, I wish Mike all the best in his next mission, wherever it may be. The only thing I could, like, just on a side note, dude, I really hope we land on the moon while some of the Apollo astronauts are still alive. I really hope that happens. It would really suck if none of the Apollo astronauts are around to see us refly to the moon. I think we owe it to those guys, if you want my personal opinion on it. To live forever. Well, Elon might figure out a way to do that. Who knows? All right, let's read this RFI. Through this RFI, the National Aeronautics and Space Administration is seeking industry feedback in advance of the development of NASA's Human Landing System Lunar Exploration Transport Services acquisition, which is being accelerated to meet NASA's needs for a routine cadence of human transportation services to and from the moon in the late 2020s. Huh? Consistent with law and national space policy, NASA is seeking commercial partners to provide routine transportation services to the moon from the Gateway Lunar Outpost in the late 2020s. Therefore, NASA is seeking input on how to enable U.S. industry readiness for this endeavor. At an informational briefing to industry on May 3rd, 2021, NASA will provide high-level acquisition strategy information consulting of the LETS acquisition definition, general structure, and draft acquisition milestones. NASA will also present potential acquisition activities anticipated to occur prior to the LETS LETS solicitation, including a potential new Next Step 2 BAA, or Broad Agency Announcement, appendix to enable early engagement with U.S. industry on sustaining requirements, development, and risk reduction activities. This RFI contains a series of questions for industry in Section 5 regarding NASA's early broad agency announcement engagement approach. At the May 3rd briefing, NASA will also provide details on potential BAA appendix content. Everybody got that? That was a lot of lawyer speak in there. And even worse, the lawyer speak is mixed with engineering speak, so it's like doubly as hard. So you're getting your appendix out? Yes. That's exactly what's going on. Your surgery is ready. Did you know, Odin, that they did surgery on a grape? They did surgery on a grape. Let me just reread it once again to make sure that I understand this. Will there be a quiz? Because my brain just checked out. Yeah, I mean, I did too. An informational briefing to industry on May 3rd, 2020 will provide high-level acquisition strategy information consisting of the LETS acquisition definition, general structure, and draft acquisition milestones. NASA will also present potential acquisition activities anticipated to occur prior to the LETS solicitation, including potential new Next Step 2 broad agency announcement appendix to enable early engagement with the U.S. industry on sustaining requirements, development, and risk reduction activities. So basically what this RFI is making amendments to the BAA, the Next Step 2 BAA from NASA. Now, first of all, what is a BAA? What's a broad agency announcement? A broad agency announcement is a nice way of saying NASA is announcing that we're going to do this. Who wants to help us with this? We have a contract to NASA would have a broad agency announcement, for instance, for landing people on the moon. The lunar lander, the HLS contract, had a broad agency announcement. Now, Next Step 2 is a little different of a BAA. Next Step 2 is basically technologies that we could use to go to the moon easier, basically, like on-orbit refueling, in situ resource utilization. So it looks like they're roping the Lunar Exploration Transport Services RFI into the amended broad agency announcement for Next Step 2. Once again, the Next Step 2 is NASA's program to develop ways to get to the moon, to live and work on the moon easier. SpaceX, for instance, does have a contract with Next Step 2 that includes on-orbit refueling, for instance. That contract went to the Starship program, believe it or not. SpaceX was awarded a multi-million-dollar contract to pioneer on-orbit refueling for NASA under Next Step 2. So it looks like these strategies that they're working on in Next Step 2 will eventually lead to Lunar Exploration Transport Services. The second part of that legal jargon basically said that we're changing the broad agency announcement to include transport services to and from the moon. And we basically amended the BAA a little bit so we could talk about what we would need to do to get the Next Step 2 technologies to be fully fledged lunar transportation services, like what we need to do that. Once again, this is an RFI from NASA. An RFI from NASA is basically NASA, pinging at everyone in their Discord, so to speak, saying, hey, if you guys wanted to move stuff to the surface of the moon, how would you do that? Broad agency announcements are basically NASA, instead of NASA saying, hey, how would you do that? A BAA would be like NASA saying, hey, we're going back to the moon. If you were going to build a lunar lander, how would you do it? RFIs and RFIs are basically lead into broad agency announcements, but it depends on how far a program gets. Once again, it's very interesting that this LETS solicitation has an amendment to the Next Step 2 BAA appendix, which is very interesting. It's very interesting that they're roping that into Next Step 2. That's interesting, to say the least. RFI is almost quite literally a huge question panel, a big series of interviews between NASA and interested companies. This kind of sounds like HR 5666. Different thing, Ryan. HR 5666 is not NASA internal. That's legislative. So, like, NASA would release these broad agency announcements and requests for informations based off of what was signed into law for them to do. So, okay, here's how this works. The president says we want to do this. The House says, how much is that going to cost? And the president says, oh, I think it's going to cost this much. And the House says, okay, we can give you this much, and is this good enough? And if it's yes or no, right, you know, it'll go over to the Senate, who will ratify it into law, and then it's NASA's job to get it done. If they don't get it done, they break the law. That's the accountability in NASA. You have to... So, for instance, if they don't put SLS on the pad, they're breaking the law, and people can be arrested. The answers to those questions, to those NASA questions, says Rocket Guy, then go to make the requirements for an RFP, which gives us a phase 1 selection to build prototypes. Cool. So are they asking SpaceX directly or asking National Team and Dynetics too? I don't know. This first part is really general. Let's see what the latter part of Mike's thing says. All human landing systems will need to include the elements and or systems necessary to transport crew from Gateway in a near rectilinear halo orbit to the surface of the moon to enable crew to perform EVAs and return the crew safely to Gateway. This includes an integrated lander with launch vehicles and NASA-provided spacesuits. Well, Ryan, there's your answer about the spacesuits. We had that answer somebody asked that the other day. Is Lunar Starship going to use NASA spacesuits or are they going to use SpaceX spacesuits? Well, there's your answer. Along with any refueling elements needed to support reusability. NASA plans to define, solicit, and award LETS or LETS contracts. Okay, hold on. Let me reread that sentence. NASA plans to define, solicit, and award the LETS contract to one or more industry partners through full and open competition. Through the LETS contract, NASA plans to utilize additional human landing systems to provide service transportation missions to the lunar surface in the late 2020s. Huh. Let me keep reading. Prior to the LETS solicitation, NASA plans to offer partner engagement opportunities to support early sustainable lander requirements development and concept risk reduction activities. Basically figuring out ways to do it that are simpler so people don't get killed. Yeah, they're going to work on that before they start working on everything else. That was the plain English way of saying that. At least I'm pretty sure. NASA currently plans to issue a new appendix against the Next Step 2 broad agency announcement to fund selected partner sustainable development efforts beginning in 2021 and lasting approximately 7 to 12 months or until the LETS solicitation is released. The new broad agency announcement solicitation will be fully open to U.S. industry for competition. NASA will offer government subject matter expertise and appropriate resource utilization as part of the new broad agency announcement, along with direct HLS program engagement for requirements maturation and operations concept development. Each partner's proposal will require to detail the subject matter expertise and government facilities requested to develop their sustainable human landing system concepts and accomplish partner risk reduction activities. Hey, Rocket Guy, are you around? If you're around, do you have time to pop into Discord for a second? We knew this was coming. Basically, the HLS 2.0 is more focused on the reusability and follow-on, but I certainly didn't think it would come so soon. They did this for Apollo and, well, the shuttle as well. It's no problem, dude. No problem. Huh. So, Yeah, that's what I'm thinking, dude. Damn, dude, that's quick. NASA's moving very fast here. So, Rocket Guy, and once again,
Discovery, go at throttle up.
Thanks, Nez. Nice shirt, huh? I just want to make sure that I have this right here. NASA is... So, Human Landing System, the HLS contract, is, in the case of SpaceX, is designed for the research and development to have an unmanned landing of the lunar starship and then a manned landing of lunar starship in 2024. If I read this right, and based off of what you said, kind of put it into clearer words here. Once again, Rocket Guy works in the industry, so he understands this a little bit better than I do. If I'm understanding this right, this is for additional lunar landers. Yeah, this is for additional lunar landers, and it is open to any competition. So that means that in the future, so NASA basically bought 2 lunar starships with SpaceX for the HLS contract. This opens the door for them to be able to buy A, more lunar starships, or B, national team lunar landers in the future. They're basically getting all the lunar landers figured out for all the missions to the moon for the Artemis program. Wait, so HLS was not for the long term? That's right. It was only for 1 unmanned prototype Blinga and then one landed prototype. Overdrive, 28-month resub. They knew people would be mad about the single contractor for HLS, so they had this thing ready. But will splitting it up to 2 parts bring more funding? See, this is where I'm getting a little confused. Why wouldn't they just have... So... They roped this under Next Step 2, which is interesting. That's a really weird thing to do. Next Step 2 is about developing the technologies needed to go to the moon sustainably. I honestly didn't think that NASA would throw in actually going to the moon sustainably into the broad agency announcement for developing the technologies to go to the moon sustainably. I thought they would change the appendix to HLS to change it from sole source provider after the first 2 missions to basically anyone. It's a very interesting move from NASA, but it makes sense. What was the U.S. Congress's bill number for returning to the moon and Mars? 5666. Yep. Didn't the contract say something like forms of transportation to the moon, not to land? No, it said to land, Swishio. Yeah. I honestly kind of wish that NASA included Canada in the ESA in that announcement. What? All right, I'm not sure why you think that, but okay. What are we just talking about? I just got back. So NASA released an RFI for a program called Lunar Exploration Transport Services. This is brand new news. This came out like an hour ago, or 2 hours ago, I should say. They introduced RFI for Lunar Exploration Transport Services. Basically, this is acquisition of landers for after 2024, right? For 2024 to 2030, right? So you want to hear something interesting? So in the RFI, the RFI includes a broad agency announcement amendment to here. This is the weird part. It includes a broad agency announcement amendment to Next Step 2's broad agency announcement. So there, in this RFI, there is a thing to basically add lunar exploration transport services into Next Step 2's broad agency announcement. That's weird. That's a weird way to do. I don't understand that. Like, why would? It's bizarre. This wouldn't have anything to do with Grandpa talking tonight, would it? I don't know, Grima. I don't care. Well, not I don't care. I don't know what he said. So I can't comment on it. I have no idea. It'd be nice if this was a joint agency mission. Yeah, okay. joint agency mission. The human landing system is already part of the Artemis program, which is a joint agency mission, guys. I don't know why it's inclusive all the time. Oh, I'm sorry. I didn't know it was NASA's job to make other countries money. They do it anyway, but not with everything. Yeah, that's what she calls him, Brian. Is this a good or a bad thing? Ryan, it's interesting. It's very interesting. NASA wants to do something like what they did with SNC when SNC got angry because they didn't get chosen for a commercial crew program, so NASA gave them commercial resupply. Yeah, but Forge, I agree. It very much is like that. But this is for human landing systems. This is for human landing systems over a long period of time. This contract could potentially be worth way more than HLS if you really want to know. I don't understand the play, to be honest with you. TJ, I think you might be right. I think that NASA... Okay, this is the speculation part, okay? Sorry if you've answered this already, but what's your take on the Chinese-Russian partnership for a new space station? If you really want my honest opinion, Ivo, it was foolish to think that the Russian space program would just pawn up to the Gateway program and not be an equal partner to it. It was foolish to think that we'd shut them out like that. Well, not shut them out like that. Offer them one module for the Gateway. They don't have the rocket to be able to reach the Gateway, so that means Russia would have to fly on SLS, basically rendering Soyuz useless. They could move it to, and then getting rid of the International Space Station at the same time doesn't make sense for them from a financial point of view. I understand that. There could be some Rule 8 nonsense involved, but yeah, I understand it. I don't really like it, I'll be honest with you. I'd prefer that we work with the Russians. I think the Russians have a unique perspective to add to the space program that we wouldn't get with just the kind of regular players in the international, with international partners, but also at the same time, you know, the Russians have unique perspective because they launch people into space too. Yeah. I'd rather work with them and international partners, and China can do it themselves, but that's not how that played out. So, oh well, I tip my cap. I respect the Russian program. If that's what they want to do, that's what they want to do. I'm not going to get bent out of shape about it. That's just kind of how it played out. Hopefully we can keep working together in other ventures and stay respectful up in space. So, NASA just wants to buy time. They don't have the funding. I very much disagree. I think, so this is the speculation part. No, Forge, no. I don't need to see last. I just answered it. The stream is started for the launch in China today. It looks like they were doing an official launch stream. We tuning in. When it goes to launch, sure. We have a Vega launch before that, though, Colonel. I lost my train of thought. You guys changed the subject. Let me rewind a second. Let me think of where I was. Okay, so with NASA, they chose to expand Next Step 2, which is weird. Next Step 2 is a broad agency announcement that NASA has about developing technologies for sustainable lunar presence. So it seems a little peculiar to me, and once again, keep in mind this is speculation on my part. I don't know. This is getting into like, it seems weird that they would rope that contract, the contract for more lunar landers, under Next Step and not under HLS, which is the Human Landing System. They're basically roping Human Landing System block buys into the Next Step 2 program, and the Next Step 2 program is for sustainable lunar technologies. It's weird. It's like, it would be like, that's like going to a tire shop for your car and asking for an oil change. I mean, I guess if they have extra tires, you'd be able to do it. But it's very interesting that they're doing that. It's a very interesting play from NASA, to be honest with you. And this is the part that I don't really understand. Why would you do that? Why would you? If I had to guess, and this is a big guess, if I had to guess, they would NASA, you wouldn't want one big fat contract to land stuff on the moon, to land people on the moon, and then land more people on the moon after. You would split it up. I would do that. You would get a demonstration, right? And then have the opportunity to down select that or another one and have sustainable presence on the moon for a long period of time. But the fact that NASA roped this RFI for sustainable human lunar exploration from basically 2024 to 2030 under Next Step 2, that sounds like they're spreading contracts around. And spreading contracts around like that might be a better way to basically have your cake and eat it too, so to speak. Jim did this before, and Charlie Bolden did it before him as well. Charlie Bolden, when the NASA administrator from 2009 to 2015, when Commercial Crew was awarded in 2014, they awarded it to SpaceX and Boeing. There were actually 3 competitors. And one of you guys already said this in chat. There were 3 competitors. There was SpaceX with Dragon, Boeing with Starliner, and Sierra Nevada with Dream Chaser. Now, Starliner and Dragon got picked. But what NASA did was they didn't want that technology to go to waste. So they found ways to rope Dream Chaser into ISS resupply missions. And Dream Chaser will fly a resupply mission along with Cygnus and Unmanned Dragon 2 starting basically at the end of this year, early next year, for resupply flights to the ISS. We have 3 resupply vehicles now. NASA found a way to get Dream Chaser flying into space. Even though it's not with people, it's the next best thing. And they did that by taking Dream Chaser from Commercial Crew and moving it over to Commercial Resupply. And they basically ended up getting almost, 2.5 ways to get people into space instead of just 2. Now, a lot of folks don't know, and this is from the chief engineer on Dream Chaser's mouth exactly. Unmanned Dream Chaser and manned Dream Chaser have 95% part commonality, which basically means that unmanned Dream Chaser is a Dream Chaser without windows and seats and a control panel. That's it. That's the only difference. Doesn't have windows. Doesn't have windows, doesn't have a flight stick, doesn't have a seat for somebody to sit in. They have 95% commonality, which is insane to me. That's ridiculous. But that's not an accident. That's why I say that they basically got 2.5 ways to send people into space. Dream Chaser would need to be fleshed out and qualified if they ever wanted to launch people on it, but it still could be done. So it sounds like NASA put HLS, the RFI for Lunar Exploration Transport Services, it sounds like they put it under a different broad agency announcement to spread the contracts around so NASA can get more money. That's just an opinion, though. A bit confused. Isn't HLS under Next Step? Is Next Step 2 a separate thing? It is. Yeah, it very much is, Phil. I think this is NASA spreading contracts around so they can get more cash. At least on paper, it looks like, oh no, we're not, this contract doesn't have all the cash. They spread it around on purpose. There are incentives for NASA to do that. Seems like they're roping it into another bucket for budgeting purposes. Boom. That's right, Novus. Or they're tacking on to an existing BAA to hit the ground running. It could be to keep the other competitors, competitive. A $3 billion contract is quite the head start, though. Novus, that's what they're doing. I'm pretty damn sure. Based off of what you and Rocket Guy said and what I'm thinking, NASA's going to find a way, even though they had to sole source SpaceX for the lunar lander, they're going to find ways to get other landers on there. You do not want one way to get to the moon. That's dumb. That's a really stupid way to do it. And fortunately, with commercial contracts, instead of NASA developing in-house like the Apollo program, with commercial contracts, you could basically get 2 landers for the price of 1. You could get 2 commercial landers for the price of what it would cost 1 lander to be done in-house. They basically will find that NASA's they're trying to worm around and worm logo. They're trying to worm around and figure out a way to get 2 human landing systems on the books. I'm pretty sure that's what they're doing. That's pretty cool, man. That's good. That's what we want. Because the only thing better than one way of landing on the moon is 2 ways to land on the moon. Interesting. HLS is to land, do an unmanned lander test, Ryan, and then a crew landing test after that, and then this contract to land. And then this contract is to land people after that. Yeah, that's correct. And there's very explicit wording in there that Mike chose to show. There's very explicit wording in there that shows that the HLS contract is not necessarily open to just HLS competitors. So, National Team and Dynetics. NASA's trying to find a way to get all the lunar landers funded. That's what they're doing with this. I'm pretty dang sure. And keep in mind, that's just me thinking of, like, I'm just guessing. That is a huge guess on my part. It's very much an opinion on my part. I'm not 100% like, I'm not a savant when it comes to NASA contracting, and I'm not a savant when it comes to legal jargon and the application of spaceflight, okay? That's just a guess. It seems like a guess so NASA can get other lunar landers on the books. And if they can get them on the books, once you get something on the books, it's extremely hard to get rid of it. What about allowing Boeing to re-enter? Boeing could also compete again. What are you guys talking about? Yeah, B-Monies, that's not how that works at all. The president doesn't fund NASA, the House does. He comes up with the plan, and they basically say, yeah or no, that's dumb. So, yeah, that's irrelevant. Hey, Toa, what's going on? So Starship would be for people, and Blue Origin would be for cargo and base development, maybe? Well, Sneaky, they explicitly say that this contract is for human landings as well. It's HLS. It's basically, yeah, human landing systems. Interesting. Yeah. So, Sneaky, this would be the block buy. Understand? That's basically what it is. It's a block buy for lunar landers. That's what NASA's trying to get on the books. No, Sneaky, that's what I mean about spreading the contracts around. Sneaky, that's why I like Jim so much. But it's really interesting because Jim isn't here anymore, but it's still happening. Huh. I wonder who's perpetrating this. I'm genuinely curious. Because this is a Jim tier move. But all of Jim and his posse left. So who the hell's doing this? It's almost as if Jim recommended a great guy. Bill is not in NASA. He doesn't work for NASA right now. You think it could be Steve? Could be Kathy Leaders. Yeah. Could be. But my question is, all right, here, let me just look. Let's do some exploring. How fluent is Kathy Leaders in Rule 8 stuff? I'm just genuinely curious. He's an American engineer and business manager. Okay. Leaders is currently leading NASA's human spaceflight program as the associate administrator of HEOMD. See, so for the people that don't know what the hell that means, she runs NASA's human spaceflight program. And don't get me wrong, like, don't say, like, oh, no, Kathy does a great job. She's a damn good engineer. I've heard her talk. So if you're wondering, what, her resume before this, Kathy was running the commercial crew program up until basically 2020. Yeah, so she oversaw SpaceX's Dragon capsule and Starliner, if you're wondering. Yeah, she's plenty qualified for that position, just in case it was on anybody else's mind. Kathy grew up in Japan. Her family was living in Tokyo when the Apollo 11 moon landing occurred. She remembers her dad waking the whole family up for the event, and she read Isaac Asimov as a kid. In her undergraduate degree, Luder studied business as she had aspirations to work on During her senior year, however, she wanted to switch to engineering after seeing her roommate study it. She also became interested in engineering because it gave me the tools to solve problems and work on something bigger. Accurate. After getting married and having 2 kids, she returned to college to study engineering. She also has been raising children born after she completed her master's degree. Oh, no big deal. Yeah, Kathy, well, guess what? I made my bed today. Guess what? I made my bed today. Boom. Boom. Deal with it. She has a bachelor's degree in business administration from University of New Mexico in 1986. She also has a bachelor's of science and a master's of science in industrial engineering from New Mexico State University. Interesting. All right, let's read. After graduation, Leader studied as the depot manager of the Space Shuttle program's orbital maneuvering and reaction control systems. She was the Commercial Orbital Transport Services Integration Manager, and she has also held several managerial positions within the ISS program at Johnson Space Center. She also managed the commercial cargo resupply services to the station and was responsible for oversight of international partner spacecraft visiting the space station, including the European Space Agency's Automated Transfer Vehicle and JAXA's H-2 HTV transfer vehicle, and the Russian Space Agency's Roscosmos-Soyuz and Progress spacecraft. Okay. She went to Kennedy Space Center as the acting commercial crew program manager in 2013 and was selected as the head of the office in 2014. As this was NASA's first venture into commercial human spaceflight, Leaders brought her knowledge of experience from CRS to the formation and management of the commercial crew program. Leaders managed a NASA team working with SpaceX and Boeing teams concurrently over several years, and she was the CCP manager when SpaceX launched Demo 2, the Demo 2 mission on May 30th, 2020, to the first human launch from U.S. soil since the retirement of the space shuttle. And then Jim put her as the HEOMD on June 12th, 2020. Okay. Now, a business degree doesn't necessarily translate into Rule 8 speak, but it's pretty damn close. Any contracts that would come out of this would be about $15 million, so it's not breaking the bank. It would definitely allow Blue Origin and Dynetics to continue their preliminary design for landers should they land it. That's not a lot to do, a ton of hardware testing for technical risk reduction, but it could be doable. Interesting. I mean, yeah, I don't know where this is coming from, man. That's a really smart idea to rope it into Next Step 2. Yeah, NASA's basically figuring out a way to get more lunar landers on the books. That's exactly what's going on here. This was probably always the plan. They just couldn't say anything. Yeah. Silly, I'll be honest with you. I think this was a contingency. This is very peculiar. It's very peculiar for NASA to change... For NASA to change a broad agency announcement appendix this much. Like... Yeah, that's... Yeah, that's crazy. That's good. That's good news. It's good news. It's good. Don't get me wrong. That's really good news. If they can get... So... If NASA can get the three lunar landers, all three of them, on the books, it's only a matter of time. Because once NASA gets something on the books, it is extremely difficult to get rid of. Case in point, Space Shuttle, ISS, Hubble Space Telescope. Case in point, see what I'm talking about? Once stuff gets on the books, especially once it reaches a high level of development, and especially if it's launching stuff into space, then it's really tough to get it to change. So, and that's, once again, that's by design. That's one of the things that we have in place to make sure that NASA's plan doesn't freaking change every 4 years. It's this type of stuff that protects against that. Dude, that's ballsy. That's a ballsy freaking move. James Webb, yeah, for the wrong reasons though, Mutter, but yeah. VentureStar would like a word. VentureStar didn't spread the contracts around enough, Gaw, so it was very easy to get rid of it. That's cool, man. That's really cool. That's really smart. So the other company's going to keep prototyping? Bagel, this gives them a way to do that. That's what I mean. It gives them a way to keep doing that. If they spin it off, if NASA spins it off as, oh, tech that could sustainably get us to the moon, yeah, that's what that's doing. It could potentially keep the other two landers on the books. So you have SpaceX, and then by the time SpaceX is done with the demonstrations, that's when you shift that money from demonstrator missions to operational missions, and you use that to fund the other landers. Exactly what they did with Dream Chaser. That is exactly what they did with Dream Chaser. Once commercial crew contracts were awarded, they awarded the development, and the funding went like this for commercial crew. Because every NASA program works on a bell curve, and the peak of the bell curve is development. Once you start transferring over into operational missions, your budget for it actually goes down. Because it's cheaper to launch rockets into space than it is to build them and develop them, right? So once SpaceX's HLS contract, once they demonstrate that they can land on the moon, the funding for HLS will go down, and if you ramp up funding for this, for lunar exploration transport services at the same time that you spin down HLS, yeah, we have a funding increase, and yeah, we need multiple ways to get to the moon because it's more sustainable that way. Boom, funding for all three landers. SpaceX just has a little bit of a head start, a $2.9 billion head start, but that gets 3 lunar landers, or 2, or 1, or whatever, or 1 extra on the books. That's cool. That's smart. That's a really good move. That's really, really smart from NASA. That's a dude. Whoever thought of that is really smart. That's a really good move. That's what I would do. And I'm not saying that I'm as smart as NASA, but spreading the contracts around is something that I learned from watching this guy talk. That's what NASA needs to do. It worked with James Webb during the Apollo program, and Jim did it to help get the Artemis program going. He spread everything around. Tried to include as many frigging people as possible. It doesn't matter if, they're doing SLS aerodynamic testing at Ames in California, and then they're doing mechanical testing at Marshall in Huntsville in Alabama. That brings everybody on board. You could make the argument that it would be easier to do everything, under one roof and vertically integrate. But NASA is spread out like that on purpose. That's one of the reasons why it stays around. It's very hard to get rid of. I don't think that's ever going to happen. Knock on wood. Huntsville gang. Yeah, Rocky Guy, I don't think it'll necessarily impact this in terms of moving the timeline up if they can definitely potential to have bad side effects if Artemis gets funding trouble. Yeah. Funnily enough, it did not work for James Webb. Yeah, right? Yeah, no. There is case circumstances, right? But anyway. Space News went super late, guys. I kind of did that on purpose. I'm not. I need some time off from KSP. I power grinded KSP out last week, so I'm just gonna keep going with the Space News until the rocket launches, and we're gonna go from there. I'm surprised how determined they are to hit the 2024 landing, though. Yeah, Phil, I'll admit I didn't see that coming. That's right, B-Money. That's correct. You know, everybody says, oh, NASA's just a jobs program. If you spread it out like that and you actually have a good deadline like 2024, that jobs program works for you. It works in your advantage. It doesn't work against you. This is why it's so important to have these short-term deadlines. And I don't think it's any coincidence that these short-term deadlines also kind of coincide with presidential terms. It's not a coincidence. It's not a coincidence. It's smart. That's a smart way to do it. You deserve a break? The hell? Yeah, from Kerbal, yeah, but not from streaming. All right, anyway, next news here. So this is coming from Joey Roulette over at The Verge, who previously worked at Reuters. What's Joey saying? SpaceX's SN11 mishap investigation remains open. An FAA spokesman said just now, it's been very close to being finished since last week per source, okay? Deleted a previous tweet indicating that SN15 can't launch until SN11's probe is done. That's wrong. The FAA can approve SN15 for flight as long as the safety review portion of the SN11 probe is complete and didn't turn up any concerns. There's no public safety determination in the SN11 investigation. No public safety determination in the SN11 investigation has been made yet, and SN15 hasn't received its license authorization yet per an FAA spokesperson. SN15 has some new things on board. It's not identical to 10 or 11, hence the ongoing license review. Interesting. The goal that you don't work towards is just a dream. Well said. How about Microsoft Flight Simulator? I'm good. Not right now. Interesting. That was actually some pretty solid reporting from Joey. One thing that I think, and this is just kind of a personal thing, the mark of a good reporter is being able to admit when you're wrong. Joey just gained some points in my book, dude. Good job. Joey just gained some points in my book. I don't know why people are amazed that this is taking longer considering the SN11 had a rud in the air instead of on the ground. I think that's arbitrary, Green. I mean, a failure is a failure. I don't think that's what makes the difference. I think that 15 is very different, and it's going to take the FAA time to understand what's different about it. I think that's why it's taking a second. All right, K-Mir, see ya. FAA is going to delay to 2024 because of how slow they move. Guys. All right, I'll say it once, I'll say it again. Stop. Look, stop barking up the FAA's tree. Stop it. Just don't do that. That's not you don't want to do that right now. Why? Because the FAA controls what launches into the air, okay? Now, and I know what people are going to say, SpaceX goes too fast, they're slow, and they're inefficient. No, the FAA a couple of months ago had new legislative architecture designed for rapid prototyping. So, trust me, it's going to take some time for them to get up to speed, but they will get up to speed. And then there's one more thing. Sounds like the FAA might be stonewalling and dragging their feet. I don't think that's what's going on, guys, to be honest with you.
Discovery.
Yeah,
go
that's what
throttle
I'm
up.
looking for. That's what I'm looking for. I mean, I've said this many times, and people called me an idiot for saying it, but I'm looking for the tweet. Elon basically said, "Don't bash these guys. They're working on it. They're getting there." We'll be watching the Vega launch. No, I don't like rockets anymore, Thorin. I'd rather go watch paint dry, honestly. Yeah, rockets don't really do it for me. You could tell by my background. DPIC 7-month resub. Thanks, fan. Ugh, I'm not reading that on stream. Well, oil takes a long time, Mutter. Oil paints take a long time to dry. I'll go with watercolor. Watercolor's fine. I'm trying to figure out where Elon's tweet is about the FAA, but I can't figure it out. I can't find it. He basically said, stop barking up these people's trees. Yeah, there you go. I got it. Thanks, guys. Like, I think I said it once before, like I said it like months before this damn tweet, but he's right. Stop it. Stop it immediately. They're working on it. It takes a second. The fact that we've seen as many Starship tests that we have is a testament to them willing to adapt. And once again, your boy agrees with me. Stop it. Get some help. See? So, once again, trust me, they're just trying to figure out the new architecture for SN15. That's why it's taking a second. But, what is it going to take? A week? A week at most? A week? SpaceX said they intended to launch SN15 late last week, and it looks like they're going to launch it a week later. And the vehicle is basically totally different. It has totally different plumbing, totally different Raptor engines on it. Hey, for a government agency to take a week to sign off on this is pretty damn good. That's pretty freaking good. Don't get me wrong. I'd love to sit here and call the government incompetent as much as the next guy. You know, bloated piece of crap, blah, 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 but that's not what's going on here. The FAA, like NASA, is one of those agencies I think is a very good idea. That's a good call. Coming up with standards for how you should fly things so people aren't getting killed. That's one of the reasons why air travel is so inexpensive. Because they standardized what it takes to fly people around on a plane. And now they're doing the same thing for rocketry. Guys, in 10 years, if this goes the way I see it going, and if it goes the way that Elon thinks it's going, taking a flight into space might be as cheap as a plane ticket. It is going to take some time. But 10, 15 years? It's possible. That's what Elon Musk sees. Now, I don't know. I don't know if it's going to go that fast. It might. It's possible. But yeah, part of what NASA did in the past is part of what NASA did in 2018 is basically they didn't deregulate the industry, but they made it so all the different people that you have to talk to launch something into space are under one roof, to make it easier to launch things into space so you don't have to go all over the place. That will tremendously bring the cost of, like, for instance, rapid prototyping down. That's a good thing. That's what we want. We didn't have to say Federal Space Administration. Well, we can't do that, Sneaky, because that implies that we own the space around Earth. That's, I'm pretty sure there'd be some people that would have a big problem with that. Space gets treated like international waters. And anything that's flying around in space is beholden to the point of its home port, basically point of departure, like a ship. So an American rocket that's up in space is subject to the aviation laws from America, from the United States. Russian rockets with Russia, Chinese rockets with China, etc., etc. I have an idea for the town hall. It's inspired by Huntington Ingalls HQ and Newport News. Each floor can be a different division of the city. Where do you want to build it? Sorry if I missed it earlier, but did you talk about the Chinese launch? Yes. I covered a lot of ground today, guys. We covered a lot of ground. SpaceX should move to Liberia. Uncle Sam won't allow it. ITAR. I want to be able to suborbital hop from New York to Tokyo in 45 minutes and do it cheaply and reliably. Fall, 20, 30 years, man. That could be a thing. Very much. We're laying the seeds for it to be a thing right now. That could be a thing very soon. So what happened if you build a rocket on another world? I don't think we've gotten that far, me man. I think, once again, beholden to whoever built it there. So if we build a rocket on another planet and Americans built it at an American base, it's beholden to American laws. Guys, think about this. Like, go back 100 years ago. 100 years ago, so 1921, right? Think about the time difference in technological changes from 1921 to 1960. That's 40 years, or 39, all right? From 1921 to 1961, we went from flying around with planes that are made out of canvas and wood to 1961, launching people into space, okay? Now, don't get me wrong. Technology progressed very fast over those 40 years for a number of certain reasons. But you see SpaceX progressing at that same exact speed. So if Elon Musk is allowed to do what he needs to do unfettered, I don't see it as unreasonable for SpaceX to be able to get that Earth-to-Earth down in our lifetime. It could happen. Yeah, absolutely. I'm not gonna say it's gonna happen because I can't predict the future. If I could predict the future, I would have a sports almanac and I would be rich. Okay? But I see a pathway to it. That's definitely doable. Wright brothers to the Apollo program happened in one lifetime. Back to the Future, huh? Well, I mean, Starship is made out of stainless steel, tweets, and the stainless steel construction is easier for flux dispersal from the capacitor, so it actually makes a very good time traveling venue. And you don't need to worry about Starship not getting to 88 miles an hour. You can use frankly, you don't even need a Mr. Fusion. Starship could collect the plasma from reentry and use that energy through a transducer to generate electrical power and jump through space and time during reentry. Fourth dimensionally, it would work because there's nothing but air there. Even if you go to any particular point in history, it's not like you're going to fly into a mountain or something, right? See? Stainless steel construction for flux dispersal is very useful. What I just said does not exist. That was a reference to Back to the Future. Just in case anybody's wondering. You would have to be Biff too? Sometimes you gotta make some sacrifices. That's fine. Lunprod. Right there? You're telling me right there? You want to build it right there? Go ahead. Do it. Make it happen. Do it. I like it. It's a good design. It matches the other buildings. Do it. Somebody else wanted to build a town hall there, but I haven't heard anything from them in like a week, so we'll build it there. If they want to build another town hall, build it a couple lots down. Slackster, 8-month resub. Honestly, Starship might be able to reach 88 miles per second. That's a little fast. Maybe from a lunar reentry. Yeah, maybe. Warp drive is not a thing yet. Well, yet. Okay. So last bit here. Biggie had a 33-month resub in there. Thanks, man. Okay, so we got the Vega launch in about 30 minutes here. I gotta move Jim out of the way so I can see the clock. All right, so we'll finish this. We'll finish up a super long space news with looking at what's going on down in Boca Chica. This video is coming from NASA Space Flight. Boca Chica gal Mary is down there every day filming these videos for us. So be sure to go over and support NASA Space Flight when you can. it is very rare that I will ever say this unironically, but go over there, like and subscribe, and seriously buy some of their merch. I'm dead serious about that. They allow us to freaking... NASA Spaceflight lets me watch this footage over here, so we better do our damn due diligence and go and support them. Looky Boogie Live, thank you for the raid. Looky, what were you up to? Wait, you raided me the other day, didn't you? I think you did. Oh, crap, I forget what you were doing. Lukey, fill me in. Stream starts in 2 minutes. Cool. Raid. What's up, Lukey Raiders? Business as usual. This is the third raid. Yes, okay, all right. Lukey, I'm not going to lie, I get raided by a lot of people. And I sound like such a D-bag when I say that, and I fully acknowledge it. But yeah, no, I do my best to keep up with it. I get raided a lot. But thank you. I do appreciate the raid. What were you up to? I just went to test drive a 5.0 Mustang today. Yeah, that Coyote motor really screams, man. I love NASA. Did you see the pictures on Mars? Yeah, of course. Yeah. They had a picture from Ingenuity today looking at Perseverance, and you saw Perseverance just sitting on the sand. That's probably one of my favorite pictures that I've ever seen from Mars. That's for sure. Can someone explain what we're doing here? So, guys, coming in from Lukey Pookie, and if you're just coming in from wherever, I'm EJ. I'm a STEM streamer here. I stream primarily about spaceflight. I don't know if you can tell. I cover like how rockets are built and how they get made, and every day we do a segment called EJ's Space and Rocket Review, where I talk about what's going on in the spaceflight industry, like what NASA's doing, what they're working on, particularly in like the application of rockets, like sending people up into space. I don't generally deal with like the planetary science stuff too much, but we do cover like stuff like Perseverance, which is planetary science. But yeah, this is the space news segment where we go around and see what's going on in the spaceflight industry. But what I primarily do is play Kerbal Space Program, and I use Kerbal to teach people about space. Yeah. You missed SN20's aft dome. You're a dome. So that's SN20's aft bulkhead. Now what we're doing right here is looking at SpaceX. So my buddies over at NASA Spaceflight, which is a YouTube channel and a spaceflight news outfit, very pretty one at that. Hey, one hop. No, they allow me to go and look at and look at this footage on stream. What we're looking at is down in Texas. This is SpaceX's Starship factory down in Boca Chica, Texas, which is near Brownsville. It's at the very southern tip of Texas. We have daily footage coming out of there that we can look at on stream, so that's what we're going to do now. And then in about 20 minutes, actually about 30 minutes, we have an actual rocket launch going off that we're going to cover. Yeah, Pagan, I don't know how that happened. SN16 nose cone is stacked on the barrel section. So this is the forward segment of the next Starship coming here. Yeah, Gagan, right? Interesting. Yeah, I suppose when you look at it that way, you're just realizing that Biff was smart to invest his initial sports bet winnings into a business. Lots of people who come into money like that blow it all on stuff. The Almanac was just a kickstart to his business, to Biff Tannen's business, and his business has got him rich. That's a good thing for him because due to the butterfly effect, the Almanac would probably become less accurate over time. Huh. That's a very good point. Is Biff the bad guy? Wait. Is Marty McFly the baddies? Are we the baddies? Gagan, are we the baddies? Okay, Blinga. hands? Are we the baddies?
Discovery, go at throttle up.
I mean, Biff wasn't a good guy. I mean... Are we the Biffies? Crew 1 returns on Saturday, Clayton. They leave the space station on Friday. Huh. SN-17 will have a huge tile patch on the barrel. That's between the nose cone and the tank section. Yeah, yeah. Huh. I mean, he did help Lorraine out when George died. Oh, no, yeah, nope, yep, okay, yeah, he didn't help her. Yeah, okay, no, he's a dick. Yeah, yep, okay, good businessman, but also dick. Yeah, okay, sorry, it took a second to turn the gears there. Yeah. Yeah. He is also an advocate for private police forces. Yeah, nope. He is, in bird culture, he is known as what would be called a dickhead. Yeah. 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 Okay. Yeah. Yeah. Biff. Yeah. Biff's. Yeah. No, he's a dick. Yeah. Okay. Cool. Good to know. Back to the space flight. I don't know, Wookie. Maybe. There's new rolls of stainless steel being delivered. Yeah, that's true, Dead Crew. Yeah. Product of a broken home. That's not good. Is the upcoming one SN-15? That's correct, user. Mm-hmm. Who's Biff? We're talking about Back to the Future. It's a picture of the build site here. Sorry. Okay, so this thing right here is ground support equipment. So, an interesting thing for the folks that don't know, if you go back and look at this thing, go back and look at this here. SpaceX is using the same assembly line to make the fuel tanks for the launch pad as they are for Starship. Because unlike other rockets that are made out of aluminum, Starship is using stainless steel. Now, don't get me wrong, there are other stainless steel rockets. But SpaceX is using the stainless steel that they use for Starship to make fuel tanks for the pad. So this piece of equipment right here that looks like a Starship is not. That's a fuel tank for the launch pad. The big indicator is, well, one, this has no wings attached to the side. And two, you have the vent lines with expansion joints going down the side. That's ground support equipment, or GSE. The serial number on that one, if I'm remembering right, is GSE-3. So it's a third fuel tank for the launch pad. Yeah, well, that's right. Yeah, true that. Was that an Austin Powers cart? It's an Austin Powers cart. Don't you go getting that stuck, Mr. Logistics Man. Don't go getting that stuck. You could block an aisle that henchmen could not get down. Wait, does that mean Elon Musk has henchmen? I'm just gonna pretend I didn't think about that. Aryan Space is live with rocket views, no commentary yet. Cool. George's like, I would be one of Elon's henchmen. Yep.
Discovery, go at throttle.
Captain Jack, 7-month resub. Happy to send this your way. Thanks for all the space hype food. My pleasure. Yeah. Okay, username.
Discovery, go at throttle up.
Peccadillo, 13-month resub. Thank you. $1 billion. He plans to go. Actually, it would be 2.9 billion. I will land people on the moon if you pay me $2.9 billion. I mean, I don't think he's evil. I love Elon. I think he's cool. Hey, Ernok, 44-month resub. Is the website down right now? It shouldn't be. I'll check though. Dodge, 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 dodge. So much dodge. There's so much dodge here. Not quite like this one with the dock of it. Whoa, what is that thing? Welder, Chevy. Oh, I believe it, silly. Oh, absolutely. Yeah, no. I mean, if you were him, would you? I mean, yeah, Justin, for sure. Can I flatten out some of the terrain on the lot? Yeah, go ahead. If you can't dodge it, ram it. Wait, what? You like dodge? You like dodge? You like dodges? There's COPVs back there. Cryotank shells at the propane production, the propellant production site. Well, I'll tell you, I'm sorry, I just see all this footage from down in Texas. I just want to talk about propane. Suddenly makes me want to buy propane and propane accessories, boy. So,
Discovery, go at throttle.
Interesting bit of kind of speculation. It very much seems like this for the propellant production area. This is a sleeve for the fuel tanks, and they're going to vacuum seal the fuel tanks to keep the propellants cold. Hey, Heavy Metal, 16-month resub. Thanks, man. But I'm not sure. I saw somebody suggest it the other day, and it certainly does seem like what they're doing. There's a big crane, Chungus crane. Yeah, Brendan Lewis did a render on it. So no double wall or outer insulation. Hellfish, see Brendan's render, please.
Discovery, go at throttle up.
Yeah, take a look. I've 34-month resub. Thank you. This is tank shell number 505. You could tell because of the way it is. Also, tank shell 505 is part of cryo shell 01445452-505. Yeah. Which was sold on eBay by Ladiesman217. Are you Ladiesman207? Parts of the integration tower at the propellant production site. It's an older code, sir, but it checks out. Jollyer's like, no, I'm not. eBay item 21153. Are you Samuel James Witwicky, descendant of Archibald Witwicky? How did you find me? eBay. Gaggin. The 100 bits, thank you. Alright, so that was a piece of that on the right, the big towery thing. No. Actually, so this is footage of the integration tower right here for Starship, and then this thing with the 6 posts right there is the launch pad. At least I think that's what's going on here. Well, not I think. That's pretty obvious. This is not the launch pad. You know how I can tell that it's a launch tower? You know how I can tell? Because it looks exactly like a damn launch tower, okay? Geez, it'd be really nice if we could, have a picture show up. It looks exactly like that. Yeah. See that? See that right there? Looks the same. Yeah. See? A lot of trusses, a lot of structure. Very structure-y. Such structure. Wow. So, guys, one thing I actually noticed about the integration tower. So this looks a lot like, looks like a launch tower, right? But I noticed that the tower has a lot of gussets attached to each horizontal member right here, okay? See all these little gussets that are attached to it? Now that tells me that this thing is either going to be plated or it's going to be clad in similar material that's used that they would use at Complex 39. So the reason why you wouldn't want to put a big flat surface on this and why you'd want mesh, and that's the same reason why with the Saturn V, the launch tower has a bunch of holes in it and why it's not a skyscraper sitting next to it, is because, well, when the rocket goes off, right, there's a lot of heat going on here. What does heat cause? Expansion. So it makes a lot of wind going off in different directions. And if this was a solid shape, right, all the expanding gases coming out of the rocket could push it to the, could make the thing sway at liftoff. I don't think I need to say why that's a bad idea. So they made it hollow. They basically made the whole thing hollow like an antenna or something. So the gases that are being expelled from the rocket, if there's any coming out horizontally, they can flow freely. I think that SpaceX is doing the same thing here. I think they're doing the same thing with this tower. Those gussets right there, see all these little plates that are attached to the horizontal members right here? I think those are going to be for adding a screen mesh, if I had to guess. Nice, or not? It looks good, man. They're building a lift that will go up and down for easy construction. There's going to be something heavy incorporated into that thing. The reason why you could tell there's going to be something heavy incorporated is look at the vertical posts. Look at how thick those are. There's going to be something on this that's going to need to be heavy enough to put a Starship stacked together. And also at the same time, if Elon has his way, there's going to be something that's strong enough on this to be able to catch a booster that's landing. So, you're going to basically have to... I mean, catching a booster with something that's 500 feet tall is... Yeah, you're going to have to build some structure into it. So that's why I think that the posts here are so ridiculously thick compared to something like the Saturn V's. The Saturn V LUT, which is, or Launch Umbilical Tower, which is the red part, is only holding fuel lines. It does not structurally integrate the rocket. That's done in the VAB, the Vehicle Assembly Building. This is just the Launch Umbilical Tower holds the launch umbilicals and the crew access arm. Now, SpaceX with their tower is aiming to basically do what the VAB and the Launch Umbilical Tower do at the same time. So it's going to be built up a lot stronger than the Launch Umbilical Tower on a Saturn. They're also putting beams that connect the sides of the center of the tower. Yeah, that thing is going to be strong, dude.
Discovery, go
Mufasa, 22-month resub. Thank you. And then there's SN15 over there with the tile plates on it. And then here's GSC 1 and 2. Ground Service Equipment 1 and 2 right there for the launch pad. Why is there a crane at the top of the Apollo Tower? Integrating payload, spacemen, if they needed to quick change out a payload. Or if they needed to integrate on the pad. It's there as a secondary crane, because why not? Yeah, Zucal, that thing is built like a freaking tank. Yeah, it also has to be hurricane-proof. That's a very good point. Guys stirring the concrete. Oh, getting ready to pour. See, he's going to switch directions here. Hold on. So watch. It'll stop the rotation, right? And then when he's ready to pour, it'll go the opposite direction. Now concrete's going to come out. Because there's an auger inside of the concrete hopper here. And if you're turning it one way, it pushes the concrete towards the forward part of the truck and keeps it mixed. If you're pushing it the opposite way, the auger pushes out and it'll start pouring. Watch. See, there he goes. And then they're pouring the concrete. Now, what they're going to do is when they get enough concrete down on the ground, they're going to start spreading it. Yeah, green, of course they do. They write messages on the rocket motors. Of course they do. Maybe not these guys in particular, but there are definitely people that watch. I think Elon watches this footage himself, if I had to guess. An auger, for what it's worth, is a big corkscrew. Inside of every cement mixer, there's a giant corkscrew. And if you stir it one way, it pushes the concrete forward and keeps the concrete mixed. Because if you let the concrete sit, it'll dry, right? Concrete has a shelf life, believe it or not. You can't just, and even if you just sit there, you can't just keep it mixed. You need to keep adding water, and that would ruin the concrete mixture. So they have a shelf life, and then they try to get it there as quick as possible, and then they basically change direction on the thing, and it spins the concrete out the back. And they already attached security cameras and work lights to the OLM. Oh, that Mythbusters episode, silly, where they blew up the cement mixer? Yeah, it's crazy. AGRC concrete also has a maximum temperature that it can be exposed to, especially newer concrete. Yep. I'd imagine that camera is temporary. Yeah, you're gonna need a little bit of a beefier camera if you want it to survive in that position. Could you clean the cement truck with explosives? Nah. I think they tried that once. I don't think it worked too well. Yeah, looks like they did weld that on there. Yeah, that's called a refurbishable cement mixer, guys. A refurbishable, as opposed to a reusable one. Is that intentional, or are those some nicks in the tile? Or is SpaceX just trying to make it look like a GameCube logo? Swung. GameCube. Go ahead, 2020. Yeah, it's fine. Anything that's in the wooden crates are mine. You can grab everything else, dude. I don't care. Go ahead. Yeah, they have a lot of tiles on there, guys, for testing. Whoa. What is that? Ferd. Wait. What? Oh, Ferd. Habababa. I like this. I like this what's going on right here. But also, what is that thing? You think that's a cap? You guys think it's a cap for the OLM? It doesn't look like it though. Where's this piece gonna fit in? It's like trying to figure out a frickin' puzzle. Fins, bezel, it's a copy of Dart. Right, Brim? I think it's part of the swivel. It does look like it slides onto the launch pad pillars. Tesla! Oh, the porta potty is right here. I see they have porta potties on site. Very nice. Ah, see, there's more. "60 seconds till the Ariane space commentary start." Okay. Whoa. Cool. Telescoping crawler crane. Cool. Just riding shotgun on the SPMTs. Freaking looks like an artillery piece, huh? Some more stainless steel rolls being delivered, and then what is this? Yeah, Tessa. Yeah, those are. Whoa. So see the angle pieces right there. Whatever that is, it's designed to sleeve into something, or not sleeve into something. It's designed to fit into a sleeve. Look at how much that trailer is rocking back and forth. Man, be careful.
Discovery, go at
Tessa,
throttle.
I think that's full inch, dude. That is... Oh, man, that thing's probably really friggin' heavy. Holy cow. I mean, whatever it is, it's got a huge support beam going through it. So, something like this that has a beam going horizontally through it is going to be holding up a lot of support that's not necessarily over the beam. So, for instance, if you're looking at the launch tower from the top looking down, you have 4 beams. This is designed to hold something heavy, I hope, equidistant from the 4 beams. Okay. There is still one more NASA spaceflight video that we could check out, guys, but we do have an Ariane space launch here. We have Vega's return to flight after a failure, so let's go see what they're up to here, and I'll switch us over to the Vega VV-18 launch coverage. All right, let's go over here like this.
Any minute now to Kourou, because we want to speak to the CEO of Arianespace, who's probably right behind me.
Guys, I'll be back 1 second. I just got to use the toilet real quick. Got to use the head. I'll be back in a moment.
Stefan, see me?
That's Stefan Israel. Listen to
Good
Stefan.
evening, yes,
Stefan's cool.
I hear you.
Great. So tell me, how do you
Hello.
feel right now?
So we are now 5 minutes before liftoff. We are all focused on the success of the mission. We are here in the Jupiter cell control with all our partners from Avio, from ESA, from CNES. And we are just now before the big event.
This, of course, marks Vega's return to flight. Tell me how that's going.
So we are going to deliver tonight for Airbus, as you have mentioned, our main customer with Pléiades Neo and Earth observation satellite. We are going to deliver with 5 more auxiliary payload in piggy bag, and this is a return to flight. So it means that it is coming after months of very hard work with our partners, and tonight we are ready for this mission.
So tell us, how will the mission unfold as we watch this all taking place live here from Toulouse and from Kourou, of course, where you are right now in mission control?
Yeah, so liftoff will occur at 10:50. We will have the separation of the first 3 stages approximately 7 minutes after liftoff. Pléiades Neo will be separated 54 minutes after liftoff, and 47 minutes after the separation of Pléiades Neo, we will have the separation of the 5 auxiliary payload, all that at an altitude of 600 kilometers. And we have now the DDO, or launch manager, who is saying that everything is okay to go for the launch. So we are really now in the final countdown.
Indeed, I can hear the range manager there. Obviously, so important as we get the guidelines on what's happening. Stefan, I know you've got a very busy few minutes ahead of you, so fingers crossed, good luck, and hope this all goes really well. And we'll talk to you at the other end, of course, afterwards to celebrate. All right?
Thank you. Thank you.
So now I turn to my whiz kid.
Hi, Chris.
Damien, tell us, what should we be watching out for now?
Yeah, let's have a look at the main milestone of the missions that are going to come up. So first, the liftoff will occur from the Guyana Space Center. After the liftoff is triggered by the ignition of the P-80 stage, which is the first booster of the Vega launch vehicle. The second and third stages that we call Zefiro 23 and Zefiro 9 will continue the job of the P-80. They will increase the launcher velocity. The fairing separation will be triggered during the flight of the Zefiro 9, the third stage booster. And the end of the Zefiro 9 flight will trigger the separation of the stage, which will occur in direct visibility of Bermuda. We have then the first ignition of the AVUM, which is the upper stage reignitable engine. The cutoff of the stage 8 minutes after the ignitions will occur in visibility of Saint-Hubert still. And after this cutoff, we start a phase that we call the long ballistic phase, which allows us to reach visibility from a new Norcia in Australia, where we will trigger the second AVUM boost before releasing the first main passenger, Pléiades Neo 3. After the release of Pléiades Neo 3, we prepare for the injection into the orbit required by the auxiliary passengers with 2 boosts, the third and the fourth AVUM boost, which will occur in visibility of Galileo, and we have the sequence of separation of the 5 auxiliary passengers in visibility of Bermuda, one after another. The launcher will complete its mission with the 5th AVUM boost in visibility of Saint-Hubert in order to trigger the
I had
re-entry.
to take a wicked Chevy.
Very quick question before we get to the final countdown. Compared to, say, when Thomas Pesquet went up to the ISS last week, how is it the same orbit or?
No, it's not the same orbit. We will start, of course, below the altitude of the ISS.
Yes.
At the end of the first AVUM boost, we are slightly below the altitude of the ISS. During the first ballistic phase that we discussed about, the altitude increases and we go beyond the altitude of the ISS, and we separate all our customers far beyond the altitude of the ISS.
Yeah, that's right.
We can see right now behind us, here on the space wall, the team's getting ready for the final seconds before liftoff.
Yeah,
We're just
see the
outside of
mission
1 minute.
manager who will announce us 1 minute before liftoff.
Tell me the role of the DDO, as they call it in French, the range manager.
The range manager is
Got
the
it,
guy
Novus.
who is
Okay,
in
good
charge
to know.
of monitoring
Thank you.
the status of the different preparations.
Okay, so HLS is under next step. I thought it was different, dude. I thought it was under a different thing, but that's good to know. That makes a little bit more sense now. Interesting still that they shifted it to next step too, but it makes sense.
We are around 40 seconds
40
until the
seconds.
liftoff.
So we're almost there. And just
All right,
also
here
the
we go,
ground
guys.
stations, very quickly in 10 seconds, their role.
Yes, we have several ground stations around the Earth in order to allow us to get direct data coming from the launcher and provide you with the actual status.
So we're there now. So now
this
let's
is a
listen
return
in
to
and
flight,
watch.
guys. Vegas' last flight didn't go.
Attention pour les décomptes finales.
Stand by for the final count.
10, 9,
8, 7, 6, 5, 4, 3, 2, 1. Later. All right, we have liftoff. There we go. Okay, everything looked real good there. Vega is a 4-stage solid rocket lifter. It's a medium-duty lifter. So, not necessarily like Falcon 9, but it's more in the same. It's more on the lower end class of the same class that like Antares is. I think it's like about 1 to 2 tons into space if I'm remembering right. I'd have to go back and look. But it's 4-stage solid. This thing is really cool.
We never get tired of seeing those launches,
No,
do we?
it's always something very beautiful to look at.
So we're into it now. What happens? We track it now. Tell me what happens now.
Yeah, now we are in the phase that we call the PAT phase. It's the name of the first stage boosters, which allows us to get far from the
Solid
launch
rockets,
pad.
guys. Goes
During
fast.
this phase, we burn solid propellant. So the name of PAT comes from the amount of propellant that we have on board. So it's roughly 80 tons of propellant, slightly more. And during these phases, the launcher provides these thrust and accelerations, and the separation of the stage will be triggered when the acceleration will get below a predefined threshold in order to get use of this mass, which is useless once you have used almost all the propellant inside.
When will the first separation take place?
The first separation will take place around 2 minutes after liftoff, so we should see it in a few seconds.
And you're monitoring, you're directly in contact with Kourou.
Yeah, I have a direct contact with the people who are getting the real-time telemetry data and who are monitoring the current status of the launcher. As soon as I will get the confirmation, I will let you know along all the mission.
And this is the next really important stage.
Yes. And the separation of the PAT has just been confirmed, and we have the ignition of the second stage, which we call the Zefiro 23.
So confirmation, the first separation has gone ahead as planned, which is what we were looking for.
Yeah.
What happens next?
Now it's the job of the second stage, which will increase still the launcher velocity and the altitude in order to provide additional energy to the launcher. And then when it will complete its job, it is exactly the same principle as for the PAT. It means once we have used almost all the propellant that is inside the stage, we will trigger the separation, once again based on the detection of the acceleration.
Okay, and in any moment now, we're going to hopefully go back to Kourou through the space wall and see the team monitoring all the progress. I guess the ground station's giving all the information as well.
Exactly.
Standing in front of the screen.
Great.
Who framed this camera shot?
You know, it just, this whole
What are you
operation
doing?
is supposed to take, what, an hour and 40 between launch and dropping off all the different satellites?
Between the liftoff and the separation of the Pléiades Neo 3,
Why is
we
the
have around
host
55
framed in the
minutes.
center of the
and
screen?
up to the separation of the auxiliary passenger, 1 hour and 40 seconds. More.
Guys!
And you never get tired of a launch, do you?
No, it's always something very beautiful to look at.
So just a reminder, the launch took off about 3 or 4 minutes ago.
6
and we're
meter
now waiting for the
distancing.
next-
Wait. You're telling me that he couldn't go to the other side of the screen, which would be even further away? Oh, man. Yeah, no. It's got to be 6 meters,
Separation
right?
detail to come up.
Velocity and still waiting for the final moment.
And just a reminder, you're watching us here from Toulouse, where Airbus has its headquarters, where the satellite was made.
He's
And I
literally
have
standing
Damien
right in
here
front of it.
from Aerospace, giving me all the latest information. And I'm going to be joined here very soon by Raphael, also from Aerospace. Yeah.
I want to share with you the fact that the separation of the Zefiro 23 has been confirmed, and we have the start of the roll maneuver before igniting the Z9.
This is very good news, right?
And the fairing has been separated as well.
So that's great. So come on in now.
He's literally standing right in front. Come
what we
on,
want to do
guys.
now is we want to go through
Really?
what the Vega launcher is like.
Exactly, and Raphael will present you.
Raphael?
Hello.
Oh, well,
Let's
Raph's
go
got to be
now
there.
to
Actually,
the magic
this
of the
guy is
studio
cool. Raph's
and look
cool.
at this Vega Lancer launch rocket and take us
it
through
should
everything.
come out of the ground magically. So it's actually, the Vega launcher is actually much bigger than this, of course. It's 30 meters tall. It weighs a little less than 140
That's why they did that.
tons.
Okay, that makes sense.
And it is composed of 4 stages, each playing a key role in the smooth execution of the launch mission.
What is happening?
So the main stage that we see here is really the one who is going to put the Vega launcher out of the Earth to extract it from the gravitational effect of the Earth. You see also
Was that guy picking a wedgie?
that there is like a conical interstage that is making the junction between the first stage and the second stage, which diameter is slightly reduced to 2 meters.
Yeah,
The
that's
first
pretty
stage
cool.
was
All
3
right.
meters
Credit
diameter.
where credit is due. That's cool.
And then
that's why
the
he had to
third
stand in
stage,
front of the
that
screen. It
just
makes sense.
ignited, and it will do this for a couple of minutes. Is there? It's 4 meters tall. And then, of course, right now, we saw that the fairing was separated in 2 halves. It means that we are beyond the limits of the atmosphere. We don't need the fairing anymore to protect the satellites from the frictions of the air, of the atmosphere. And also, doing so, we get rid of a dead weight that is not anymore useful for the rest of the missions. And of course, this phase is very, very critical because
Look,
otherwise
Vega's burning
we will
radial
not
in.
be able to separate the satellites into space. And last but not least, you have the last stage, the AVUM stage, which will continue the mission. It's absolutely key because this is the one who is going to put the satellites at the right locations in space. It has a reignition capability, which is absolutely key, and I think we will talk about it later.
I'm sure you will. These are amazing pictures we're looking at. And while I have you here on my right is my other guru. We're now waiting for the next separation element,
Yeah.
right?
The separation of the separation has just occurred.
It just occurred.
Yeah,
Okay, that's very
separation of
good
the
news
three
as
and
well. Okay, so let's moving forward now from there. Go ahead, Raphael. What else can you tell us now?
Maybe on the AVUM.
Yeah.
So I said
brought
that
the
it's
telemetry
absolutely
back.
key technology because, especially for capturing the small satellites markets, because these are very specific satellites that typically have very limited propulsion capabilities. So it means that they require the launch vehicle to separate them as close as possible to their operational
AVM is liquid
orbits.
fueled.
And we do this with
It's a
several
Ukrainian
boosts
liquid fuel
in
upper
order to
stage.
address complex missions. And doing this, it allows us also to optimize the filling ratio of the launch vehicle in order to share the cost of the launch between all the passengers. This is like carpooling in space.
And that's the reason why we have.
See, we like
Pleiades
Raph.
Neo,
Raph is cool.
and we have
this
5
guy.
other
This guy
smaller
just
satellites
explains things.
who are all
I
taking
like him,
part in
and I
this
like the
ride
engineer
together.
over
It makes
here.
sense for everyone.
Exactly, from CubeSats to a little bigger satellites, it's very convenient to actually capture this market and to improve and augment the launch opportunities that we have with our launch vehicles.
It's possible, Coley.
And you're, of course, continuing to track what's going on there, right? And
we are currently in the phases just before the ignition of the AVUM, in the phases where we tilt the launcher in order to get the correct orientation just before ignition. And as soon as I have the information, I will let you know.
Okay. And that
ignition confirmed.
Ignition's confirmed.
All right.
Okay. So now we have the AVUM, and that's all going well now.
All right, so they probably won't talk about it. There it goes back down the hole. They probably won't talk about it, dudes, but the AVUM upper stage on the VV-17 flight didn't go so well. That's where they had a problem before. Now, you can tell, like, this is the reason why we wanted the telemetry, okay? The reason why we wanted the telemetry is because the Europeans generally, up until this point, have showed the telemetry throughout the entirety of the flight. And it's really easy to see what the rocket is doing. Really easy way to tell, I should say, if the rocket is going off course is if that X goes out of the circle. So if the center point of that X goes outside of the circle is the ground, is what's called the track. It's not the ground track, it's the track for the rocket. Rockets always have kind of an imaginary cylinder around them in a certain amount of directions, and those directions generally change. It depends on the rocket. But if you picture like an imaginary cylinder that the rocket flies through, if the rocket is cleared to fly through that imaginary cylinder, that's its track. If it goes off track, that means something bad has happened. So if the X goes out of that circle, something has gone wrong. Generally in the past, when rockets leave the track, they blow them up. That's what happens generally. But the Europeans did have problems with the AVUM upper stage, and it did go out of the track last time we saw a Vega launch. It does not seem to be doing that this time. The X is literally in the center of the pipe. Everything is real good. The AVUM upper stage is moving to deploy the satellites into the different orbits here.
A generational hop. Explain that, because I think you can really focus in on some amazing things now.
Well, typically here, these satellites and the next 3 Pleiades Neo, they will provide 30 centimeter native resolution. So it's a very, very high accuracy of the imagery, and that's the best you can get on the commercial market. There are only 2 companies in the world that can provide you that. And we have put further other innovations on top of that. You will have laser terminals on these satellites, so you can communicate directly with lasers. You will have a lot of agility and a huge capacity. So in the years to come, you will see a lot of this data actually going into many, many applications, and we'll speak about this.
And we also have to point out that this is Neo 3, but in fact there's 4 altogether going up.
Yes, exactly. And it's part of a much bigger constellation, so part of a much bigger story. But altogether, it makes a lot of sense for our customers, for our partners, and indeed, it's a technological leap because they need this 30 centimeter resolution, and they will get a lot.
Let's now look at this video explaining just what the Neo is. Go ahead.
Nah, Bandit, I'm not going to be able to see. It's too low on the horizon. Sorry, they boosted the sound, guys. I turned it down a little bit. 30 centimeter native res is pretty damn good, man. That means the accuracy, they could see things at a foot very clearly. It's pretty cool. See the people walking around? That's really, really, really game changing. Yeah, Rocket Guy, that's like spy satellite good, man. Help me, satellite, I'm stuck! Oh wait, no, never mind. Sorry, that's something different. Cam. Missed opportunity. I mean, 30 centimeters for a civilian satellite is pretty damn good. So, like, if you have a piece of paper,
now,
right, and you painted the piece of paper a different color, you put it on the ground, it'll be able to see
30
it.
centimeters, zoom
Pretty crazy.
One key issue could be urban planning. As cities become megapolises and more of us move into towns and cities and become more dense, this kind of technology and what NEO can offer will be essential.
That's right, Chris. There are many applications. Urban mapping is one of the key ones because of the density of cities, which is growing, because of pollutions, because of many areas. Here you see one image actually, which is at 50 centimeter resolution, so previous generation. But you see a city with a lot of density, lot of complexity, water, buildings, and many things. On the next page, you will see afterwards that we can play actually with artificial intelligence to get more data out of these images. This is what you see here.
Okay, first of all, explain what are the different color codes. Obviously, I can tell a river.
So, yeah, the river is in blue, obviously. In pink, you will see the buildings, so people living there. You will see in green the areas with vegetations, trees, and so on, and the roads, and many other things. What's important is that this type of map is very precise. So you can use it for many things which are important missions. If you have waters going up, a flood, for instance, you can really see and calculate what will be the impact on the buildings. If you want to change a bit the environmental impact on the city, you can work very precisely on your vegetation map.
We're coming up
and get also some monitoring out of that.
First stage.
Finally, maybe
stage shutdown.
To mention, you can look at the economic activity. Here it's one map, but actually the satellites, they are coming and coming, and they give you very precise information. You can look at objects, cars, people, and you can actually derive information from that.
Question though, this is 30 centimeter. What is it until now?
Well, until now, Airbus was providing 50 centimeter and above, which was providing already a lot of information and very strong position on the market. But clearly, the market is expecting more, as they're expecting also more capacity, more agility, more information, and at the sweet spot, which is currently 30 centimeter on the commercial market.
Can I stop you for a second, Damien?
Just hot news, we have the confirmation of the cutoff of the first AVUM according to the timing and trajectory is completely nominal.
Good.
Okay, so in human talk, what does that mean?
It means that we have completed the first part of the AVUM job and we are where we want to be at the time where we want to be. So everything is nominal.
So your client here must be happy.
Close to Christmas.
Well, that's good news. We'll wait for more from you coming up.
For sure.
So let's take this a bit further now.
Looks good, it's guys. Right down the pipe.
I'm interested in the AI, but you'll talk to me about that.
Oh, there was a picture.
Pollution.
Oh, wait a minute.
Well, that's good news. We'll wait for more from you coming up.
For sure.
So let's take this a bit further now.
Hold
on. Not just. I'm interested in the AI.
What was that? Oh, it's the wrong slide. I thought that was a picture of space for a second.
AI, but you'll talk to me about that.
Damn, I was close.
Very broad areas. That's where
I thought we were looking at space for a second. I'm like, they creeped us out of the live views,
but sometimes you are also looking at very precise things, looking for a ship which you have lost. Here on this image, which you see here, you have actually a tanker here. This tanker was hijacked, and nobody could find them. The only way to find them was to use our satellites. So this is a kind of mission that you can complete, which has very strong security impact.
this was a hijacked ship, a real case scenario?
Yes, yes.
Okay, well, you've got to tell us, did they find the bad guys?
They found the bad guys, and thanks to our satellites.
Go into the pollution area as well. I'm interested in that, how that can help.
Well, the pollution is also indeed an interesting case because on Pleiades Neo we have decided also to get some spectral bands that give us more information around the water, and especially we can go a few meters below the water in terms of visibility. And that gives us information like looking at plastics, for instance, looking at specific pollutions which is not exactly at the surface. So we'll get a lot of this new information, and I think it will help a lot on the market.
And who would ask for that kind of information? Would that be governments, NGOs? Would that be private enterprise?
Honestly, it's all more and more. It started obviously a lot with governments, NGOs, and so on, but more and more also the commercial market, the private market,
I don't know, Bill,
are looking at these kind of things.
There's too many rocket launches.
From different perspectives, economical perspectives, responsibility. So it's moving a lot.
So, you know how they talk about how those massive islands of pollution or litter, debris in the water, kind of going with the currents. So you could track that.
We could track that. I hope we can track that. That's the idea, and actually to get some more and more information and to help to solve at least partially the issue. Here you can see also on the map another aspect which I think is interesting. Is here we have used artificial intelligence to actually track and look for ships. On the previous image, you had plenty of ships. So obviously, if you are doing that as a human, it takes you time, and sometimes you miss the ships. Here, with the artificial intelligence, you get it automatically, very performing, but only if you have good images. And that's why it's very important to have good satellites with very accurate images. Here, you even see through the clouds. That's where the machine, together with the good imagery, is doing some miracles.
So you can penetrate cloud cover?
Almost. They are using some space between the clouds, but somehow it gives information we didn't get before.
That's extraordinary that you can use AI with satellite imagery to do so much things now. This is a real advance, right?
Yes, yes, and that's really a kind of virtuous circle. The more AI, the more data we can use. And the more data, the more satellites, the more capacity we have, the more missions we can fulfill.
Francois, this is all very, very interesting. You'll be with us again very shortly, but I'm now going to pass it on to your colleague now, who's going to be joining us. So thanks for that. That's all very enlightening to hear that, okay? And we're having good news now, of course, from Damien. So now, Damien, do you have something else?
Yeah, just to tell you that we have lost completely nominally the telemetry link, which is completely foreseen. So now we will wait for the next acquisition of the telemetry at the end of the first ballistic phase, and I will come back to you just when the telemetry will come back as well.
Okay, come back with some great news, okay? All right, thank you. So now, I would like to introduce Philippe Farm, who's head of Earth observation at Airbus. Hello, Philippe. I guess you've heard some of the good news that things are going well.
Hi, Chris. Yes, very good news indeed. Very relieved.
Explain to me, from a simple person like me, why do you call it a NEO?
We call it NEO because this is the real latest technology for satellite imagery, the latest generation of satellite performance and capacities. Latest generation, so this is why we called it NEO.
Where was the satellite made? I think you're going to tell me a lot of it was in Europe and a huge amount in France.
Yes, indeed. I mean, both platform and instruments were designed, developed, manufactured and tested in Toulouse. We are embarking mainly European technologies and equipment that we collected all over Europe and also in France. So it's a French plus European satellite indeed.
Describe to me, as we've been talking, it's the generational leap. We've gone from 50 centimeters down to 30, but there's more to this than that, isn't it? The way we make satellites is quicker, cheaper, lighter. There's so much, right?
Exactly. This satellite has been is the result of 5 intense years of hard work, millions of labor hours to come up with a very compact, very agile design. This is embarking really the latest technologies in terms of detection chain, silicon carbide material, very capable end-to-end processing chain, a very, let's say, capable satellite indeed.
Postage stamp, Jeffrey.
I think in a few seconds we're actually going to be able to see another animated reality of the satellite. And before it comes up, another key thing is this satellite can last longer, right?
Yes, currently the lifetime of our satellites is 10 plus years. It used to be 7, 5 or 3 years, 20 years ago. We've made a lot of progress. We are now quicker in building, cheaper in cost, very efficient in launch.
I think we can see it right here.
Very big difference.
How about that? So talk us through what we're seeing here.
Yes, here you see a 3D animation of our satellite design. You see how compact it is, what is the very small satellite size. You see how the accommodation of all instrument, platform equipments, solar arrays has been optimized to really fit in a very small volume to enable an optimum launch compatibility and to be able to use a lot of launch capacities.
So, Bandit, that thing is probably about the size of a NASCAR's hood, and it can see something a foot wide. So if you took a piece of paper and you put it on the ground, it wouldn't be able to read the text on it, but it'd be able to see the piece of paper. And now that's pretty dang impressive from 400 kilometers that way, considering that the thing is about the size of an LS engine, maybe? Yeah, maybe just a little bit bigger. I mean, that's a lot of kit for something that small. I mean, I'd say it's about the size of the front of a car, like from the firewall forward. It's about that big. That's pretty impressive. You know, credit where credit is due. I mean, it is a box, and it's not a very big box. But also, that box can see a piece of paper 400 kilometers away, which is pretty cool.
Been the previous generation times lap.
Usually, with the design, the manufacturing, and then the launch, it was...
It's like maybe the size of a smart car or something. It's not very big. That's pretty good for an optical satellite.
Lower capacities, lower performances. Now we have industrial processes, far more, I would say, and quicker methodologies from design to manufacturing and test, which allowed us to have far more performances in less cost and quicker time to delivery.
So it makes you wonder, we'll talk about the future in a bit, but what could you achieve in 10 or 15 years from now to be extraordinary?
Well, you know, we are working on constellations, on building more and more satellites in terms of numbers, in terms of time to delivery, in terms of launching several satellites at once. So we will continue to improve, being smaller, being quicker, and being less costly to launch and operate.
Okay.
I'm not trying to be mean at all, but does Philippe look like a Fallout NPC?
Discovery, go at throttle up.
I just get a real Fallout NPC vibe from him. And once again, it's not a character. I'm not trying to bark up his tree or anything. I'm sure he's really, really smart. But I get a very big Fallout NPC vibe from that guy.
So we took all the efforts, all the knowledge we have from the last 25 years on this market.
Patrolling the Mojave makes you want to wish for a nuclear winter.
It's all about delivering to the customers.
So let me get this right. The customer calls you and says, I want something newer, bigger.
Which one?
Pull up Philippe and say, get it done.
Well, in fact, we work very tightly together from the understanding of the marketplace and the customer expectations.
This is the first
to translate that into design features, capabilities, to both deliver very high resolution imagery, capacity of collection, very quick tasking capabilities and downloading of imagery,
no KSP today,
together with the ground capacities to process the imagery, to enable digital services deliveries to our customers. So it's an end-to-end chain of capacities and performances to satisfy our customers with respect to their latest expectations, the needs for application, and also to satisfy the global marketplace.
Without giving away any business-sensitive information, what kind of, I guess customers are already anxiously waiting for this to go up and use it. So what kind of things have they said they'd like to use it for without giving anything too sensitive?
The typical customers will have governmental customers for sure, but actually what was amazing in the journey of the last years is that it's more on the commercial market that we got the highest, I would say, appetite, especially to invest upfront. So we have already customers before the launch. So we have people who really believed into the quality, into the performance of what we deliver before seeing the images. And that's great. It's a great comfort. Never. And now we will work on the next phase of customers, government
So, guys, the next launch is Long March 5 going out of Wenchang in China. It's the Tianhe Space Station module. If there's a broadcast, if there's a CNSA broadcast for it, I'll probably show it because that's the launch site that launches out into the ocean. And then after that, once that goes up, literally right after that, so that's in about an hour. And then in about an hour and a half, SpaceX is going to launch Starlink. There's a Starlink launch tonight. So, yeah. Yeah, we're just going to be watching rocket launches for the rest of the night. I literally couldn't stream KSP today because there's so many rocket launches. That's not a bad problem to have. I just, Primo, yeah, I never thought I'd hear that.
Satellites with this type of web interface.
I never thought I'd have to do that.
Very modern.
And just very quick wrap, data protection is incredibly important as well.
It is very important. It is very important, and especially for some of our governmental customers. So it has been always at the core of our work and of our systems. And you were asking me on the way to get access to the data. Actually, some customers need also a direct access. This is why we have teams all around the world who are also able to interface with the customers directly and take care on their special needs.
Interesting, Novus.
Thank you very much, Francois. You'll come back in a bit. I'm now going to bring Raphael in because...
So, Novus, I agree with you. That very much seems like a Jim move. And if you did some reading and you said that the HLS was added to Next Step 1 and 2 in 2019, well, Jim, baby. I knew it was him. I freaking knew it, dude. I just couldn't prove it.
Vega launch, the first of 2021, I should remind you. And you sent in a bunch of questions, and Philippe and my other guru here are here to answer them.
Philippe?
So we want to talk to you about some of these questions. And,
I thought that was a blue screen for a
here's
second.
the first one. A little homework. Someone who likes to play golf. What force is required to place a golf ball on orbit?
Well, this is an excellent question that still requires some simplifications. So let's consider a golf ball that is placed on the equator. So it already benefits from the rotational speed of the Earth.
Cool.
So the whole point in putting the ball into orbit is to give it a speed of at least 8 kilometers per second. If that speed is lower than this limit, then the ball will fall back on Earth because the force applied to the ball is weaker than the gravity force of the Earth. If the speed is higher than 11 kilometers per second, then the ball will escape the gravity of the Earth and it will continue its way into space. Also, we have to note that the force that needs to be applied to orbit the ball is also dependent on how fast you want to get there. If, for example, you want to put the ball into orbit in 10 minutes, then the force you will apply is rather weak. It will be at the order of magnitude of less than 1 Newton. If you want to get there in 10 seconds, then you will need to apply a much stronger force that would be more than 30 newtons. And this is, again, very simplified way to see the problem because, of course, we don't take into account the friction of the air, which is very dependent on the specific shape of the launch vehicle, and also dependent on the trajectory that you will choose in order to put your object into orbit.
Okay, but we're not going to be playing golf anytime soon in orbit, but
we
let's
could play
go to
golf
the
on
next
the moon.
question, and this is for you, Philippe. Are there any situations where a satellite could catch fire in space?
Well, you know, there's no atmosphere up there, so we don't have fire per se. We may have some other failures like electrical shutdown, short circuits, propulsion issues and failures. So this is the kind of failures we face in orbit on satellites. And then you have to resolve that.
These are actually pretty good questions, I'll be honest with you.
To solve the issue and to get back on track.
Not sure how it's pertinent to the mission, but still cool.
What we do is that we passivate the upper stage. It just means that we drop the residual propellant in order to prevent from an explosion due to a sudden heat from the sun.
Yep,
this
event
is
the tanks. You inert the
very
stage.
key in order not to generate debris that would be caused by the explosion. This is required by the French space law, which is one of the most virtuous legislation framework in the space sector.
Fantastic. Now let's go to a third question here. We're getting a lot of questions about, we talked about this earlier, Philippe, the mega constellations. There's so many satellites going out, the CubeSats, there's tiny ones going up there. And so we're getting a lot of questions about increasing risks. Could there be collisions? And also we had one real big fan of space who sent in a question as well. And we hope we can see it here in a second about what are the risks of a collision between, say, a launcher and a satellite. Hopefully we can see that now. Well, there we are.
Hi, Ariane and Airbus. As it's getting quite busy up there in low Earth orbit with satellites.
Okay.
How is it worked out from the launch time to satellite deployment that they are safe from collision by other satellites?
Well, apart from you have your new recruit in a few years you can get, go on, you can both answer.
So regarding the launch vehicle, what we do is that we calculate the risk to collide the International Space Stations where Thomas Pesquet actually returned a couple of days ago. So it's, let's say that it translates into short launch windows where we cannot simply launch during the day, but it's very short times. It is true that if mega constellations keep increasing in low Earth orbits, we will need to calculate this risk with other space objects. It is not technically difficult to do so, but I should remind that the risk to collide with the launch vehicle with another space object right now is very low. This is like a boat that would hit a can of soda in the Mediterranean Sea.
Good imagery there. Philippe?
They call it soda.
Indeed, more and more satellites, larger and larger constellations
Soda,
will lead to
not
more
pop.
and more risks, meaning
Soda.
trying to avoid collisions. But there are some computations of trajectories. It's being followed up in real time. So currently, all this is mastered and the collisions are avoided this way. It will, of course, the risk will increase and it will be more and more complex to avoid collisions.
Pop. No, you're wrong.
And I think you're working on technology just to handle that kind of thing for the future, aren't you?
Yes, indeed. In particular from both ground technologies with respect to radar to really compute the trajectories, to automatic detection and maneuvers to avoid collisions in orbit.
Okay. Apart from social media, what's the kind of questions you both get a lot? That, from people who ask you about what you do with Vega. Can you think of something that comes to mind in particular?
I think one of the big questions is the business model of space. We are talking about large constellations, thousands or hundreds of spacecraft. It has a cost. It's a long development. It will need a lot of launches. It will take years to get there, in particular in telecommunications, but also sometimes in Earth observation. So the question is, what about the money? Where does it come from? Will it work? Will the service work in space? So these are the major questions with respect to the current buzz on constellations.
Raphael, thanks very much.
These are good answers, man.
Philippe, stay there. Thanks very much.
Philippe, stay. Do not move.
Francois Lombard, if you can join us again. Just a reminder, everything is going smoothly. We're waiting for more information from Damien, who will be here shortly. In the meantime, I have the two cool customers from Airbus who at the moment have big smiles on their face. Francois, we talked earlier about, not every resolution and every photo fits each customer. They want, you can offer different solutions. Tell me more about that.
This is right. And by the way, you were asking me how to access to the imagery, and I will use that as a reference. Here you have an interface which I mentioned before. So if you have your credit card, you can go on this kind of interface, and here you will have all type of data with different type of resolutions indeed. You see that you will have Pleiades at 50 centimeter, you will have spot at 1.5 meter, you will have radar imagery. And the point is, depending on what you want to do, what's your mission, you will use different type of image. The radar you will use to look through the clouds, for instance, or to look at data elevation models.
Man, that's just Google Maps.
The Spot 1.5 meter, it's great for maritime. What we have seen before was a Spot map, actually, very, very broad, good quality, but a resolution which is less accurate. And then Pleiades Neo, you will use it more to spot at very, very specific area and to look for smaller objects. Here is also an example on how you would use that with your credit card again. You have a very simple way to do it. You look at the archives if you need it. You can use the analytics toolbox if you want to use the AI. No big deal. You just use it very simply. And the most exquisite part, if you want to task the satellites, have a direct access to the satellites and order the next image for the next orbit, you can do that directly on the web.
Wow.
I thought you could ask me for my credit card details.
All right.
I could do that.
Not gonna lie, that's actually pretty neat.
Yes. We have a track record of Airbus of doing Earth observation satellites going back a long way.
Engels Air Force
There was Spot,
Base.
for example, some time ago. Yeah, and you still use Spot, right?
Yes, of course.
Guys, that was Engels Air Force Base. That was a Russian Air Force Base in the background there. Was that supposed to be shown, or?
We are currently using 2 Spot satellites, 6 and 7, 1.5 meters, 2 Pleiades, 50 centimeters. We are also using
At least
some
I think it was
DMCs
Engels. I'm not sure. I could be wrong.
Vision 1 satellite from SSTL, plus 3 radar satellites, Terasa X, Tandem X, and PASS. The Pleiad Neos are going to complete the Airbus fleet in adding capacities at 30 centimeters. So in fact, we are operating a whole fleet with various capabilities which are really fully complementary and that we use for all the vertical markets applications.
And you can confirm, and people still want some of the older satellite technology out there.
Yeah, definitely. It's really the combination of all these sensors that makes sense to the market.
And that would be because they just don't need that much accuracy or detail, I should say, or because the price is right for what they need?
Exactly, because of also the mix of revisit, the coverage you need to have.
They showed it again.
The budget you have. There are lots of reasons, but it's very, very complementary. There are examples where you need to go for high accuracy. And again, here you have a picture which is showing a very specific case of actually customers who want more than images. Here you are looking at an airfield where what we are looking at to do here is to give alerts to customers by identifying the airplanes and various objects around the airfield.
I want to stop you there because thanks to this studio, we have this incredible augmented reality. And Philippe, I want you to talk us through the satellite that we're seeing here. So any second now in front of us, as if magic, we will see the satellite here going around the globe. Go ahead, tell us a little bit about this.
Why are you peeping on a Russian Air Force
base, man? The full constellation of the Airbus fleet with the previous satellites that we are operating, Spot 6 and Spot 7.
Okay, so real quick, that was Engels. That was Engels Air Force Base in Russia. That's like where Russia operates their strategic bombing fleet out of. Tupolev 160s, Tu-95s, and IL-78s. That's like, that would be like somebody peeping on like Minot Air Force Base in, South Dakota? Where like a big big B-52 bomber fleet is. Like, yeah, that a little bit of a weird thing to choose to show off, but all right.
Swath and capacity of collection. We aggregate the data to provide our customers with what they expect in terms of
cool. All right. Scott was a technical advisor for that.
Services or products in various vertical markets. If you were talking about maritime, agriculture, local base service.
Yeah, Scott Manley was a technical advisor on Stowaway. Yeah, absolutely. His name should be in the credits, dude.
Everything is going well at the launch right now.
All right.
But it doesn't mean that
you guys want this or the Chinese coverage? Because right now we have overlapping coverage here. They're coming up on satellite deploy here very soon. Yeah, I think it was Stowaway. I think it was Stowaway, if I'm remembering right. Now I'm second guessing myself. I know he was a technical advisor on a space movie in Netflix. I don't know if it was Stowaway or not. Did the ship in the movie have look like have a center core and then have modules attached to the side, and it kind of looked like a big eye if you look at it from the top? Yeah, okay, it was Stowaway. Okay, I was right. All right, cool. Yeah, Scott was the technical advisor on that. Yeah, absolutely. He made a video about it the other day.
Are also preparing the next steps beyond that. It's a constant evolution.
That's why it was probably a little bit more realistic.
And the idea is to remain on the top of the world of this Earth observation market.
Francois, that's all great, and hopefully you'll be back with us in just a few minutes.
Nasman, Tianhe is scheduled to go off in about 45 minutes. But the coverage has started. It's very rare that you get CNSA coverage like this. I'm actually kind of curious to go see what their webcast is about. Yeah, it's very rare that you get Chinese coverage, like official state coverage. So I kind of want to switch over, and I just kind of want to check it out. I'll keep Philippe and Raphael and all those guys over on the second computer if we want to switch back and forth. But I actually kind of want to see what's going on with the Chinese coverage here. I've never seen state coverage before, dude. So I have the European still going, and I'll keep the closed captions on over there. But I actually want to go and see the Chinese launch. This is the CNSA Long March 5B Tianhe launch. Okay, I'll switch this over. We're gonna basically have double coverage going on right now because there's so many freaking rocket launches. But here, let's take a look at what's going on with the Chinese coverage. I'm gonna flip us over.
Takes launch missions for the space station and its modules to low Earth orbits.
I can double box it if you want, guys. Deep 10-month resub.
5B rocket
They're
is
just
among
talking over
China's
each
new
other.
generation launch vehicles. It reflects the progress of the country's space engineering over the past decade. Experts say technology behind the 5B lays the groundwork for the development of heavier launch vehicles in the future.
Well, joining us in the studio is Professor Yang Yuguang from China Aerospace Science and Industry Cooperation. And we have another guest via video link, Xu Yansong, the Director General in Asia Pacific Space Cooperation Organization. Welcome you both.
Now, let me start with you, Professor Yang. Talk to us a little bit about this rocket, right? What is the carrying capacity of this Long March 5B carrier rocket?
As you mentioned, the Long March 5B is a new new member of the Long March 5 family. The original version of Long March 5 has 2.5 stages, which is mainly used to launch high-altitude orbit payloads, such as geosynchronous orbit satellites, such as the lunar probes or the Martian probes. So for the low Earth orbit, it's not feasible to launch heavy payloads more than 20 tons. So this Long March 5B is a derivative of Long March 5, which only have 1.5 stage. But the payload fairing is very big to put the space station in. The payload fairing is long more than 20 meters, and the capability is, as mentioned, 25 tons to the lower.
So what he's saying is that there's two variants of the Long March 5. There's Long March 5 and there's Long March 5B. 5B has no upper stage, and where that room that the upper stage is taking up is just a gigantic payload fairing. So think of it like if Ariane 5 didn't have the ESA-B upper stage and it was just a big fairing. The Long March 5 needs that because it needs a big enough fairing to be able to launch the space station modules into space, which are big.
As Professor Yang mentioned, Long March 5 was for geosynchronous and deep space missions. Long March 5B basically removed the second stage, which plays a role for a higher altitude. So that also enabled the rocket to have a larger fairing, a larger capability to low Earth orbit with a single stage launch.
They're loading it in the transfer aisle there.
A fundamental difference between
and then they're pick it
the
up
5
and
the 5B.
And Professor Yang, this rocket is the most powerful rocket that China has ever had. Why do we need the Long March 5B carrier rocket for this particular mission?
You're correct. Long March 5B is the largest launch vehicle for China to launch low Earth orbit payloads. Actually speaking, it is third largest rocket in the world. The most powerful is Falcon Heavy. The second is Delta IV Heavy. The Falcon Heavy has a payload capability to low Earth orbit of about 63 tons, and the Delta IV Heavy has a capability of 28 tons. While our Long March 5B is the top 3 launch vehicle in the world have a capability of 25 tons. You know that our space station is composed of 3 modules in the initial stage. The Tianhe core module, the Wentian experimental module, and the Mengtian experimental module. All these 3 modules has a mass of more than 22 tons. So we don't have other choices. We can only use the Long March 5B to launch these 3 modules into space and combine them together to construct the station.
Well, thank you, Dr. Yang. And for the latest, let's go to our reporter Ning Hong at Wenchang spacecraft launch site. Hello, Ning Hong, and how are the preparations going so far?
Hello. Well, yes, now we're in a platform very close to the launch pad, and the rocket is about roughly 3 kilometers before in front of the launch pad. You can see now the rocket and the service platform is now open. The rocket, we have learned that the propellants now have been added into the orbit, into the rocket. You can see that there are vapors showing beside the rocket. That's because it is using the low temperature liquid propellants, and it's now people need to fill the propellants, continue filling it until before the launch. And we're now about half an hour before the launch, and you can see that this is a very open platform. We could see directly.
So Squall, the weird face is like, okay, so I've never actually sat and watched one of these casts before because they usually don't exist. But all the Chinese commentators have no accent, and their English is very, very good, like very good. Like they sound like me, which is. Like, don't get me wrong, I'm not like, oh my god, they sound like me. I'm not trying to make any, like, don't read too much into that statement. It just threw me for a curveball. Like, I'm impressed, like, very much. This cast is really good. And the engineer actually spoke some engineering speak, so I'm like, I'm impressed. Seriously.
About half an hour from now on.
They did probably go to school over
thank you,
here.
Neil.
A lot of Chinese go to school over here. I know that because in Boston you see a lot of them. They go to like MIT and they go to Harvard and stuff, which is fine. Like so, there's nothing wrong with that. It's just throwing me for a curveball. That's all.
Carrier rocket has the super large payload fairing, and why is that?
Well, basically because of the space station is large. But traditionally we have 3.35.
I mean, Homeboy has a Saturn V on his desk over there.
This is basically due to the limitations that we have launch site inland in China.
Okay, Nesman, thank you.
Limited by the railway capabilities and tunnels that we have to limit the fairing. So the Long March 5B has the longest and largest fairing so far. The dimension is over 22 meters long for the fairing only. And it's more than 5 meter diameter. So it's capable of engulfing the maximum dimension of the Tianhe segment. And also future missions, as Professor Yang mentioned, Mengtian and Wentian. So those are 3 largest segments, like the human body.
I don't know, LQ2. I'm really confused.
So it is due to.
This is not what I was expecting. In a good way.
Required.
In a good way.
Yes, in a later we're going to see that super long fairing that is long as over 20 meters. That's the super one.
That is very critical. And you were just watching
that has a Midwestern accent, and it's messing with me.
Spacecraft launch site. But Mr. Yang, let me bring you into this. There's a bit of green technology involved in the fuels, right? Talk to us about the clean fuels that the rocket is going to use.
Yes, you know that Long March 5 family is called the new generation of China's launch vehicles. Before that is currently in service is Long March 2, 3, and 4 series. All these launch vehicles use UDMH or unsymmetrical dimethyl hydrazine as the fuel and use nitrogen tetroxide as the oxidizer. The UDMH is highly toxic, and
it's not bad, not a bad thing.
NGO, or the nitrogen dioxide, is highly corrosive. So all these are toxic fuels, toxic propellants during the past. Well, our new generation, including this Long March 5, use cryogenic propulsion system. The 4 boosters use the kerosene as the fuel and use oxygen as the outsider, while the core stage of Long March 5 or Long March 5B use the liquid hydrogen as the fuel and use liquid oxygen as the oxidizer. So you see kerosene liquid oxygen and the liquid hydrogen are all environmental friendly, no toxic and no corrosive components. So you see that this will be more friendly to Earth and more easy to use. But on the other hand, it also brings some difficulties. You see that liquid hydrogen and the liquid oxygen must be being kept in a very low temperature.
It's better than UDMH,
so it requires, it raises a very high requirement to the launch pad and to the launch procedure. You may see the white smoke
I understand
or
what
white
he's saying.
smoke coming out from the vehicle itself.
Compared
that
to
is
UDMH,
vaporized liquid oxygen.
I mean, obviously.
And we were having that shot at the countdown club. We're just 40 minutes away from the launch, and you were seeing the shot at the command center. People are doing these final preparations. And Mr. Xu, how does the Long March 5 compare with other heavy lift rockets that are in operation now? We're having this great view of
Swing
this
arm
Long
retract.
March 5 rocket of the launch
Whoa!
pad now.
Swing arm cam.
Yes, the Long March 5 has, like Professor Yang mentioned, its unique characters. It used the liquid kerosene as the strapped arm boosters. As you can see, the total configuration, there are 4 strapped arm boosters along with the centerpiece, which is YF-77 liquid hydrogen and oxygen engine. So this is a character that
we're about 30 minutes out, guys. Little under 30 minutes.
As propellant in the atmosphere. So compared with other vehicles, we have upgraded the centerpiece, which is the core engine, into a liquid oxygen and liquid hydrogen, which has a better ratio in propulsion once it's
a space station core module, Doom,
so
for the Tianhe
very
space station.
Efficient and also environmental friendly, as Professor Yang mentioned. The Hainan launching site is built for such a fuel only. So UDMH and nitrogen tetroxide is not part of the plan for Hainan, only kerosene and oxygen. So it's very clean and also very
Too many rocket launches, Ryan. I don't know what to tell you.
Yes, this is a new type of fuel that we are using in the Long March 5B is more environmental friendly. We go ahead. What can we expect from China's next heavy lifted carrier rocket, Dr. Yang?
Well, you see that the leaders of China Aerospace has expressed their wish to have human missions to the moon in the future. Yep. And also in the after the 2 sessions of this year has announced that we have the plan to have the human missions in the future. So we now is in the stage of key technology preparation. So you see that we already have some tests about the 10-meter module of the core stage of the future.
I never covered Chinese launches before because I don't like covering. I mean, one, they never had coverage like this, Squall. 2, I don't like covering them because of certain ethical things, like using UDMH is one of those things. 3rd, this launch site is on Hainan Island. That's on the south coast of China near North Vietnam. It's the Wenchang Launch Center, and the Wenchang Launch Center has nothing but ocean to the east of it. So I don't have a problem here with this. This is totally fine, and the coverage is quite good from what I've seen. I don't like the other ones because of the toxic propellants and dropping stages and all that other stuff. But yeah, no, this is fine. This is cool with me. I don't have a problem with this.
B is only 53.7 meters in height. But the new generation Long March 9, let's call it for now, it would be more than 9.
You do cover Proton. Yeah, see, there's that thing, Swishy. 1, Proton is on its way out. 2, Proton stages don't land on people's houses, okay? There you go. Oh, but EJ, you do that? No, it's not what you do this. The other launch sites that China launches from, Long March 2, Long March 3, from Jinquan, the stages land on people. They land on me. I don't know. I'm not going to cover that. This is fine, though. They're launching out over the ocean. I don't have a problem with that.
Temperatures at the launch site, and we were just less than 35 minutes to go till the launch. But Professor Yang, it looks like we're having a bit of overcast sky there. Is it an ideal climate or weather for the launch?
That doesn't have much influence to our launch. You see that for launch procedure, there are many conditions we must meet. For instance, there should not be thunder and lightning during the trajectory of the rocket. And also, before the launch, the wind should also be well monitored, because the wind have very great influence during the flight. And also, you see that because until now, the human being cannot go into orbit with only one single stage, so we need to drop our stages in the sea or in the land. For this Wenchang spacecraft launch site, our boosters, our payload fairings of this Long March 5B will drop into the sea. So before the launch, we should see we should confirm that during the dropping area there is no any vehicles, either ships or planes coming through this area. So we must keep this safe. And also we must ensure that other systems, for instance, such as the telecommunication and tracking system is okay. We have ground stations and also have space tracking systems. All must be in good condition.
Okay. All right, Dr. Yang and Dr. Xu, stay with us. Now, China is set to launch the core module of its first space station today, as we've been talking about. And CGTN's reporter Yo Yang takes a look at a model to show us what it looks like and how it was developed.
Yeah, Hellfish, it's like...
As the main control cabin of China's first space station, the core module of Tianhe is about 16.6 meters long with a diameter of over 4 meters. It's divided into 3 parts: the connector, the life support and the control section, as well as the section for resources. The connector looks like a hexagon. It has 2 berth ports for 2 lab modules called Wentian and Mengtian, and 3 docking ports for the Shenzhou crew spacecraft, the cargo and other vehicles. It also has an exit on top where astronauts can conduct spacewalks. This is the living area of the crew. It's about 50 cubic meters. It's also called the thinner area. It's got 3 sleeping areas and 1 sanitary part. This is the thicker part, which is the working area, where astronauts control the daily operation of Space Center while conducting some scientific experiments. If we take a look from the outside, this is the resources part of Tianhe. It's responsible for fueling the space station. Once operational, the space station can host 3 astronauts for 6 months and up to 6 astronauts by replacement. Tianhe, along with its Long March 5B Y2 carrier rocket, has currently been transported to China's Wenchang spacecraft launch site in Hainan province. It's all set to kick off its journey into space. Yo Yang, CGTN, Beijing.
Oh, dude, hold on. Let me back that up real quick. Guys, I don't mean to get off live for a second, but check that out, dude. Hey, look. They're loading in an extravehicular mobility unit into the module. See that? See the forklift? They're loaded in EMU, so they can do EVAs. That's the go outside spacesuit. That looks like it's Orlan based off of the Orlan, which is a Russian EVA suit, but I'm seeing elements from the EVMU there too, which is interesting. It's like halfway between NASA and Russia's, which is
Retail is not very high. So this means that it is more rigid
I saw the
than other
robotic arm
vehicles,
too.
and also for this design, it brings some convenience.
The modules auto dock with each other.
And looking from here, it might.
So, guys, the Russian the Chinese modules and the Chinese spacecraft, so Shenlong and Tianhe and Tiangong, they're all based off of Russia's DOS and Salyut modules, and then Shenlong is based off of Soyuz. It's similar, but it's not the same. It's very much a different capsule. I mean, they are heavily based off of it, and it's really easy to see the Russian influence here. But I mean, it's so far out of the gates, it might as well be their own design at this point. That would be like saying, a Saturn 1B is a V2 missile. Like it's not. You could trace the anthology there, or you could trace the you could trace the lineage there if you really wanted to. A Saturn 1B can trace its roots directly to the V2, but yeah, it might as well be its own thing at this point.
Of the total thrust during the liftoff, because they use a powerful rocket engine called YF-100, which have a thrust of about 120 tons. So each rocket boosters use 2 of these engines.
Clive, right?
So totally, the 4 boosters can provide thrust about 960 tons. You can see that this is the biggest launch complex in China, and just now we can see from the camera that there are some white forks coming out from the top of the boosters. That is the oxygen. That is the vaporized liquid oxygen, because you know that it must be kept in a very low temperature, and by vaporizing.
All right, that is the call out you're hearing now. It is 30 minutes prior to launch. It is T minus 30 minutes. And at this point, what happens here, Professor Yang?
Well, we have a countdown in different stages. For the 30 minutes countdown, we've already completed many checking of the critical systems. For instance, such as the telemetry and tracking systems, the space tracking ships, and also to confirm that other systems are okay. Moreover, we should also test some of the subsystems on board the vehicle itself. So each must be kept in good condition and monitored by the data downloaded. And also, you can see also there are some small arms on the vehicle, because we have multiple plugs connected to the vehicle, and one by one they will be disconnected, and finally the major plug, the main plug, will be disconnected, and the vehicle will be completely depending on the power supply of itself. At that moment, we can perform the launch.
And it is also the time where the last batch of team members pulling away from the launch pad, is it?
So at this moment, there is no ground staff near the vehicle, because it will be very dangerous. So there are procedures, or the safety procedures ensure the safety of our staff. You see that the fueling has been completed several hours before. At this moment, the ground staff must leave the launch pad, because if there any uncertain things happened, the explosion will stress the life of our ground staff.
And the umbilicals we're looking at, they are still attached to this rocket. Why is it?
Because we still need connections, some cable connection to the vehicle, such as the power supply, such as a monitor of the signal and the control commands to the vehicle. So until the last minutes, maybe 1 minute or just several seconds before the launch, finally we disconnect the main plug.
What else? Those cable and it seems a lot of the pumping tubes there, so connecting the main body of the rocket and the service structure. They have been pumping I think it's the fuel, right? It's just, they need to keep fueling that rocket until the last minute.
Yes, you see that we need the storage batteries to provide electricity during the flight and before the launch, just after the disconnection. So we must save the energy of the storage storage batteries, because the capacity is limited. So just at this moment, still there are cables connected to the vehicle.
Doom, those side boosters totally huge. Each one of those side boosters is about the size of an Antares core stage. Yeah, maybe a little bit bigger than that. This rocket has payload capacity that's roughly similar to like an Atlas 552 or a Delta IV Heavy. It's 25 tons to Leo. It is a heavy lift launch vehicle by definition. It has 4 Carolox boosters with a Hydrolox core stage. So it would be like if you took Antares boosters and put them on an Ariane 5's core stage. That's what it's like. That's what it would be the most similar to, I guess. Yeah, I mean, Long March 5 is not, it's not a bad launch vehicle. I mean, 25 tons into space is no joke. That's really hard to do.
Of the vehicle, so the launch window is limited by this.
It's not the worst either.
By this consideration, the angle between the direction of the sunlight and the autoplane must be less than 30 degrees. And also, this because this is the condition of the sunlight, and also the time of the launch. We must ensure that when
that's the one that's on the coast. That's why I'm covering it, dude. I don't have a problem
from
they're going to launch off the coast.
Space station. When the solar panels is deployed, there are also sunlight to ensure the power supply.
Yeah, so sometimes we saw this kind of launching window in the middle of the night. Yeah.
Yeah. But this is the launch of the first module. For the second module and other ships, the things will be changed, because they match the launch into the first orbital plane. The accuracy of the launch window is only 1 second, which is called zero launch window.
Nice. Zero launch window.
So once it's missed, you have to be
another day.
They have to totally reschedule then.
Well, it's maybe better than the Mars exploration because once it's a mess, it's going to need to wait another 26 months, right?
Maybe the next, for this, maybe the next 24 hours. Every day we have a launch vehicle for this, for the next vehicle to go into the same orbital plane of the station.
Falcon 9's low Earth orbit capacity in fully expendable mode is 22.5 or 22.8 tons. 22.8 metric tons. It's actually an expendable Falcon 9 is almost the same as the Long March 5.
There are 4 major launch sites in China, right? This is a great coastal view. I mean, this satellite launch center or launch center is located in coastal regions, but we already have another one called Jiuquan Satellite Launch Center. That was way up north in the Gobi Desert, right? That one is for launching astronauts into space, while this one you're looking at is responsible for launching cargo spacecraft
About 20 minutes.
Why is that, Mr. Xu?
Well, I think this is like previous, we have just mentioned about the fueling system. We have developed a new generation launch vehicle, which is based on liquid kerosene and oxygen. That fueling system
That's
is
right,
part of the
we have a SpaceX launch after this.
So the Wenchang satellite launch site is only for kerosene, oxygen, and hydrogen fuels. There is no other fuel system that is available for the rocket in Wenchang.
I agree, Green. That's fine.
So new generations starting from Long March 5 onward, such as 6, Long March 7, and 8, will all use the same fueling system. So all of those rockets you will see in the future will be launched from this particular launching site, including
I hope they show that during
the Long March 7, which is due to be launched very soon, following this mission of Long March 5. As you mentioned about Jiuquan, I think that we also need to mention about the system engineering of such a complex program.
Thank you for showing
as human missions.
Can you show that shot again, guys?
The system comprises not only the launch vehicle, but also the TT&C support system, the ground facility, the manufacturing, the operation, and the human missions, including life support system. All of this will be put together.
Called? Yes, it is.
And to form a complex and very complicated system. So as you can see, at the launching site, they're preparing for the launch of the Tianhe, and also busy at Jiuquan, they're busy with the astronauts preparation. So once the Tianhe is in orbit, in the right inclinations and orbit, as Professor Yang mentioned, once in a day opportunity. So once we capture that window and we insert this Tianhe into the right orbit, and we will start preparing for the following missions. And of course, the designing of the orbit as well as the launching opportunity is also based largely on the orbit and communication capabilities. It has to be flying over the Chinese territory that we are able to see and witness, to control the rendezvous docking in the future for the human missions.
Mr. Xu, the Long March 5B is going to launch from the Wenchang, and how long can we expect it for this flight? Like, how long did it take to enter this orbit?
Roughly, we consider that launching timing by seconds. I think it's around 1,270 some seconds before we see the insertion.
That's about 10 minutes.
Yes. So once it's in there, they will see the deployment of the solar array of the Tianhe and then start communicating with the Tianhe. So right now, the ground crews as well as those connecting ports or the umbilicals you can see from the ground to the launch vehicle is basically communicating with the launch vehicle as well as communicating with the Tianhe station. So once it's launched, we'll focus on the control of the launch vehicle, and once deployed, we'll communicate with the Tianhe directly with using TT&C network, including
really
ocean-going ships
out a lot
as
of
well
information.
as ground crew. So it's a process that will take very close connections between each other.
And let's talk a little bit about the Tianhe core module, right? Because she is the star today.
Yes.
You were looking at the bottom of the rocket, but at the tip of that rocket, the Tianhe core module was actually encased in that huge casing called rocket fairing, right? And Dr. Yang, talk to us about it. China hopes to have its first space station operation by 2022. But how is this core module instrumental to the space station's construction?
Well, of course, the core module will be the most critical step of the construction of our station. In fact, this Tianhe-1, the accurate name is the test core module. So it is
right, SCP?
At this moment it is not the formal core module of the station. So after launch, we will perform many critical or key technology demonstration as testing. If all these are okay, we can formally change the name to the core module. If something wrong, we must have some improvement. We will launch a second core module. That will be the formal one. So before this, we must perform the demonstration of many key technologies. For instance, the long-term residence of astronauts in space, the regenerative life support system, and also other technologies to operate so heavy spacecraft like this. And also, we need to test the transpositioning technologies for the experimental modules. You see, we choose a different technology comparing with other countries. Although we also choose a modular design like the Mir station and the International Space Station. But we when the Mengtian and Wentian modules is stocked, we transfer its position by a special mechanism. So we must test this technology.
Well, thank you, gentlemen. Stay with us. And China is...
So what my man over there was saying is that they made two modules. They have a test module and they have a backup module. So they're going to launch a test module. If the test module works, then they'll launch a backup module and butt them up together like that. See, they'll be attached next to each other, right? They basically built two of these core modules here. Like here, Guy will show you. See what I'm talking about?
It took me only a few minutes to finish this model of the Chinese space station. But if you're going to build an actual one in space, it's not that simple. China's Tiangong space station project consists of 3 stages: key technical verification, construction, and operation.
It's modular. It's modular like Mir.
The launch of China's Long March 5B rocket in May of 2020 was a key milestone, validating this rocket.
Yeah, did you see that, Kevin? It's got a robotic arm on it to place the modules.
The station's core module called Tianhe into its designated orbit.
Okay.
Tiangong will be a T-shaped structure with the Tianhe core module and Mengtian and Wentian experimental modules. Besides the 3 launches to put the modules in orbit, China has planned 4 manned missions and 4 cargo missions. 11 intensive launches in total by the end of 2022. All of China's manned space missions will rely on this Long March 2F rocket. The Shenzhou spacecraft sits on the top of the rocket. Once the core module and later the entire Tiangong station are in place, this specific craft will dock with the core module while in orbit. Chinese astronauts will not only conduct a number of experiments, but also carry out
don't get stuck.
activities to help complete the construction of the space station. Living and working in space for long periods of time requires more supplies. This is where the Long March 7 carrier rocket comes in. It will be used to carry the Tianzhou cargo ship, which will contain food, water, and other necessary supplies to the space station.
Correct, Limford.
All of these missions are integral parts, furthering China's endeavors for space exploration. Wu Lei, CGTN.
So that core module, guys, here, I'll back it up. That core module is a test module. See this guy right here? That's what the core module looks like. That's what they're launching today. This looks like it's derived in some way, shape, or form from a DOS module, from a Russian DOS module, but it's also important to mention that at this point, it's so far out of the gates from when China exchanged, or Russia exchanged information in China, you might as well just call it its own thing. We'll call it a Tianhe core module here. Now, they have 2 of these. There's this, and then there's a backup, right? They're going to launch this test module, and if this test module works, what they'll do is they'll take the backup, right? They'll take the backup, and they'll most likely convert it into one of these modules here. Or they could use it as a functional mock-up down on the surface to test the station. That's what we did, and that's what the Russians do as well. There are copies exact 100% working copies of like the Zarya in the Zvezda module in Russia at Star City. There is 100% replica. It's an exact copy of the same thing. So they can test doing stuff down here before they go and prototype it up there. Simultaneously, over at Johnson Space Center in Houston, there is a functional mock-up of the ISS, of the U.S. operational segment. That's why, like, when you we're talking about contracts before. When you contract this stuff out, right? You always contract out for multiple versions. You contract out for a flight version and then basically a clone of that. So you could use it as a mock-up down here if you need to test stuff and prototype stuff on the station. Everyone does that. Yeah, that's smart. That's smart building. Imagine if we had to do that in mission mode. Funding would be tight. No. Yeah, I don't really need to, Sneaky, because I know the modules will dock together, but yeah. Yeah, I know, Swishio, right? Oh. They popped an umbilical. Oh, they popped. Why would they pop the umbilicals before the...
between the cargo ship
they popped the umbilicals.
There are two ways.
Usually,
automatic
a lot of Western rockets don't usually pop the umbilicals off like that until the rocket takes off. The reason is because if you have to scrub, you don't have to send a guy out there to go and reconnect them, but China clearly gives no fricks about that. No, it's not that they give no fricks. They have a service structure right next to the rocket. They'll probably just... So this service structure actually is like a clamshell. It rotates around so they can get at the rocket pretty easily. These are gigantic hinges, and this thing actually turns and it becomes a gigantic building around the rocket. So like when they go to deploy the rocket, this whole thing turns out. Like, see, these are service structures. These are service gantries right here, and the whole thing pivots. So, I mean, it's very clear that even though they're separating the umbilicals, even if they do scrub, they can clearly turn the rocket around pretty quick.
Gyroscopes, the accelerometers, and the onboard computers are okay. So we have...
Ivan, we can stream this one because it's out of Wenchang, and it launches out over the water. I don't have a problem with that. And this is the first time I've seen a Chinese launch with a state-run broadcast. I was just genuinely curious as to what this was like. But, yeah, it's very interesting. Actually learning a lot here.
The last one, which provide also
power
supply to the vehicle. And now, because some of this system
okay, 13 minutes out. Long March 5 is a Hydrolox core stage, and then it's Keralox boosters. It would be like if you took Antares boosters and strapped them around an Ariane 5 core. So you got a Hydrolox center, and then you got 4 boosters. Now, this is a Long March 5B. This is the B variant. The B variant has no upper stage on top. It's just a big payload fairing. Instead of having a smaller payload fairing and an upper stage. This Long March B variant is specifically designed to deploy space station modules, like what you're about to see. Okay. I think wind. That's the wind. 1 meter a second at 30 degrees. Ambient temp is 25 centigrade at 87% humidity. I think that's what that says.
And Mr. Xu, we were looking at the launch team in our screen now. Talk to us, what is it like for them? I mean, during these last few minutes, few seconds leading up to time 0.
Sicher, Penderman.
I would imagine, right? It's got to be extremely nerve-wracking, but at the same time, you got to keep calm and focus on what you do. What do you think is going through their mind?
Penderman, I can't. Dude, her accent is so freaking vanilla. It's messing with me, dude. I'm like, wait, what's happening here?
So I think they're good in confidence because
really good.
The data, as Professor Yang mentioned, are constantly feeding back from the rocket. Even though the cables are disconnected, we still have remote TTNC signals, and we have also all the sensors that is working. So the ground crew or in the command room, they're controlling, monitoring, and keep constant eye on those signals,
control audio is live.
Sensors. On the data and parameters. So if everything goes normal, because they have the time to compare, and if everything goes normal, they will count down to the last minute,
6 minutes
or the
out.
last second. If not, they will have the authority
well,
to
no,
call off the
little bit more than that.
We have this happen before.
It's more like 8.
Even seconds before the launch, we call off the launch itself because of the anomaly occurred in the launch vehicle. So even disconnected, we still have all the connections made to the launch vehicle.
Mr. Xu, in a previous we mentioned that the carry out by the NASA, we can saw them from the live streaming that there is the go no go procedure. It's a poll to decide whether they're going to give a call.
Panaman honestly didn't know until you just said something. Wouldn't. I mean, it's not just you. I mean, that's fine. Like it's messing with me. Okay, like all right, I'm a d-bag. I fully acknowledge my d-baggery. Like I expected everybody to talk like the engineer, but. I mean, I didn't know that they'd put it on their English state-run station. So the English state-run station obviously has a lot of people that speak English. Oh God, geez, funny how that works, you know? It's just kind of it's kind of like, huh? I know it makes me happy. That's cool.
And what happened prior to this, around this time, is that the air conditioning for the fairing has been cut off, right? Talk to us about it.
You see that the temperature and other environmental parameters must have kept in the correct range during the launch.
It's not easy to learn another
language inside the payload fairing.
And it especially isn't easy to learn another language and be so fluent in it. That's not easy to do, especially going from a dialect like Mandarin to freaking English. The words are completely different. Like the pronunciation is totally different. I respect that. That's pretty cool.
And as mentioned,
Yansu
has mentioned, we not only have signals from the cables, we also have wireless connections. You see that the payload fairing is made of metals, so we must prepare some special non-metal material to have a window to allow the radio signals to coming through.
I don't even want to know.
Right, that's a comfort. That's a most comfortable zone within that fairing.
And the Tianhe core module includes the living quarters for astronauts and control center, right? And needs.
You could do some Zhao Ma stuff up in here. It just confuse people.
How is that being masked, Dr. Yang?
Well, you see that from the outside, we can see that the core module is composed of a node, a small cylindrical segment, and a large cylindrical segment. The bedroom or the sleeping chamber of the 3 astronauts is in the small cylindrical segment. Okay. Also, there is a toilet there.
They gotta have that. Gotta have that.
Yeah, Mr. Xu, can we go ahead with our go no go?
He's like, what?
I'm still very curious about
T-minus
that.
30 minutes for SpaceX, and then we're inside of 10 minutes here. We got two rocket launches ready to go, guys.
I think the go and no go is basically on the launch vehicle statics.
I got it for you. What's the payload?
Of the engines.
So this is a high-profile launch here for China, for the CNSA. CNSA is China National Space Agency, so that's NASA. That's China's version of NASA, or vice versa. I mean, how you want to look at it. This is a Long March 5B rocket that's launching a space station core module. China's building their own space station, and that's fine, totally cool. This is the core module for it. The Tianhe. Am I saying that right, Panda Man? I want to make sure I'm saying this correctly, dude. They were saying Tianhe, but it's Tianhe, or I'm not sure the right way to say it. But this is the first module, Dak. Yeah, this is the core module for China's Tiangong 3 station, which means Heavenly Palace 3 in English. So yeah, it's interesting. They're not usually this upfront about when they launch stuff into space. So that's why I was curious to kind of peek my head over here and see what's going on. Can Dragon dock with it? No. Classic, yeah, no. No.
A smooth one.
All right, that was a great split screen, but you're now watching at the side boosters of the rocket. We are just moments away from that liftoff.
I don't know, Christian.
Also talk to us, Dr. Young, the energy about the core module. I mean, everything run in the module needs energy, right? And I suppose solar energy is the main source?
Yes, you see that's the final step of the launch, in which case we can announce the successful launch success of this mission will be the deployment or the unfolding of the solar panels.
Dude.
That means the core module can have continuous power supplies from the sun. You see that our core module have one dimension.
This thing can't. It's in a lower inclination than the ISS.
SADA or the solar array driving assembly, which can rotate and let the surface of the solar panel meet the sun.
right.
Dude, I get it. Come on, man. I get it. You know, there's a lot of posturing on an international scale, so a high-profile launch like this would be televised. I get it. It's, you know, I'm not, you know, I'm more about the engineering. I'll be honest with you, about the engineering behind it. But yeah, of course, dude. Of course they would put a high-profile launch on, like, for everyone to see. You know, that's Rule 8 people gonna Rule 8 people, man. Like, let's not beat around the bush here. We do the same thing. Like, I'm not saying that's good or bad or anything. Like, it's just same stuff. China has human-rated vehicles. Yeah, Long March 3 launches the Shenlong capsule. Shenlong is a Soyuz-derived vehicle. The Chinese station and the ISS at the same altitude. Negative. These look like they're gonna be in different inclinations and at different altitudes.
Well, you see that we adopt docking mechanism called the APAS, or the androgenous 5 minutes countdown.
5 minutes countdown. We are entering the final stages, really. Oh, there you see Chinese Premier Li Keqiang. That is the live picture coming out from the Beijing Aerospace City. Chinese Premier Li Keqiang is among the audience who are watching this launch very closely. That is Mr. Wang Ying, member of the Standing Committee of the CPC Political Bureau. They are there to watch this, which really speaks volume about how important Beijing sees this mission, isn't it, Dr. Yang?
In every important mission,
Beijing don't screw up, man.
Also
no pressure.
Important role to give commands. So you see, there are control centers in Beijing and also in the front.
Guys, so that would be like the vice president showing up for a launch over here. That's about the equivalent. And then there's all these guys. Yeah, that's like the VP showing up for a launch. You don't want to screw up. Don't do that.
To show how important today's launch is.
And very interesting, that Beijing Aerospace City you were seeing is also the main training base for China's astronauts, right? A lot of Meet the Press events were actually
core module for the new space station, bloody.
It's just in the northern part of Beijing City, right?
And the primary function of that aerospace city is also known. All right, this is the live picture coming out from Wenchang. That is Mr. Zhang Youxia, who is in charge of this mission.
You got T up in there?
The chief commander of China's manned space program. Oh no.
Right.
Cool.
Right.
So this launch is going to kick off
it is on the coast
of
gauge, and it's Wenchang.
Coming, I think, in 2 years, right?
This launch site here is on Hainan Island, which is south. This is south of Hong Kong, south of Macau. Like, this is near North Vietnam, actually. It's North Vietnam is like just a stone's throw away, 3 minutes out. This is South China. So it is on the sea on Hainan. Hainan is an island. So they're launching south, 41 degrees incline. Thanks, Green. I knew this was a lower inclination than the ISS, but so it's 370 by 370. So it's lower than the ISS and in a slightly less inclination. So in axial, well, not axial tilt, but it's just Vietnam now. Shh.
Any tiny mistakes
Right.
could be catastrophic.
Be quiet, Elfish.
I want to get back to the very fundamental question for both of you, Mr. Yan and Mr. Chu. What is the significance of
this? Is their English cue, fortunate son? No, this is the English-speaking Chinese state TV station. So this would be like C-SPAN covering a launch, which is peculiar. But I was actually kind of interested here, like, to see what's going on. We're inside of 2 minutes, guys. All right, let's see what you guys got.
Cool.
Well, I think it's also very important for future human missions, either to the moon or beyond. So if we want to be an interplanetary species, this is the very first step.
Did we see the umbilicals pulling away? Is this about the time that the umbilicals
maybe several seconds later?
Seconds later.
The final plug or the major, the main plug will be disconnected.
And that will indicate that the launch pad team has given a go.
And just before this,
this thing's going to yeet off the pad. Watch.
The power supply will change from the ground to the vehicle itself using the storage batteries.
2 minutes, I think.
2 minutes out.
Yeah, I heard that. It's 2 minutes. Yeah, we're watching this. Long March 5B. I think that's for 335 meter diameter boosters.
Yeah, because of the
hydrogen.
hydrogen.
More about that booster.
The booster, as you mentioned, the booster has a diameter of 3.35 meters using liquid oxygen and kerosene as the propellant, and each have a thrust of.
Oh, I thought it was a solid. I used to have thought it was.
No, it's not solid. It's liquid
so
rockets.
Liquid fuels.
And
he's explained that like 3 or 4 times, guy. Who are you paying attention to?
All right.
So that was using liquid oxygen, right?
The core stage use liquid oxygen.
Okay, we're seeing the countdown clock there.
Yeah. So everybody's watching that.
Okay.
All right, T-minus 60 seconds, 1 minute prior to liftoff. Truly an incredible moment to witness.
Well, I'm getting nervous right now.
Yeah.
There are also cameras on the rotational arms to monitor the disconnection of the plugs.
And ladies and gentlemen, if you're just joining us, you're watching the live feed coming out from the Wenchang Spacecraft Launch Center. China is about to launch the core module of its Tiangong space station 40 seconds out. The Tianhe core module is on board that rocket you're looking at, the most powerful heavy lift rocket, the Long March 5B rocket, 30 seconds out. 29 years after China's manned space program was envisioned, the first module of the space station is finally being launched to space. Less than 20 seconds out. What an extraordinary moment. All right. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition.
Whoa. Are you kidding me right now? There's a button? You pushed the button? That's kind of dope. Oh, that's kind of dope.
And liftoff. What an incredible view.
Are you kidding me?
That is the sound of history. A historic spaceflight carrying the Tianhe module, the core module of China's space station. That itself is history in the making, a major milestone of China's space program with the ambition to explore deep space. Not even gravity contains humanity now. And Dr. Yang, we are looking at the view of the side boosters, aren't we?
Exactly. This is a camera mounted on the core stage.
That was what they said for Crew 1.
Looking downward, we can see that the two of the.
The lady just said exactly what the lady said for the Crew 1 launch. That's weird.
Mounted on the surface of the core module, so it does not influence the shape, the total shape of the vehicle, and also don't have the aerodynamic influence.
And keep in mind the Long March 5B has 4 strap-on boosters like this. You are looking at 2 out of the 4, and they run on liquid fuels.
Should
and
be coming
in the
up
next
on
few
max
minutes,
Q now.
these boosters will detach and fall away after propellant is burned up. All right, 69 seconds into the flight.
70
Everything
plus. Looks like we went through max Q
going
there.
Good. The core stage will continue to burn after these boosters detach. And in the next few minutes, we're going to see some major steps, are we? Mr. Xu.
Look.
Yes, I think the separation of the booster will be the first thing you will see.
Panda Man, am I picking up on this right? Dude, it sounds like the engineering dude, the professor, is into this. He's like, look at it launch. I get you. I'm picking up what you're laying down. He's pretty pumped.
About 100
That's kind of all right. I dig it.
Ground. You'll see the
Dude, the
fairing
professor
also will be
I think his
separated.
name is
And we're seeing this 3D animation on the right of your screen, right? And you can see the rocket has pitched over a bit.
Yeah.
Originally, the rocket is shooting up vertically, but eventually it will fly in orbit, so it's going to take a turn in direction.
It's rotating and turning slightly.
I know,
now it's heading to the Earth's orbit.
Southeastward.
Got a lot of paint coming off there.
Orange flame
So
out of the nozzle.
it started with the vertical flying.
The aerodynamics ripping the paint off the booster.
So
See that?
the pitch over is the first operation after liftoff is already being successfully completed.
Dude, launch button.
And
That was pretty dope.
Yansong has mentioned, the next step will be the separation of the 4 boosters, just 3 minutes
SpaceX
after
Alive, got it.
liftoff.
All right, that's the major event coming up, booster separation.
A lot of paint coming off that sucker. Wait,
Because
whoa.
separation
Something's coming
is
from the
always
booster.
very
Look.
dangerous. Their influence of
Yo, the skirt on the booster is getting all messed up. I'm not sure if that's bad or not. I don't know much about Long March, but there's definitely a lot of paint coming off here. I'm gonna go ahead and guess that it's probably not an issue because these things are about to get jettisoned anyway. There's cut off.
Booster separation.
Great.
You can hear the cheering and the applause from Command Center. Looks like we've got a good separation.
We got a good start.
Separation.
guys.
All right.
So you now it's just the core stage.
Okay, all right, we're good.
Go and throttle up.
So you can see also this is
the ellipse of
camera.
Earth?
Oh, this is inside the payload fairing.
Dude, he is pumped. Yo, Yang's pumped. That's wicked funny to me. I like that.
That we're watching at.
We can see there are some lights inside the payload fairing. And also, you see
the professor is pumped,
right
dude.
The screen is the 3D animation. This 3D animation is based on the real date downloaded from the vehicle, the position, the attitude, and the condition
Yo, this guy's
of the
into
engines.
I like that. Oh, there it goes. PLF jettison confirmed.
Another round of applause.
Yeah, there's a lot there, Sneaky, but.
And you are watching at the
worked,
dotted
I
yellow
suppose.
lines, right? What are they? These are data links from ground
yes,
tracking
that shows
stations,
that
what's the payload? Chinese Tianhe core module, dude. It's the first module for the new space station. That's why we even have a stream of it, dude.
We have stations in our Xisha Islands, and also we have the space tracking ships.
You got a raid a little bit? From whom? Oh, Horologist hit me with a raid. Thank you very much, dude. I totally missed it. I'm sorry. We were getting ready to launch, dude. Thank you for the raid, man.
So this is the camera mounted also on the core stage and looking forward, not like the last camera we mentioned. So you can see part of the space station.
Mr. Xu, it's very
about the size of Mir
Squall, because the Long March 5B is the single stage.
Yeah, it's
rocket.
a Chinese space station.
It's not like the Long March 5.
Tianhe, which
and in the previous.
So Tianhe is the name of the core module. That's what's going up into space right now. Tianhe is going to form the core module of a space station called Tiangong. Tiangong is Heavenly Palace, I think, in Chinese, if I'm remembering right. Tiangong 3, that's the name of the station. There was Tiangong 1, Tiangong 2, and those were basically prototypes of this. And now, in a similar profile to like how the Russians launched a bunch of modules up and then they started coupling modules together, that's what they're doing too. The Tianhe module will make up a much bigger station. They'll start coupling up more modules to it. So in that regard, it's a lot like the Mir core node. It's very similar to that.
With the Tianhe. So once that is happened, it means the success of this mission, of this launching phase.
And I think it's going to be more complicated than the multiple stage rocket, because you got a bigger stage, you got a main engine that creates 140 tons of thrust, and you stop them suddenly. It's like I think it's like the high-speed train have an emergency stop. Can they just get into this orbit properly?
You just mentioned a very important fact. Because you see that Long March 5B is the only rocket in the world that only have a 1.5 stage to come into orbit. So there are many great challenges. For instance, as you mentioned, we use the two YF-77 rocket engines in this core stage, which have a thrust of 50 tons. That means that the total thrust of the core stage is 100 tons. It's very big for when it is shut down to come into the orbit. Because you see that we have very
switch over to SpaceX very soon,
in
guys.
the accuracy of the orbit. Well, for this accuracy, the smaller the thrust is, it will be easier. But you see that the thrust is rather big. And at this moment of the shutdown, the core stage, the tank is almost empty. So it is very difficult for us to keep the accuracy. That is a great challenge when we develop.
Dude, that guy is pumped. He's pumped. That's so interesting hearing it in another language. I'm sorry. That's really cool. He's friggin' into it, dude. The professor.
Now. And the rocket is flying over the Pacific Ocean, right? It's actually flying.
All right, 4:30 into the flight here.
Southeastward, so
all right, guys, I'm gonna switch us over to SpaceX now. I'll keep you guys in the loop, and just like we did before, we're 13 out on the SpaceX launch here. I know, Sneaky. It's just interesting hearing it from, like, dude, he's super into it. Like, you could tell he's getting fired up. Like, that's bizarre. Like you know, like you see the Europeans, you see the Russians when they launch, they're like, yes, this is good. This is good. The Europeans never smiled during their damn launch coverage.
Discovery.
You know, it's cool seeing them kind of fired up. That's kind of makes me happy, man. I'm like, oh, all right, this guy's getting into it. I can get down on that. That's cool. All right, so I'm gonna switch us over to SpaceX here. We have a Starlink launch. This is the launch medley. And Horologist, thank you very much for the raid. I do appreciate it. Panja had a 32-month resub in there. We're going to flip us back over. Oh, man, they just had core stage separation. Here, look. There it goes. Look. Watch this.
Hydrogen and oxygen.
So they had engine cutoff right there.
Will be fully displayed in outer space.
Did we heard the engine cut off?
And
oh! Separation.
Great.
Oh!
Separation is ongoing and
a perfect
Deuces.
view. This is the
Holy balls, man. Hey, it's got an A passport on the back.
Of Long March 5B. And you can see from the screen on the left side is the Earth.
Frick,
right,
dude.
Because it is under the sunshine.
Wow.
Wow.
Okay, that's something you don't see every day. Well, shoot.
Now is flying by itself in
way
orbit.
Way to go.
It's already in the initial orbit. Theoretically speaking, is
So yeah, that Long March 5B put it right into its orbit. Damn, dude. Good job. Cool. Hey, Nick Tide, another win for humanity. Yeah, here we go. And right on cue, we got another one. 10 minutes. 10 minutes until Starlink.
At the top of the rocket, what you're looking at on your screen is the fairing.
I'm going to back it up a little bit here. Right here.
Michael Collins, who passed away earlier today at the age of 90. Collins served as the pilot on the Apollo 11 mission that helped define a pivotal moment for our nation. Yeah, it's been nearly 50 years since humanity last stepped foot on the moon, and we are honored to follow the path Michael Collins helped lay out years ago. Working with NASA to support a permanent human presence on the moon will require the safe and affordable transportation of crew and significant amounts of cargo.
Okay, I'm going to push us back over
Technical
here.
poll at T-1 hour.
10 minutes
and the launch
out.
director held a propellant load and launch go-no-go poll at T-minus 38 minutes. Falcon 9 has been loading propellant since T-minus 35 minutes, and our fuel is a refined form of kerosene, which we call RP1. Our oxidizer is a super chilled liquid oxygen called LOX, and to densify the LOX, we chill it well below the boiling point, allowing us to fill the propellant tanks as much as possible. Now we use the same propellant on both stages as the second stage is primarily a short version of that first stage, which is one of our many reliability features of the Falcon design. With fuel and oxidizer on hand, we do need an ignition source to complete that fire triangle. For this, Falcon 9 uses TTEB, which you'll see at T-minus 2 seconds via the green spark right before the rocket takes off. In addition to RP1 and LOX aboard, Falcon 9 also uses helium to keep the tanks pressurized in flight and the propellant flowing correctly into the engines without air bubbles as the propellants deplete. Helium load began before the webcast went live and will continue to top off until a minute and a half before launch. Now, very shortly, we will open the pre-valves between the first stage engines and the propellant tanks. And at T-minus 7 minutes, engine chill will begin, and that's where we cool the turbo pumps and avoid thermal shocks when we start the pumps at T-minus 2 seconds to light the Merlin engines. The vehicle is healthy, and we are currently working, no issues. The range is green for launch. Weather is looking good. We're about 90% favorable for launch at T0 today. And all systems continue to be go for an on-time liftoff at 11:44 p.m. Eastern Time.
So, what did you say? Well, the Chinese rocket stage deorbit. It's in a decaying orbit, Huggy. It's going to come back down.
Eastern Time.
How many times has this booster flown? I'm not sure.
We talked a lot about human spaceflight activities at the front of the webcast. This is why SpaceX was founded. Ultimately, our goal is to enable regular human transport to and from the moon, Mars, and beyond. Our focus on human spaceflight played a significant role in our development of Starlink. It was critical that we build a constellation in a way that ensures space stays safe for all missions, particularly human spaceflight missions. So we approached our satellite constellation differently than others have in the past.
They had APAS ports on that space station core. Those were APAS all day. Or some type of I think Professor Yang said that it was yes, that was his actual name. Shut up. His name was Yang Yul Yang. I think is what his name was. He said that they're using an APS, which is an androgynous peripheral system. So I'm guessing it's somewhere between the IDSS and APAS. It looked like APAS, but it looked like it had pedals from IDSS, which is weird. So I'm assuming it's kind of some weird halfway in between.
For hundreds of years. And unlike our Falcon 9 rocket, Starlink satellites are not designed to survive
just
re-entry.
coincidence, Mark.
In fact, Starlink satellites are designed to be fully demisable, meaning that they burn up when they re-enter the Earth's atmosphere. Beyond making sure satellites deorbit at the end of their useful life, we also need to ensure we didn't run into any other satellites or objects in space. We cannot talk about space safety without mentioning the amazing folks at the 18th Space Squadron who keep track of space debris so that we can effectively dodge it.
Hellfish.
3 times per day, the orbit predictions for all Starlink satellites are uploaded to space-track.org, which is managed by the 18th Space Control Squadron. The 18th Space Control Squadron screens the predictions.
Brimo, if you're here about who tracks the debris from space and launching and whatnot, that's the 18th SPCS, the Space Control Squadron, part of the Space Force. They're the ones that do that. Every country has a Space Control Squadron like that. Ours are part of the Space Force. They expanded it with the Space Force a couple of years ago because more people are launching more things into space. You need to expand to take into account all the stuff that people are launching into space. So those space control squadrons are kind of what coordinates the launch and makes sure that everybody's good. Now our Space Force squadrons aren't talking to the Russian Ministry of Defense and they're not talking to China's Ministry of Defense, but everybody tracks everybody's stuff. It's called space situational awareness, and it's a vital thing, just like how everybody kind of monitors international waterways around the world with satellites. Like, do you think it was any secret when the Ever Given got stuck that the Russians, us, everyone pointed their satellites at it? Obviously it was no coincidence. You know, everybody kind of monitors it and monitors each other's things. It's just kind of a way to make sure that no one's doing anything dumb.
It continues to grow.
It's almost a weird form of checks and balances.
Now we're currently at T-minus 5 minutes from liftoff, and Falcon 9 is now moving into the final stages of the countdown. We're currently waiting for the transporter erector, or the TE, to retract. The TE is that structure that's right next to the vehicle on your screen. It's slightly behind the vehicle or to the left on your screen. First, the TE clamps will start to open, and then the transporter erector will begin to retract away from the rocket slightly.
Did you leave a message
And then
here?
at T0, hydraulics will pull that TE farther away from Falcon 9 to clear the way as the vehicle lifts off.
Thanks, man. When the Chinese module was detached, did it not gain acceleration in its orbit? If so, how did they correct this? Tweets, it has reaction control system thrusters on it, or RCS, that will help place it into the right orbit. So they had a nominal stage insertion of 400 by 170. So that means the apogee of the Tianhe core module is at the altitude that they want the station to be at. So they said it was 370, but it hit 400, I guess, from what I saw people saying in chat. The Tianhe has little thrusters on it. It has RCS that will correct its orbit. Using the Oberth effect at the apogee, if they boost prograde, it'll boost perigee up enough to make it nice and stable. The reason why they shot it into a slightly eccentric orbit, so 170 by 400, is so that 5B core stage will come back down. The problem is it's an uncontrolled descent, which I kind of am not too incredibly happy about, but maybe they changed it this time.
Those white clouds.
Uncontrolled descent is not words that you want to combine with re-entry. Yeah, that's bad. You don't want that.
First stage should finish prop loading at T-minus 3 minutes in a few seconds here, and then second stage.
Yeah, Neuro, everybody monitors we do talk to Russian and Chinese on civilian and classified spacecraft. Interesting.
Falcon 9 will be in startup.
All right, guys.
Go, bleed verification.
And what startup means is that the rocket's autonomous internal flight computers have taken over the launch countdown.
A lot of action tonight, B.
That LOX load is now complete on both first and second stage. Now just inside T-minus 2 seconds, we light the Merlin M1D engines, and we use T-Teb, as I mentioned earlier, as our ignition fluid. And when it mixes with the oxygen, it will burn a green-colored flame. And then
Now, I'm not going to lie to you. I'm not a big fan of that, but to be 100% fair, they're getting better at it. But China still, they need to work on not having stages land on people. Like, that's my big problem with them over there. But they're getting better at it. They're understanding it. Give them some time. This stuff doesn't get fixed in a day. I understand that. Space flight takes time.
For a launch.
Greg, it's actually at around the T+7 minute mark, so it would be 11 minutes from now. Jerk. What's up, dude? How are you?
There's that call out that
Third launch of the
LOX
night.
load is now complete. Now that LOX loading is complete, we will start to vent the LOX line on the transporter erector. So as I mentioned, those white clouds earlier, you're going to see a lot more of it here shortly. And there you can kind of see it on your left-hand side.
How's the core stage re-entry different than the shuttle's external tank? Every single shuttle external tank came down in the Indian Ocean, dude. Every single one of them came down and it re-entered. Well, mostly re-entered. Most of the tank was blown up. They actually, when the shuttle separated from the tank, they vented the hydrogen, the leftover hydrogen and oxygen, and they inerted the external tank, and they would put the external tank on a flip end over end to ensure complete destruction of the tank. Every shuttle launch had this type of external tank separation where they'd flip the sucker end over end and nothing would come down through re-entry. ULA actually ran a extremely similar ascent profile for the OFT-1 mission. That dual-engine Centaur was on a very similar trajectory, and they flipped it end over end to make sure that it would completely destroy itself.
30 seconds.
30 seconds. Here we go.
At
Third launch of the
30
night.
seconds, let's listen into the terminal count and watch as Falcon 9 takes our stack of
it's
Starlink
uncontrolled,
satellites out into space.
Okay.
Stage 1 press for flight. T-minus 15 seconds.
15.
Falcon 9 is configured for flight.
Okay.
10, 9,
Sound suppression
8,
system will activate.
7,
There it goes.
6, 5,
Okay, next
4,
step is engine ignition.
3, 2, 1, 0. Ignition and liftoff. Guys,
3 launches.
Apollo 11 Michael Collins. May the pursuit of exploration live on.
3 launches. 1 day. The medley continues.
Vehicle's pitching downrange.
Okay, that looked
Stage 1
good.
propulsion is nominal.
RB, 29-month resub. What was the first? Vega launched the VV-18 mission, and then there was a Long March 5B from China with the Tianhe core, and then Starlink here for SpaceX. This booster was flying for its 7th time here.
Falcon 9 has successfully lifted off from Cape Canaveral Space Force Station, carrying our stack of Starlink satellites to orbit. The next event coming up here shortly is Max Q. Max Q is the maximum aerodynamic pressure that the vehicle sees on ascent. So throttling down those engines helps us pass through that large structural load.
There's always a little bit of low pressure at the bottom of the rocket between the engine nozzles and the bottom. And it kind of makes it look like, as the rocket goes higher, it makes it look like fires going up the side of the rocket.
Vehicle has reached maximum aerodynamic pressure.
Don't worry, that's totally normal.
And there's that call out that we passed through Max Q.
Max Q.
In about a minute, we'll have 3
Northeast,
events happening within seconds of each other. The first will be MECO, or main engine cutoff, followed by stage separation, and SES-1, or second engine start 1. Now, MECO is where we shut down all 9 of the engines on the first stage.
Evac engine chill has started.
Okay.
Just a call out that
So now what they started to do is they started flowing liquid oxygen and kerosene into the second stage engine. The reason why you want to do that and thermally condition the engine is to make sure that you don't flash freeze and hard start the rocket motor. They basically prime the engine with the propellants to, 1, bring the engine down to temperature, and 2, when they go to start it, they don't want to sit there going with the rocket engine to wait for the fuel to get down to the part where it explodes and comes out the back, right? So they prime the rocket engine. That's what the M1D chill is for. So that's the second stage motor. They're now flowing propellants in. And if you look, when we get up to the staging camera, you'll see cables kind of hanging off the second stage here. They'll show, if they show the split screen here, and those cables will depress and they'll pop off. Those are the vent lines for it. Watch. Stand by for main engine cutoff.
Miko.
All right, watch. You'll see some cables kind of flopping around up here when they separate.
Stage separation
See?
confirmed.
There they are. Okay, stand by for ignition. Good ignition on the M1D vac. Now the stiffener ring should separate.
We had
Perfect.
Miko and stage
Perfect.
separation. On your left-hand screen is a view from the first stage. On your right-hand screen is
Also, there's Orlando, by the way. There's Orlando. There's Tampa. You're looking at the entire I-4 corridor right there. There's Daytona Beach. There's Port Canaveral right there. Orlando. See that big dark area? That's Disney World. There's Tampa. Fairing separation is confirmed. Isn't that cool?
confirmation on your screen that we have successfully deployed the...
And there's Kissimmee down there.
Attempting to recover the fairing halves today with a contracted recovery vessel named Sheila Bordelon.
There's the port. You can see it. This booster will be down there.
On your left-hand screen. It is a little dark over there on the East Coast because it is nighttime. But we did get some glimpses of the sunlight hitting those grid fins.
Starlink's 54 degrees
inclined. See if we can get some more
green.
views of that in a little bit.
It is Warhawk. The big dark area is Disney World, yeah. Because there's no light. I mean, there's lights, but Disney World's all spread out on a nature.
As stage two,
it's not actually.
As stage two takes our Starlink satellites to their targeted drop-off orbit, stage one will make its way back to Earth by executing 2 burns. The first is the entry burn, and that's where we light up 3 of the 9 M1D engines. And this will help to slow the stage down as it re-enters back into the upper parts of the Earth's atmosphere. The second of those 2 burns for that first stage is called the landing burn. And this is where a single engine, the center engine, will reignite and bring the vehicle speed down rapidly in order to touch down on that drone ship.
Fun.
As a reminder, we are attempting to land on Just Read the Instructions tonight. And those M1D engines do have a thrust of 190,000 pounds. So that lighting up that one single engine slows the entire vehicle down just enough to touch down on that drone ship. Stage 2 is still looking good, and what you're seeing on your screen is a view of that MVAC engine.
Vehicle's following a nominal trajectory.
Now, if you're just catching up with us, we had a successful launch of Falcon 9 from Cape Canaveral Space Launch Complex 40, and you're looking at a live view of the Falcon 9 second stage as it is making its way to deliver our Starlink payload to orbit. Stage 1 is currently cruising back to Earth towards our drone ship. Just Read the Instructions out in the Atlantic Ocean.
That's ship. That's it. They only use about 20% of the land, and I think that's.
We're just about a minute away from the next event on that first stage. That'll be the entry burn.
Also, during the Crew 2 launch, I don't know if you guys saw this.
Again, Starlink satellites are going to a LEO orbit or low Earth orbit, about 550 kilometers above the Earth's surface.
This is a couple of days ago.
Now, most satellites are at 36,000 kilometers.
Spaceship and a
or
spaceship.
in a geo or geostationary orbit.
Florida's flat, man. You can see the launches.
Just about roughly 30 seconds away from that entry burn beginning.
It's pretty flat, man. You can see the launches from Orlando. I knew. I lived in Orlando. You can see the launches on a clear night. See the whole thing. All right.
On your left-hand screen,
stand by for the
there
entry
is
burn.
the first stage. It is a little dark. You can see some glimpses of the nitrogen gas burst that you see there.
Nitrogen gas burst from the attitude control system.
Stage 1, FTS is safe.
So stage 1 flight termination system is safe. You can see some plasma accumulation on the grid fins over there on the right.
Stage 1 entry burn.
Supersonic retro propulsion.
And you can see on your left-hand screen the entry burn has begun as those 3 engines light up that view for us. This entry burn will last about 20 seconds long.
Supersonic retro propulsion.
Stage 1 entry burn shut down.
So that entry burn is done to slow the booster down.
Continues to follow a nominal trajectory.
And also, that's the booster's
That
heat shield.
concludes the entry burn, and then we also got to call out that stage 2 is still nominal.
Supersonic.
The next event coming up will be in about a minute from now. That'll be the landing burn, the start of the landing burn on the first stage.
Nice, Raziel. Hell yeah.
And what you're looking at live on your screen is a view from the second stage looking aft at the MVAC engine. That MVAC engine has a thrust of 220,500 pounds of thrust in a vacuum. It's very, very powerful engine taking our Starlink satellites to their targeted drop-off orbit.
About 900 and change kilonewtons.
Stage 1 transonic.
Stage 1 is transonic. Stand by for the landing.
Still getting
burn.
good call-outs on that first stage.
Supersonic retropropulsion.
We're about 15 seconds or so away from that landing burn beginning on the first stage.
It acts as the heat shield, Denny, and it also slows the booster down. It's double. It's dual purpose. So Falcon 9 shooting gases out the bottom pushes the plasma out of the way. Okay, there's the landing burn.
Landing burn has begun. Let's watch and see if this Falcon 9 can land on our drone ship. Just read the instructions.
Oh! Stick it!
And a really cool onboard view.
Stage 1 landing leg deploy.
Stick the landing! This never gets old! Come on, baby! No! No! Yeah!
And there you can see the first stage Falcon 9 has landed for...
That never gets old!
Has landed for its 7th time. Cool. This marks our 81st successful recovery of an orbital class rocket. And again, the 7th flight and 7th landing of this booster.
And there it is.
And then we heard a good call out for Seiko.
Perfect.
That second engine cutoff.
You win.
Nominal parking orbit insertion.
We got a good
and
parking
a good
orbit.
Orbital insertion.
Loss of signal, Cape.
Now stage 2 is going to coast in this orbit for the next 35 minutes or so. So while that happens, we'll keep you posted on where we are in the coast phase. We'll see you back here at T plus 45 minutes for a second stage relay.
Oh man, can I just please excuse me.
Has begun to still looking good.
Please excuse me. I just need to see that one more time. To make it look so damn easy. So Falcon 9, guys, is 150 feet tall. 47 meters tall, or no, yeah, about 47 meters tall. That's a 15-story building coming down. Look at this, look at this. You gotta be kidding me. Like, come on now. Oh, dude, that onboard footage, that's so legit. Just got home in time to watch stage 2 fly by. That's cool. Oh, look at that. Look at that. Oh, that's pretty cool. Oh, man. How did we get here? How did we get here? We just launched 3 rocket launches back to back from 3 different continents by 3 different countries. What in the frick? How did this even happen? Deck looks like it's made out of wood. Well, they sprayed it down with water. That's why it's got that sheen to it. The reason why they did that phase is because the water on the deck provides a good film cool. It film cools the deck, so when the rocket engine comes down, instead of burning the deck of the ship, it evaporates the water. The water absorbs all that heat. Smart. That's so they don't have to paint the drone ships as much. 3 launches in 2 hours, and we got one of the boosters back. Not bad, not bad.
Go at throttle up.
All right, got a nice onboard view here. Shrub, 49 months. I've been out of the loop. How's Kerbal going? Oh, horrible, Loopy. Yeah, horrible. I killed Jeb trying to land a dart. Yeah, horrible. Yeah, is the end of that sentence. I got 6 lunar landings in, which is good, but killed Jeb, so yeah, that's on hold for a little bit. Yeah, it's going really bad. The dart landing gear came back to bite us, dude. It did something I never saw. We never saw that during testing. I basically brought it down hard on the nose gear, and I shorted the landing so it was on uneven terrain. And I think what happened is that the nose gear hit a terrain seam and it shot dart up in the air and it started doing flips and killed Jeb, dude. Oh well, kind of sucks. But other than that, the program's going real good. Program's going real good other than that. Yeah, Jeb died. Freak accident, dude. I think we clipped the terrain seam. But it is what it is. Back, I had 1 sticking cloud and it was right in front of the flight path. Oh, I'm sorry, man. How did you figure out it was a terrain seam? I think it was wood bite just because I never seen... Loopy actually got up my tail about messing with the landing gear. We lost 4 or 5 darts to the landing gear testing a couple of months ago. I never saw that failure mode throughout all of the testing that we did. The only logical explanation is that we hit a seam. Why would the front landing gear pop like that? It had to have gotten caught on a texture seam. It's always Jeb. Yeah, Bill and Bob were riding right and left seat in dart, Loopy. It didn't kill them, just Jeb. It's always Jeb. I mean, that's the only... this is why I need time to think about stuff, guys, because I have to go back and I have to look at the footage and everything, and I have to kind of figure out what's going on, but I don't want people in chat like saying, oh, it was this. I need to look at it, and I'm pretty sure we hit a seam. But that's not Dart's fault. That's not Jeb's fault. It's just my fault. Dart is not designed to land on hills. It's designed to land on a runway. So maybe if you landed on a runway, it won't kill Jeb anymore. So I think where we should go is introduce some upgrades into Dart and get it a little more, we'll roll out the Mark II version of Dart, but I don't know what we should do with the lunar program. We'll see. I only killed Jeb. Where did you land? It's about 20 kilometers away from KSC. Sounds like you need to try some Dyson Sphere on stream. Swishio, thank you for the bits. No, I'm good. Hey, Eagle, what's up, dude? I think emergency shoots aren't the dumbest idea still. I don't think shoots would have fixed this, Loopy. Shoots wouldn't have solved this problem. The next burn on stage 2 will last less than a second at startup and is in 45 minutes, 45 seconds with cutoff at 45 minutes and 45 seconds. Nice, Thomas. Yeah, I guess passing. I don't know. We're a little ways out from deploy here, guys. So, okay, what the hell? Yeah, Swab. Yeah, I couldn't get my chicken. That's why I was annoyed. I couldn't get the chicken, so I crashed it. I think that guy with the Lego Saturn V forge, that dude that had the Saturn V behind him, I think that was a Long March 9. At least I think. I think that was LM9 behind him, but I didn't want to say anything. So this is a guy from the Tianhe launch coverage. He's got a Saturn V right there. And I think that's LM9, but I could be wrong. Nice, T-Man. I think that was the point of putting those there. Got a Lego Saturn V, and then I think he had Long March 9 in the back. Rewatch it. Rewatch launch. It looked like it changed its flight path. I didn't see anything out of the norm here, goalie. I'll ask for a question, please. Okay? Physics question. How are things falling off and being thrown back behind the second stage? If the stage is actively slowing down, as you can see by its speed, things are falling off and would have the same velocity as where it came from. There's basically zero resistance in space, so why are we seeing bits of ice fall off and go flying past the camera? It's not ice, it's solid nitrogen coming from the nitrogen at cold gas thrusters on the second stage. They're pushing the stage into a different orbit. They're adjusting its orbit. Are they really building Long March 9? I think so, Rocket Pilot, yeah. They're actively being thrown back there. Yeah. Night, Swishio. Arrivederci, amico.
Acquisition of signal, Gunhilly.
Hey, mates, we got acquisition of signal in Gunhilly. Gunhilly is in the southwest part of England. I don't know why I'm doing the Scottish accent for it. It just sounds like a place that would have a Scottish accent, but it's absolutely not. You're welcome, mates. Now, Gunhilly's down here. It's down by Cornwall, southwest part of England, over here. Ship show, I'm just happy for... I think they're happy for the business, dude, to be honest. Whenever I'm here, I think it's Zach Brown screwing that up. What do you mean, Brian? Could have been the angle. Space GeoGuessr time. Guess the country it's flying over. Weebo, I will destroy at this game. I'm really good at this. I know. I like geography. Geography is my favorite. I did really good in geography at school. That was like in 4th grade or something. No, I like it. So, all right. So we have Ireland right here. And then there's Northern Ireland, which is Ireland, but also not Ireland at the same time. A lot of people not happy about that. Get it? Scotland is up here. You have England right there, and then you have Wales right there, and then Isle of Man is right there, and then Isle of Wight is down here. Yeah, not bad for an American, I know. And then you have France right here, Spain, Portugal. France is right here. There's Monaco down there, which is a principality. You have Luxembourg, Belgium, the Netherlands, Germany, Denmark, Switzerland is right here, and then you have Austria, Italy, and then at the top you have Norway, Sweden, and Finland. Oh God, Zanku, no. Yeah, with it. Oh, arrivederci. Yeah, right. Nah, that's Europe. Yep. Yep. Also, you have an MVAC. Where is Svalbard? I have no idea. I'm looking at a map off screen? No, I'm not. Liechtenstein is over here. Andorra, I forget. San Marino is right there. Vatican City is right there. Then you have Sicily. You have, so Sicily's right there. Then you have Sardinia and Corsica. Where is Georgia? Georgia. Are we talking about the U.S. state or the country? Georgia's over here. Georgia's on the southern coast of Russia, next to Azerbaijan. If you're talking about Georgia, the state, it's way over there. Here, hold on. Let me move over here. I'll move to this side. It's easier. Think you could see Uranus? I mean, maybe like way in the background over here, Swamp Rat. But you know what you can't see? You can't see your rectum. Where's the UAE? You can't see it on here. It's off the screen. Turkey? Bazı. Turkey's right here. Istanbul, right there. Georgia's in Florida. Greg's like, I can see Uranus from Georgia. Where's the moon? Yes. Precisely locate Liechtenstein. So Liechtenstein, if I'm remembering right, is on the border of Germany and Poland. Could be wrong on that one, though. And if you'd be like, oh, you got it wrong. Yeah, that's a guess. I know. I'm pretty sure it's over there. Where is Putin right now? Probably in Moscow? Like, over here? Moscow's way over here. I mean, he could be at his dacha down here near Sochi. I mean, he has a big house right there. I don't know. Why would you ask that? I have no idea, man. Do I look like his biographer? I don't know. Where is Holland? Saw it for the first time in Dublin. No way, Hammers. That's awesome. So it's making its way over Europe now. Yeah, probably, Blasty. Bump, 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 bump. Hey everyone, I am from Holland. Isn't that weird? Morocco? Casablanca. Right there. Morocco's over here. So there's Morocco. And then, what's next to that? Libya? Oh, jeez. I don't know my African countries very well. Latvia? So Latvia, Lithuania, Estonia, Belarus, Ukraine, Poland. I told you I'm good at this. Romania, Bulgaria, Serbia. No? Keep it. Greece, Crete, right there. Cyprus, Malta. I'm good at this, man. I'm telling you. Egypt? Egypt's right here. Egypt's an easy one. Yeah, there's Morocco, and then there's Algiers, and then there's Libya. You're right. Kaliningrad? Kaliningrad is right there. It's not. It's Russian territory, but it's not connected to Russia. Where did V2s launch from? So V2s were tested in Peenemünde, which is right here, but there were all coastal launch sites here throughout France and northern Germany to hit the UK. But their big testing site is in Peenemünde in northeast Germany. It's right here. See that coastline? They launched them this way into the ocean. What's your opinion on the Portugal GB? Portimão is a good track. Where's Burkina Faso? Over here. That's Western Africa. St. Petersburg? St. Petersburg is... I might be able to point it out now. What a picture. If they go back to the map view, I'll show you. If a V2 ever hit the UK officially, it would have been bad. V2s did hit the UK flag, and St. Petersburg is over there. It's right there, right near the border with Finland. A lot of V2s killed a lot of people. Like in Haiti, over there. Haiti's not even on this continent. It's not even in this hemisphere. It's in the, yeah, it's not even in the, yeah, it's not even, yeah. They did? I thought they didn't go. Oh, they launched them, Flykin, yeah. The V2s were tested in Peenemünde, and then we bombed the trash out of that factory, so they moved them to an abandoned underground mine in Mittelwerk. And they used slave labor to make them, and then they launched them from all different types of sites up in here. They built a huge launch complex in the side of a mountain in France, and then we bombed the crap out of that. So then they figured out that it'd be easier to just kind of put it on a truck and make a launch site wherever. Like a Scud missile almost. Yeah. Not a high point in human history. So we're over the Balkans right now. Greenland? Up there. Greenland, Iceland, Reykjavik is right there. Copenhagen is right there. It's near what's the city at the bottom of Sweden? Malmo. Malmo's over there. Norway's right here. Finland is right there. Helsinki's right here. Uzbekistan is over here. So it's south of Kazakhstan right here. Like, it's on the bottom southern border of Kazakhstan. Kazakhstan kind of runs along the top of this mountain range right here, which becomes the Himalayas. Uzbekistan is right there. Svalbard is the island at the top of Norway. Oh yeah, it's the launch site. I knew I recognized that name. Yeah, it's Malmo. Yeah, I was right. Okay. Where does MSC take place? Right around where my mouse cursor is. I don't know specific cities, Iliad, to be honest. So we're flying over this is between the border of Bulgaria and Turkey. We're gonna fly over Istanbul right now. What's your opinion on the Portugal GP? I like Portimão, Shaw. I already answered you, bro. It's a good track. Closest IKEA on the map. Yes. Oman? Do you want me to find Oman, DJ? Oman is right here. Guys, I'm telling you, I like geography. I'm good at this. I'm a geography nerd. Oman, Yemen, Saudi Arabia, Bahrain, Qatar, UAE. Egypt, Israel, Iraq, Syria, Jordan. No, Jordan. Where the hell's Jordan? Yeah, no, Jordan's up there. Jordan and Syria are next to each other. Ever Given. Literally right where my mouse cursor is in the Suez Canal. The Suez Canal is right there. Dubai? Dubai is right here. Palestine is right there. Can you play GeoGuessr for early hours? Sure, but where is Russia? Yes. The capital of Turkey. It's right. It's literally right where the stage is. I forget its name. Shut up! Don't say it. Don't say it. I forget. It's not Istanbul. I know it's not Istanbul. I forget. I forget the name. Ankara. Damn it! I knew that too. I knew it wasn't Istanbul. The Roman Empire, all right here. China Webcast is talking about the ISS. The Russian launch sites. Baikonur is right here, Plesetsk is over there, and you can't see the other ones. Interesting. Senegal? Senegal's over here. On the west coast of Africa. Blackness, that link doesn't work for me, dude. Buzzard, I got give me half credit on the capital of Turkey. Half credit. Where is Tuvalu? I actually don't know that one. Rwanda? I think Rwanda is over here. But I forget. My African geography is rusty. I mean, it technically is geometry. Where's Godzilla? We're not near Japan, Mason. Why does the Caspian Sea look dry? That's just, I think it's because it's in the daylight. I don't know. And yeah, so the Caspian is right there. The Black Sea is right there. The Aral Sea is right there. But, well, what's left of it? Where's Waldo? I don't know. You find him. Look for the stripes. Nice pictures. Nice picture, Snake. That looks great, dude. The Taj Mahal, it's in India, but I'm not sure where. Where's the money? We don't have the money, Torg. Rwanda is in East Africa by Tanzania, so that's down there. Cyprus? Right there. Where's Japan? You can't see it. Kuwait. Right there. So where are the Mongols at? The Mongols are in Mongolia, Flykin. They're over there. Mongolia, the Asian steppe by the Gobi Desert. It's over there. Astro, I don't know my Indian geography very well, to be honest with you. I'm not that good at it. So, like, Middle East, I'm okay. So, it's flying kind of on the border of Iraq and Saudi Arabia right now. And then, so you have Iraq right here, Saudi Arabia, and then Iran is right here, and then Pakistan, and then India. In short words, it's a little bit more complicated than that, but Mount Everest, right there. The Himalayas are right here. That's the Himalayan mountains. It's between the border of China, which is right here, and India. Where's your mother? Probably see her from this altitude. Wrong side of the earth, man. Hello. K2 is right next to Everest. Do you have a favorite enclave? I'm not sure what do you mean enclave? The Gobi Desert is right there. It's on the northern part of China, between the border of China and Mongolia. No Nepal? Well, Nepal is in there. There's a bunch of countries in here. Here, have a good link. I don't know what this is. Blackness, it's not working. Where's Asia? I don't know. That's too complicated. The Democratic People's Republic of New Jersey. I see what you did there, you jerk. I'm walking here. Oh, great shot by Mike Seeley. This one. Great shot. Indian subcontinent. It's right here. Bro, they're talking about ISS commercialization in the 2024 to the future. On the Chinese webcast?
Space Station. According to the Outer Space Treaty, the United States and Russia are legally responsible for all modules they have launched. So can you tell us a little bit more details about what are their disposal plans after the ISS retires?
Well, that's the very good question you mentioned about the Tiangong 1 and Tiangong 2, as well as the International Space Station burnout. Tiangong 1 was uncontrolled re-entry, so it was very close to a damaged area, but fortunately it landed in an inhabited
where the pyramids.
Areas. So it's
right
very
there.
safe re-entry. On board the International Space Station,
so this is
if
the
they
Chinese
want to burn
webcast.
out some of the segments, they can do it in a controlled manner. They can drop those cargoes or the segments
everywhere
they don't want to use anymore. They can re-enter into space, and they can design the trajectory so that it will drop in the Pacific or some areas that is less populated or even no populations, so it can drop into the ocean. But some of the hardcore stuff would sustain the burn. For example, the glass, the ceramics, and some of the metals that they can really withstand the re-entry of burning. Unlike other materials, will disseminate and fragment it in the re-entry process. So some of them will survive. So we have to design the process in such a fashion that we have joint observation of the ground facilities, and it will drop in the same area, a safe area.
I don't think that word means what you think it means, man.
Inhabited by human activities. So the dropping of the International Space Station is not being planned at this moment. I think the first thing is to look at the value of the International Space Station, the amount of money it costs to maintain the station altitude and the control of the station, as well as the commercial aspect.
Yeah, like, and this is a Chinese webcast talking about deorbiting ISS modules.
I want to get your take on the international collaboration, right? China is saying that it welcomes collaboration on the Chinese space station from scientists from all over the world, but the level of international collaboration that the CSS will receive, according to analysts, will be unclear due to geopolitical hurdles, noting that U.S. law places very heavy restrictions on NASA scientists cooperating directly with China. So how are you looking at this, the prospects of international collaboration?
It's actually a good question.
Well, you see that according to the white book of China aerospace activities, and also according to the announcement of China Manned Space Agency, the international cooperation will be one major task of our space station. There are 4 levels. The first is a joint experiment, as you see, it's extended.
That's the replay. That's the replay there. And also talk to us about this telescope that we're going to see be joining the Tianhe module.
It
says the Hubble Space Telescope will last through the mid-2020s. What are some of the significant contributions it has made to the study of outer space?
What you mentioned is
they told him to shut up.
Module. Originally, it is
did they? Like, did I just hear that right?
Original experiment.
They basically cut his mic.
But finally, we decide to
what the hell?
let the Xuntian to fly independently. So the Mengtian takes the place of the Xuntian as an experiment module of.
No, let me rewind that. Let me rewind that.
Hold
on.
Xuntian will stay in the same orbit of.
In such a fashion. And the control of the station.
Chinese analyst
of China.
How are you looking at this, the prospects of international collaboration?
Well, you see that according to the white book of China aerospace activities, and also according to the announcement of China Manned Space Agency, the international cooperation will be one major task of our space station. There are 4 levels. The first is a joint experiment, as you see, it's extended.
That's the replay. That's the replay there. And also talk to us about this telescope that we're going to see be joining.
Bruh.
Yeah, what kind of the international...
So, I didn't show it, but when he's talking, he looks over to his left 3 or 4 times. Oh, don't tell Mr. Yang, Professor Yang to shut up. I like that guy. He was the guy that was getting hype.
Example to illustrate how important this kind of international cooperation is in this era of space exploration.
Frickin'
Mr. Chu.
Well, I think international cooperation is very important for all missions in China. We have also
I like that
a very
guy.
prominent mission of the Chang'e missions. The Chang'e 4, as a redundancy of Chang'e 3, has collected 5 or 6 countries to put on board the Chang'e 4 instruments.
Professor Yang there started talking about their plans with the station. He said it was going to be deployed in 3 steps, and then right when he started talking about the first step, they were like, shut up. Oh, man. I was actually, dude, I was like amazed for a second. I'm like, are they actually talking about this? Are they going to answer that question? And then I was actually going to say that would actually been pretty cool if they sit there and let him answer it, but nope. Yeah, no, that's the dude that was getting like all pumped up. He was getting fired up during the launch. I like that guy. Don't do my man Yang like that. Come on now. Don't do my man Yang like that. That's, dude, I've never seen that actually happen. Holy smokies, man. Yeah, that's scary, dude. I don't like that at all. Looks like they improved something and they can now actually deorbit the core when they want. Cool.
Has been applied in construction of smart ports, communities, factories. Diapers were initially designed.
Hellfish, they were talking about, you know, what are China's plans internationally with the internationals, like, you know, like what are their plans in space in the future, like in terms of international cooperation. And the professor started talking about what China's plans are with the station, and they straight up cut him off. And then they showed like a replay of the launch. Like they cut him off. He was like saying, it's like, oh yeah, no, this is going to be great. That we're going to roll out the station in 3 steps. And oh. And then the other commentator was like, yes, this is a replay of the launch. Like, that was... Oh, boy. Like, that's kind of messed up, dude. I liked that guy. That guy was cool. So here, I got you again.
Analyst will be unclear due to geopolitical hurdles, noting that U.S. law places very heavy restrictions on NASA scientists cooperating directly with China. So how are you looking at this, the prospects of international collaboration?
Well, you see that according to the white book of China aerospace activities and also according to the announcement of China Manned Space Agency, the international cooperation will be one major task of our space station. There are 4 levels. The first is joint experiment. As you see, it's extended.
That's the replay. That's the replay there. And also talk to us about this
guy
that we're going to see.
Oh, man. Yeah, no. Yep, you're going to get in trouble for that. Oh, that's no good, man. Wow. Dude, I've never seen that actually happen.
The coverage of our ground stations are still limited, so we really need the support from other countries to get the ground stations, the data link from the stations of other countries.
Let me back
and
up
also, as Mr. Xu has mentioned, we
operation even before the construction.
I backed it up a
of the
little bit.
space
Let's see.
station.
Actually speaking, you know that our manned space activities and our lunar exploration project and even our Mars missions is getting some support from other countries. You see that during the first several missions, the European Space Agency provides support by utilizing their ground stations all over the world. Because you know that although China is a big country, but still very small comparing to the whole globe. Well, during the flight missions before we have our Tianlian data relay satellite, the coverage of our ground stations are still limited, so we need the support from other countries to get the ground stations, the data link from the stations of other countries. And also, as Mr. Xu has mentioned, we have payloads from other countries. Especially, I should mention that you know that Shenzhou 8 is a manned mission to test the rendezvous and docking technology. But on board the Shenzhou 8, there is a joint experiment between China and Germany called Symbols, which performs some biological experiment in space. So these have very great achievements and have benefit to the science, to the space science, and also to the benefit of the whole human society. So in the future, you see that the international cooperation, to my understanding, is already a major trend in the whole world, not only in China but also in other most space-capable nations. So we should do this more in the future.
Well, Mr. Xu, I got to ask a question because this project has been involved so many international organizations inside.
So this is one of the.
I skipped around.
For once you have an.
How long is second SES2? 1 second, Shaw. What are they flying their astronauts on? They fly on Long March, a Long March 3F, I believe. Long March 3. Long March 3 is a hypergolic booster, and it's it launches up in the Gobi Desert, believe it or not, and it launches the Shenlong spacecraft, which is it's Soyuz derived. Okay, we're coming up on engine restart here on the SpaceX launch. Couldn't tell, well, he started talking about what their plans with the space station was, Astro, but I mean, that could have been a hiccup, dude, but so, like, he was, whoever, okay, look, someone who's been inside of a studio environment, all right, the guy, when he was talking, was doing this. So somebody was saying, no, not the right thing. Now, that could just be that he was going on a different, that they asked him the wrong question to coordinate with the slides. It could be something as simple as that. Or they told him to shut up. It could be either one. I don't know. It's just weird seeing that, though. They had solar panel deploy on the module here. Yeah, Caviar, very much like that, yes. They'll boost the apogee here in a second, Greg. It's flying out over Diego Garcia, that's right. Manny, guten Morgen, wie geht's, mein Freund? Okay, stand by for SES-2 here. That's not ullage someone, they're chilling down the engine. They're doing an MVAC chill. That's what the vents out the sides are. You could see that? There we go. That's a chill down. I said gut Wetter here. Cool. Wunderbar.
Welcome back to the
Okay,
webcast for our
What up, Jesse?
25th Starlink mission from Cape Canaveral Space Force Station. We had an on-time liftoff at 11:44 p.m. Eastern Time. We had a great stage separation with first stage making its way back to Earth, landing on our drone ship. Just read the instructions for its 7th flight and 7th landing.
Yeah, it's gonna be
for
quick,
this
guys.
particular
Don't blink.
booster. And our 81st
Actually, the
landing
engine
of
spooling
a,
up is going to be
orbital
longer
path
than the actual
rocket
engine
overall.
ignition. Watch.
Stage 2 completed the first of the 2 burns, and now we're coming up on the relight of the second stage engine once again for SES-2.
Don't you need an ullage burn before you can pre-chill?
Burn.
That's what
It's
the attitude
just
control
1 second
thrusters
long,
are for,
but it
Entropy.
gives us
The
enough
nitrogen,
boost
did you
to
see it
get us to
pulsing?
our targeted
They
drop-off
were
orbit.
doing it.
We should get a live view here. May not look like much because it is only 1 second long. But we should be able to see SES-2 as well as SECO-2, which is second engine cutoff.
Okay, stand by for ignition. There's a little bit of a delay on the feed here. And we're good. Perfect. Looks good. So you got a good transfer orbit?
And there was SES-2 and SECO-2. As I mentioned, it was very quick, just 1 second. We are waiting on confirmation of good orbit here.
Nominal orbit insertion.
Perfect. Good
And
satellite
there
orbital
is that
insertion.
call
Perfect.
out. We have a good nominal insertion. Again, our Starlink sats will ultimately end up in a LEO or low Earth orbit about 550 kilometers above the Earth's surface, which is different than your typical geostationary or GeoSat, which orbits roughly 36,000 kilometers above Earth. Now we have another 15-minute coast phase before we deploy our next batch of Starlink satellites into orbit. During this time, the spacecraft will start to spin, giving the Starlink satellites the momentum that they need to space themselves out over time after they deploy. So while this happens, sit back and continue listening to those super awesome space jams. We'll see you back here at T+1 hour and 3 minutes.
Why make it such a short burn? Can't they do it before second stage engine cutoff? floating disc, what they do is they basically put the thing into a parking orbit. They put it into an orbit where if something goes wrong, it'll deorbit pretty fast, or they could do like some kind of controlled deorbit, right? That's what a parking orbit is. It's basically where you park before you go on your expedition wherever you need to go. Okay, they have lost a signal from Diego Garcia there. So they put it into the parking orbit, and then they do that little burn right there to ensure that the satellites hit proper apogee. The Starlink satellites don't have enough delta V to be able to push from that parking orbit all the way up. Simultaneously, they've tried to optimize descent trajectories where the first stage launched with the apogee at 550 during launched with the apogee higher. So at second stage engine cutoff, they were at 550. And when they tried that previously, they lost the first stage, or the first stage was damaged. So now they fly on a lower ascent, put it into parking orbit, and then puff the engine for a second to make the orbit slightly eccentric, and then they'll deploy the satellites, and the satellites will utilize O-berth, and they'll burn at apogee to push perigee up with their krypton ion thrusters. No, that's not fake, I swear. The Starlink satellites have a krypton-based ionic thruster. So basically what they do is the satellite has a little thruster mounted on the side, amongst other places, right? And it's a little combustion chamber, and it has two nodes in it. So like, and what those nodes do is they arc electricity through the combustion chamber. So what the satellite does is when it wants to fire, they shoot krypton gas into the combustion chamber, and they arc electricity through that krypton gas. And that krypton gas ionizes using the Hall effect, and that's actually how the satellites produce thrust. Now, ionic thrusters are cool. It's very sci-fi stuff, but they're very efficient for what they do, because you're basically ionizing inert gas, right? It's very efficient, but a fan on your desk to keep you cool during the summer has more thrust than an ion thruster. But then again, up there for small satellites like Starlink, they're perfect. They're perfect to push it up into orbit. That's what that Starlink train is that you see go over. What is the Hall effect? A Hall effect is when something ionizes and creates a little electrical field. They could put a nuke on a satellite and blow it up over the USA and cause EMP. Yeah, of course they could, DJ. But there's very strict regulations on launching nukes into space. Because, so no dingbat goes and does that. And that's something that's agreed upon by all spacefaring nations right now, with the exception of a couple. Yeah, you don't want to GoldenEye somebody. That's a bad idea. I saw that movie. It didn't end well. I saw what happened at Severnaya. Remember Severnaya. Okay? How many kilograms is one of the Starlink satellites? Formula 1 car, maybe 600-700 kilos. They're big satellites. There's 60 of them in there. I am invincible. Hey, NASA man, check this out. Ready? Don't ever do that again. How long did you say that fuse was? Oh, grow up, 007. They'll say the pen was mightier than the sword. Thanks to me, they were right. Now let's ask Fred here to demonstrate. Here we are. Sorry about this, Fred. 1, 2, 3. I can do it! I can break her codes. Give me the codes, Natalia! Give them to me! Sorry. Yeah, Pilot Mike, that sucks, man. She works on the guidance system. She doesn't even have access to the firing codes. The guidance system. You're calling someone who works on the guidance system a moron. The guidance system. How the spacecraft flies in space. Boris, you're not too smart, mate. If she's a GNC controller for a satellite, bro, are you dumb? Boris, critical miscalculation. You watch way too many movies? Thank you. Ion engines benefit with the top speed being determined by the speed of the particles leaving the nozzle, not the overall amount. Mm-hmm. Yeah, I mean, in different gases, well, have particles leave the nozzle at different rates, you get different efficiencies. China's giving us they got a live view here of, here, check this out. Live view of the solar panel deploy. Boop. And right when I did that, they cut it. There it is. Very nice. Did NASA cut off the live feed when UFOs are near? No, they don't cut off the live feed, DJ. They have a TDRS handover, dude. It always seems like they do, and everybody gets all bent out of shape. No, what's going on is that, so in geosynchronous orbit, what's geosynchronous orbit? So there's an orbit that's high above Earth, about 23,000 miles that way, or about 38,000 kilometers straight up. There's an orbital altitude where the satellite's orbital period is 24 hours. So that satellite will orbit with the spinning of the Earth. NASA has those tracking data and relay satellites up there. Now, I'm not saying that that's what you saw and that was cut the feed. No. The tracking data and relay system has one satellite over the United States so they can communicate with mission control. And then there's another set of satellites that's 60 degrees around, and then there's another set of satellites that's 60 degrees around. That's how they can communicate with the ISS, even if it's over like Australia, for instance, right? So when you see pictures of the ISS and they cut to a blue screen, what they're doing is they're handing over between the satellites. That's all it is. It happens fairly frequently, and I see people confuse it for... They confuse it for, they cut the feed. No. Nah. That's not what that is. And the other thing to take into account, dude, is that there's a lot of junk up in space. A lot of stuff that we put up there. But there's also a lot of other things. Space isn't just empty. There's a lot of stuff up there. There's a lot of ice and dirt and rocks and all this. Space is a dirty place, dude. It's a dirty place, Hey, RG, what's going on? What happened? What's happening with China right now? Well, they launched their space station module, and it looks like they have the Li Shengfu, the chief commander of the China manned spaceflight program, is talking to people on it sounds like they're having a press conference or something. Yeah, I know they lose signal, but at certain times it's sus. The ISS astronaut said they've seen a UFO. Like I said, dude, there's all kinds of crap that's up there, dude. The UFO that they see could be solid gas that was outgassed by an incoming spacecraft that could just be in a similar orbit because the spacecraft fired its engines near the ISS. Could be something as simple as that, dude. Yeah, it's not always, oh my god, there's aliens! Like, look, there's stuff up there. Space is a dirty place, dude. There's a lot of junk up there. Micrometeorites, there's chunks of ice, there's all kinds of crap. And that makes the UFO people go nuts, but it's a dirty place, dude. That's like walking through a forest and being like, hey, that rock doesn't look like that rock. Aliens must have placed it there. That's how stupid that sounds. You see that rock over there? That's a different color than that rock. Aliens. Not saying it was aliens, but it was aliens. Some people ask me, is such a thing even possible? Well, yes, it is. Did you enjoy it, SC? That's kind of weird. Like I was saying about that one cloud, this had the chance to be a cool shot. Let me see. Oh, that sucks, man. Oh, yeah, that one cloud. Dude, that's close. Almost. You win some, you lose some, though, Sawyer. Like, yeah, there's a lot of crap up there, man. There's a lot of junk. Boop. We don't need to see Chinese officials saying how good they are. I was hoping it'd keep moving. I turned on all my fans. Nice. Do you believe aliens built the pyramids? I don't know. Maybe. Clutch. Okay, here's the thing. Look, all right. So the pyramids. You know, some people say, oh, humans couldn't have done that. Humans couldn't have done that. I mean, the pyramids were built, what, 6,000 years ago and change? Humans don't evolve that quickly, dude. We don't evolve that fast. The humans from 6,000 years ago were not that far off from us now. Really, they weren't. They could read and they could write. Funny how and they had spoken language. It's not like they were cavemen. It's not like the ancient Egyptians were cavemen. And now all I can see is that if we have the, you know, like, we don't evolve that quickly. So if they have the same hardware up here that we use, what's to say that they couldn't figure out a way to do that? You know, like, oh, they couldn't have moved the blocks. Yeah, really? 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 That's the best you... Oh, they couldn't have done that. They were idiots. Nah, I don't think so, man. Raid Area 51. They can't stop us all, bro! No. No phase, but that's a good name. I hate that argument most because, I mean, look, the ancient Mayan temples at Tikal, the pyramids, the Colosseum, like, why do we look at the Colosseum and say, oh, yep, yeah, that was definitely made by humans. And then you look at something like the pyramids and say, nope. And I get it. I fully get it that, you know, the pyramids are a little bit of a bigger undertaking than the Colosseum is, for instance, right? But also, we have acquisition of signal through Tasmania on the SpaceX rocket. Yeah, Ram, yeah, maybe. I mean, but that's like, I just never understood that. Like, why is the Colosseum cool? And why is, like, the Roman aquifers, like, oh, yeah, nope, yep, they definitely did that. But then the pyramid, no, we draw the line at a freaking box? Like, no, that can't be made. I mean, look at like, Angkor Wat. If you look in Cambodia, like, Angkor Wat is ridiculous. Like, you could sit here and you could make that same stupid argument. Oh, humans couldn't have made this. They would have needed tools. So you're telling me humans 6,000 years ago couldn't come up with a friggin' hammer? Like, really? You couldn't, nope, can't have a hammer. Nope, they couldn't have a hammer, they couldn't have a screwdriver. Yeah, okay. Yeah. What about mutilated cows? I don't know. I don't have all the answers, bro. The blue line is the next track, Rumblebelly. Fiber optics hellfish would probably be right. So, Rumble, the reason why you have the blue and the white orbits is the current orbit that it's on, and the reason why the blue one is shifted is because Earth is spinning. They didn't, yeah, they built the pyramids because they didn't have video games and they were bored. Yeah, Mad Cobra, I mean, you're not wrong. That would be a long cable. What? What? What are you talking about? The cable? No cable. Lasers. Fiber optic lasers, dude. Beam the data. Tight beam. Hello? Have you ever watched Star Trek, bro? No, seriously, you could do that. Starlink satellites are prototyping that exact tech. Pyramids were a pissing contest. I'm glad you're on the same page. It just makes me mad. I should work on that. Blackness, my sister is... or my sibling, I should say, she's an archaeologist by trade. I mean, she doesn't work, she doesn't do it, but she doesn't do it anymore. She switched paths because she decided she wanted to make money. Hilarious how that works. But she's gone on digs to, like, Tikal and stuff. So I end up knowing a lot about anthropology. And the funny thing is that she knows a lot about spaceflight and cranes and trains, and that's because of me and my stupid butt, which is hilarious, which I think I always thought that was funny. I know a lot about, you know, ancient cultures, more than you'd think. With that being said, I still watch Ancient Aliens and I laugh my butt off, dude. Those guys are hilarious. And for what it's worth, I watch a lot of UFO conspiracy stuff too. It's great. It's great fun. I don't know, Bram. Does she watch a stream? She's here from time to time, but she doesn't have an account. She lurks. Anubis is the first furry. Oh, don't do Anubis like that, man. Come on. Oh. Chunk of solid nitrogen or salt. Actually, that's probably solid oxygen because it came out of the vent line. Oh, Alucard, Ancient Aliens is fantastic. I love that show. Alright, we're at the speed of light speed too slow. Light speed too slow. Well, ship show, we gotta go right to ludicrous speed. So, okay. The stage is currently a little ways off the coast of Tasmania, mate.
25th Starlink mission. We had an on-time liftoff this evening at 11:44 p.m. Eastern Time. Our first stage booster had a successful 7th flight, as well as landed back on our drone ship. Just read the instructions for the 7th time, and that marks
they fire
our
the RCS
81st
and they spin the stage to separate
overall.
the satellites.
Stage 2 has already completed its 2 burns to enable reaching the targeted drop-off orbit, and now we're coming up on the deployment of our Starlink satellites. That should be coming up here in about 30 seconds or so, and we are hoping to get a live view of that deployment. As we pass over ground stations, sometimes we lose that live view, but hoping to get the live view right when we deploy the Starlink satellites.
I mean, it could happen, Elfish, who knows?
And there they are on your screen. Awesome view from space.
Nice, Black. All right, stand by for satellite deploy. Watch, they're going to release a tensioner rod, and because they're spinning it, Flykin, they're just going to let the satellites go. SpaceX didn't have room for a separator mechanism.
See how the second stage is spinning. This does
there's
help
that chunk of solid oxygen right there.
The satellites to separate once they do
So
deploy.
they're going to... So basically, this is like a deck of cards with a rubber band around it, and then they're going to release the rubber band and play 52 pickup in space. Watch. It's really cool, actually. And if the satellites bump into each other, Starlink satellites are built up on purpose. Oh, there goes...
Starlink deploy confirmed.
There goes the tensioner rod, and there they go. 52 pickup in space.
And there you can see and hear that call out that the Starlink satellites have deployed as they are drifting away from the second stage.
My briefcase!
Now you may notice a slightly different look of these sats on this mission, as some have been painted white for thermal reasons. This will not impact the satellite brightness since the painted face is facing away from the Earth. And just a reminder that this is their drop-off orbit, so shortly they will deploy their solar array, and over the next few days and weeks they will distance themselves from each other and use their onboard ion thrusters to make their way to their operational orbit.
Deorbits, Flykin.
And that brings our webcast to a close. Thank you to the Range and the FAA for supporting today's mission. If you're interested in Starlink service, head over to starlink.com and sign up. Thanks for joining us, and have a wonderful night.
You too, Jesse. Do ion thrusters work at sea level, and if you held your hand, would you feel the breeze? They work, D-Pick. The breeze, like I said, it's like a Newton at best. A model rocket engine has more thrust than those things by a pretty significant margin. You'd be able to feel it, sure. Yeah. But it would be it'd be like less than a like a light breeze, dude. Last, please. You wanting me to see your last, Flykin? No, come on. Does it land or does it burn up? The second stage? No, it burns up. Yeah, Tip, I don't know, man. I'm not an astronomer, so I can't really say. Typically between 25 and 250 millinewtons. Yeah, it's nothing, guys. Yeah, thanks, Mike. It's nothing. Like, that has more thrust. That has, like, significantly more thrust. What I just did than an ion thruster. They really... Guys, it's incredibly efficient for what it is, but it literally makes, like, next to no thrust. It's going to take a couple of weeks for those satellites to circularize their orbit. Interesting. So, 3 launches. Not bad. We saw a space station module go up, we saw some observation satellites go up, and we saw some internet satellites go up. Pretty much back to back to back. Back in the late 90s, I remember the thrust from an ion engine being described as like a sheet of paper resting on your hand. Oh. Typically, they also consume 1 to 7 kilowatts of power. Three launches, no scrubs. We live in the future. Yeah, Flykin, it's true. It's a shame. It's not very efficient. It's great for satellites, Hellfish, that have solar panels where you don't have electricity as a finite consumable, you know? But at that point, the krypton gas is your consumable. Or the ion, or the argon. They use argon, they use krypton, they use xenon. What do you think of SpaceX getting permission to fly their sats lower? That's good, Ship Show. Yeah, but BZ, that's good, man. That's a good thing. So if something goes wrong, the satellites they'll deorbit. I like that idea. Ship, I don't like orbits. I don't like the internet satellite constellations that are going into high orbits where if there's some type of like collision cascade where nothing will come back down. That's dangerous. I don't like that at all. Thank you for the coverage. No problem, Trey. Dave, 4913 sub. Is Blue Origin actually happy about the Starlink ruling, or are they just trying to save face? I have no idea, Venom. I'm not sure. Hellfish, I've talked to people that work on ion thrusters. A lot of ion thrusters are actually made in Massachusetts, believe it or not. Yeah, they're made in, I think it's Natick, which is a couple of towns over from me. They're made in Natick. There's a company that makes okay, so the ion thrusters for Gateway, yeah, those are being made here. They're not that far away. And I had guys that worked there tell me at some point through my travels that that ion thrusters are really only limited by how much electricity you can generate. If you couple one of those things to a nuclear reactor, then it scales, and it can scale decently well. The bottleneck at that point, and this is a guy that works on them, that works there, that told me, is that the bottleneck at that point is wire gauge. Yeah, how do you not overheat the wires and cause a short? Seriously, it would be like taking like a 16 gauge wire and connecting it to the 2 leads on a battery. It's gonna fry that wire. Like quite literally fry that wire because there's too much current going through it. That's the bottleneck with ion engines. That's what I was told by somebody that works on ion engines. Heat dissipation is a big deal for them. Are ion thrusters under ITAR rules? I have no idea, dude, to be honest with you. How much of that gas does the ion engines eat up? Well, it ionizes the gas and shoots it out the back, so yeah. By using liquid metal instead of regular wires. Yeah, nuclear thermal is more efficient at scale. How I would, like the ideal spacecraft that, like the best that we could design right now is a rocket that has a nuclear thermal engine. And all a nuclear thermal engine is an engine with a nuclear reactor inside of the combustion chamber, and they basically shoot hydrogen into the chamber, and the nuclear reactor exchanges heat with the hydrogen, and then that heated up hydrogen shoots out the back. That nuclear reactor still does generate electricity. So if you had a nuclear reactor in a NERVA, right, with reaction control systems that were using ion thrusters, you have RCS that's way more efficient than using like autogenous pressurization, cold gas, hot gas. It's way more efficient, like 100%, like, well, not 100, like 1,000% more efficient. And this is the type of tech that actually Russia and the United States are working on, this kind of tech. I would go throw my hat into the ring and say that China probably is too, but Natick is where I got my new bicycle. On Route 9, Forlorn, Landry's, by the 927 interchange. Yeah, I know exactly where that is. That's weird. That Staples that's right there? Forlorn? Across the street? I worked at that Staples. Yeah, that's weird. Forlorn, where the hell are you? Seriously, that is the reason why I know that area really well is because I took Route 9 to get to Framingham, which is the Best Buy that I worked at. That's a little peculiar. Near Albany, New York. Why? Yeah, Forlorn. Why were you in Natick? What were you doing in Natick? Yeah, that's my old commute. I know exactly where that is. It's right by Music Around. You can go look if you want. Music Around's a great store. Why not? All right. Forlorn is coming after you. Well, I don't know. She's a weird one, I will say. That's where the bike I wanted was available. Okay. Yeah. Yeah, Forlorn, that's weird. That's not close to me, but that's on the way to work. And once upon a time, a really long time ago, my family lived in Natick before we moved back into the city. Yeah. Funny how that works, huh? My dad commutes to Lowell every week from PA. Wow. I am sorry. Saw the Delta 4 launch from 6 miles away back on Monday. It was truly a sight. Aiden's pretty cool, huh? A little loud, huh? A little loud. There's also the issue of ionic erosion of the thruster's internal surfaces. You can easily carry more xenon or krypton propellant than you can use before the thruster fries itself. This is why the Dawn probe had 3 thrusters. Ionic erosion. Not something I thought I would ever talk about in a professional capacity, Bill. I'll be honest with you. You ever been to Pennsylvania? If so, how was it? Yeah, of course. A long time ago, I went with my girlfriend. This is the girl that I was dating before Brimo. We went to Pittsburgh. Been to Philly a bunch of times. PA's nice. Flykin, Pennsylvania seems very normal. And I mean that in an endearing way. There's nothing, like you go there, you're just like, yep, just seems like normal people to me. It's very normal. Does that make sense? I don't mean that. I don't mean that in like an insulting way. And I know that, you know, Eastern and Western Pennsylvania are 2 way different things. But everybody that I've encountered from Pennsylvania is just normal. Just normal dude. And I'm not saying that, just not weird. Like you, drop my dragon capsule. Now, you come up here, you there's all kinds of weird people. Like, you know, do you mean average? No, just normal. What you trying to say? You're a friggin' hick, geek. That's what I'm trying to tell you. No, just PA seems very normal. Just normal good folk. At least that's the vibe that I got. I mean, that's the vibe that I got from rural Pennsylvania. So, like, you get out in the Alleghenies, like, center part of the state. Pretty normal folks. Yeah, always, Thomas. I keep a lot of stuff on my desk. Seems like normal people, normal folks. I mean, it's not like I went there and I was like, whoa, this place is weird. It just seems very normal. Like, there wasn't, like, I didn't go there and I was like, like, when I went to Michigan, I'm like, everybody talks funny. They're like, oh yeah, oh god, oh crap, and everybody's gonna say that's Minnesota and Wisconsin. Yeah, okay. People from Michigan talk like that. Brimo talks like that. Don't try to. No, that's not how we talk. Yeah, it is. Say AutoZone. Say AutoZone right now. That's how, AutoZone is how the rest of the world's like. You say AutoZone. Weirdos. Seem like pretty normal people to me. Yeah, Ernok, just normal folks. You ever been to the Franklin Institute? Long time ago, Lev. Long time ago. Not everyone in Michigan. I know. EJ, did you watch the ISS tour by Victor Glover and Mike Hopkins? I haven't watched it. No. No tengo miedo. Squall. This place is so, it's hard to explain other than the car shows. Carlisle is cool. Yeah, it just seems like for normal down-home folk, at least out in the rural areas. To be fair, I was there at night, but still, you know, I don't, like, it wasn't like if you go to Texas, right, you'd be like, man, this place is ridiculous. Or if you go to Florida, you're just like, yep. You know what I mean? Like, I went to Pennsylvania, I'm like, this place looks pretty normal to me. I'm so sad the Montreal GP was canceled. I was supposed to go. Sorry, man. Yeah. It looks like they're going to replace it with Turkey, from what I understand. Oh, okay, Squall, I'll check it out. DJ believes in flat Florida. I'm sorry, the truth hurts, Forlorn. Wake up, sheeple. Is this what you want me to say, you frickin' weirdo? Oh wait, it's in Carlisle, not Canton. Or not, the biggest Corvette show on the East Coast is in Carlisle. Corvette's in Carlisle. It's a huge auto show. Florida sucks. I hated you. J-Rock, I like Florida, man. I don't think you know what you got, dude. You got car racing, you got good weather, and you got rocket launches. And not only rocket launches, you got a lot of rocket launches. How could you not like it? I mean, I'm talking specifically about Central Florida. I like Central Florida. I lived there. I don't know what part of Florida you're from, J-Rock. I don't think you've ever told me. Have you been to the Air Zoo Aerospace and Science Museum in Michigan? No, but Brimo took field trips there a lot. Yeah, there you go, Ernok. Carlisle Ford Nationals are June 4th through the 6th, just saying. Plus the Miami GP. I mean, that's fine if you want to go watch basically a faster autocross event in a parking lot. Might as well call it a launch pad. Orlando sucks. 35 years in this hellhole. Well, what part of Orlando do you live in? Jeez, man. I lived in Winter Park, J-Rock, when I was there. I loved it. I loved Winter Park. It was a great town. Seriously. That's on the northeast side of Orlando. I mean, if you're like in Orlando proper, oh god, or if you have to go on I-4 every day, I can see why you'd want to blow your brains out. Winter Park, do they even get a winter? Yeah. Random Bob, you want to know what Florida winter is? Florida winter is 60 degrees and cloudy with like 50% humidity. That's what Florida winter is. I want to go to Sebring. Sebring's cool. I like Florida, man. It's better than 95, let's be honest. So if you're just popping in, guys, the SpaceX coverage has ended. We had 3 launches tonight. The Vega VV-18, the Long March 5B launching the Tianhe Chinese space station. Yeah, brand new space station just went up. There's now 2 on orbit. And then we watched SpaceX with the Starlink satellites. I don't even know what Starlink mission it is. I've lost count. It's somewhere in the 20s. I'd love to move to Florida. I like Winter Park is nice, but I'm done with the people. J-Rock, I never had any problems with the locals when I was down there. Maybe that's because I had out-of-state plates. Last, I got you, Flykin. I'll check it. I'll check them out if I go there. Why don't you move to Florida? Because Brimo has a good job here, Clutch. It's a dream job. Brimo works for a pretty awesome tech company. I can't take her away from that. And no, we're not splitting up. Hell no. Hell no. No way. Yeah, J-Rock, maybe. I don't know. Someone who wants to lay dailied from Foxborough to Andover, I-4 is fine. Yeah, Mike, it's not that bad. It's bad relatively, dude. It's bad relatively. Foxborough to Andover. Oh, have fun with that. Have fun with 95 in the morning and then 128. Pfft, nah, I'm good, man. Okay, Squall, I'll check it out. I don't know who CJ is, DJ, but that's not me. I don't know who you're talking to. Take Brimo's employer and push him to Florida. Apollo, I'm waiting for her employer to put her job remote permanently. Dude, put a job permanent remote. Bees out now. Primo likes New England, and I don't blame her. I do too. But yeah, it just sucks because we're really far from launch sites. You should check out the auto show in Michigan. It's a must for car nuts. I've been to Michigan's International Auto Show, Astro. Brimo is from Metro Detroit, dude. Dream job. I know how it is. I went from IT to trucking. I want to do nothing else. Yeah, there you go. Easterners poop their pants in Colorado. Never been to Colorado Farm. I've flown over it, though. Dude, I've been to almost every state. Actually, hang on. Let me see. No, I was gonna say I've been to every state on the Eastern Seaboard, but here, let me take a look. Actually, like for reals. All right, so Maine, Vermont, New Hampshire, New York, all this. Never. I've driven through West Virginia, never stayed there. Been through Maryland, been to Delaware, Virginia, North Carolina, all this. Yeah, no problem. Georgia and South Carolina are really pretty. Obviously Florida. I've never been to Bama, never been to Mississippi, never been to Louisiana. No. Yes. Never been to Wisconsin, been to Illinois. And the only other states out of all this is Texas, California, and Washington. That's it. Never been to Alaska, never been to Hawaii. Oh, wait, Arizona. I went to Tucson because of Pima. So, California, Arizona, Texas, Washington, and then that's it. Yeah. I've been to Michigan, been to Ohio, Pennsylvania, New York. All this, everything on the Eastern Seaboard except for West Virginia, which isn't really on the Eastern Seaboard. No West Virginia, no Kentucky, no Tennessee. None of these guys in here. None of anything up here. Been to Texas a bunch of times. Been to Arizona, been to California, been to Washington. Other than that, nope. Maine, many times, Everest. Yeah, Maine is 40 minutes away, dude. These states are tiny. I'd love to go to Yellowstone, Brim. I mean, we flew, so like, that's the thing. I've never been to those states, but that doesn't mean I don't know anything about them. We flew to a vast majority of these places in Flight Simulator, and I don't know if you guys noticed, I spend a lot of time on Google Earth. Nice shirt. Not a mission from Gad. We flew around over Yellowstone. Yellowstone was cool, man. Really cool. What's your favorite state? Oh, I like Massachusetts. I like the state that I'm from. Yeah, Massachusetts is cool. It's a cool place. There's a lot of people. There's a lot of people like on the seaboard, like up here in the Northeast Corridor, in this area right here. There's a lot. Have you been to the Caribbean? No, never. Besides home, Florida. But that's Florida. Yeah, it's the only other place I've ever lived. Aside from this place up here. Florida's kind of getting whatever, man. Different states have different costs of living. Oh gosh, what I'm not gonna do is go down there and act like a doofus north of the Mason-Dixon line and treat everybody like I'm better than them. I hate people that do that. I can't stand that crap. Like if I move to a state, I'm not gonna sit there and expect everybody to act like they do in the state that I moved from. I can't stand people that do that. I get people around here like that all the time. Boston has a lot of international trade, and there's a lot of people that aren't from Mass that didn't grow up here, and it's very easy to see who didn't grow up here, and they're. Oh yeah, Novus, I'd love to. GeoGuessr? Man, I don't know. It's 1 o'clock, dude. I've been going for 11 hours. Well, no, 10 hours. So getting that vitamin D. This feller's mullet looks like it was grown in New York City. That's not how that works at all. Yeah, Bram, I know. Yeah, that's what I mean. Yeah. Oh, geez, I moved to the state. This state's real nice. Here, let me just act like everything's California, right? Because Idaho's California, right? That's the same thing. Okay. Get some rest, please? Yeah. I got another stream tomorrow. Tours get really interesting in the Four Corners in the summertime. Jeez. Couple of rounds of Tarkov. Maybe tomorrow, fellas. Okay? Yeah, no. Trust me. I get a lot of people. There is a lot of people because of all the schools and stuff, dude. So, like, I'm here, right? That's me. There's a lot of people from BU, BC, Harvard, MIT. What else is up here? Suffolk. There's a bunch of schools. I lost track of all of them. So you get people from all over the country and you get people from all over the world. Now, you know what the messed up part is? I don't really have problems with people that are like, okay, so in Boston, because of the Medicare, the medical stuff, you see a lot of people from the Middle East. And then because of the schools, there's a lot of Chinese foreign exchange students. I actually don't mind those folks because they're quiet and they keep to themselves. As screwed up as that sounds, I don't mind that at all. Like, really, thank you. You leave me alone, I'll leave you alone. Just, like, you get a lot of folks. You get a lot of folks that aren't from Boston that want to let you know that they go to school in Boston. Yeah, I get that a lot. You get that a lot. You get that a lot around here. Yeah, Hellfish, maybe. Yeah, that's the kind of stuff that's annoying. It's always, you could always tell a local from someone that's not. It's really easy to spot. Whoops. That must be annoying. Yeah. Hey, Astro, you know what, dude? It's good to see my city doing well. My city and my state's doing fine. You know what I mean? Like, as messed up as that sounds, if that's my biggest gripe, that some of the people that are from other parts of the country that are moving here, are D-bags, like, how bad is it, really? How bad is it? It's not bad. It's not a bad place to live. It really isn't. I'm on a travel nursing assignment right now. I miss Florida. Ship show. It's people that get it and people that don't, man. I love Florida, dude. Florida's my second home, man. Love that place. I mean, ship show. Look at this. Look at this. Look at this. Look at that. Look at that. Come on. Come on. It's legit, dude. Are you implying that people from Boston are impolite? No. You know how I can tell someone that's not from around here, Green? They're polite. The more you know. Come here and shoot guns with you. Mike, I'm thinking about it. You're a little pale for a Florida wannabe. Nah, that's just the monitor light, dude. Look at that. Look at that. Look at this. This is great. It's freaking ridiculous. If you told me 10 years ago that I would have a mullet and I would sit on stream all day talking up Florida and playing video games and getting paid for it, I would have called you nuts. You have mullet for Florida, but we need to talk about the skin tone. Once again, that's just the three monitors, dude. You want to see? Here, look. Let me turn them on lightsaber mode. I actually think it suits you well. Oh, yeah? Still pasty? I mean, guys, I got an orange chroma. Any light is freaking taken out of my freaking skin color, dude. Yeah, Everest, the Chinese folk keep to themselves, dude. That's something that I've noticed. They mind their own business. They keep to themselves. I like that because that's what I want. Just leave me alone. Just leave me alone. Anybody from the Northeast knows exactly what I'm talking about. Just leave me alone. I don't think people truly understand how redneck Florida is away from the beaches. I understand, man. You know, it doesn't bother me. Can't tell the difference. Go to Panama City then? What, in the Gulf? I know where that is. Guys, yo, look. That's exactly what I was talking about, man. You don't come from urban Massachusetts and then go to the Gulf Coast in Florida and go there and be like, man, these people are so stupid, am I right? I hate people that do that. I can't stand that crap. Yeah, of course, someone living 1,000 miles away from you lives a little differently than you do. Oh God, imagine my shocked Pikachu face. Like, I don't care. Doesn't bother me. Shocked Pikachu face. Oh, I go to this place and everybody's acting different from me. They're so weird, right? Like, yeah, that's how that works. In bird culture, that is known as a dick move. And the funny thing is, the people in Florida can't stand people from Massachusetts and New York because they do that crap all the time. Don't think I don't notice that crap. I see massholes doing that all the time. Saw that all the time when I lived down there. Stupid. Oh, or knock. Yeah, that's kind of close. I hate people that do that. I hate people that turn their nose up at other people because they live differently than them. That's the dumbest shit I've ever heard. Yeah, guys are massholes. We're all over the place. Sure glad I live in the Wild West. Massholes from Massachusetts. Yeah, that's right. No, DJ, I don't. Yeah, a lot of New Yorkers down there, Ivo, and a lot of people from New England. The reason there's a lot of people from New England down there is because mass maritime ships. A lot of charter ships. At least they're better than the New Yorkers. I don't think in their eyes, Mike, that locals down there don't see a difference. Lies, New Yorkers actually got good baseball teams. Okay. All right. Screw you and screw them too. Look, in the Northeast, it is customary to be a jerk to someone. Doesn't matter if it's Jersey, doesn't matter if it's New York, doesn't matter if it's Connecticut or Massachusetts. We're all jerks to each other. That's the culture. That's how we work. Everybody's a complete jackass to each other. You don't pay it no mind. It ain't personal. That is a little bit different than how they live down there. Yeah, exactly, Astro. It's the difference between Southeast Michigan and the UP. The UP is very different. Not much of a gun person. Let's just say moving to Idaho was a shock to the system, but I respect it. There you go, Bram. Freaking firearms are cool. Legal firearms are cool. That's cool, man. I enjoy the engineering behind them, believe it or not. Like, it's like something that can launch 800 rockets in 1 minute. It's pretty cool. You know, like, you can get some full rock and roll. That's actually pretty cool. Yeah, Farm, I just never was into that, dude. I never was into that. Dude, oh, man. Farm, I grew up with yuppie trash. Like, ask Brimo. It's ridiculous. Like, oh, God, there's yuppie trash everywhere. It's like, you know, I watched American Psycho yesterday, like, on my day off. It's like that, dude. It's like that, and I had to deal with that. I had to deal with that all growing up. It's just like, okay. Oh, my goodness. Yeah, so it's a payload Yeeter 5000, Mike. So I'm from the South, and I think I may move out to Washington State or New England or something. I'm worried I'm going to be too polite. Apollo, that's the people in the cities. You go out into the, like, you go out into, you know, upstate New York. Actually, Apollo, here, I'll show you. Okay, strangest phenomenon, right? You have the Mason-Dixon line, right? And you go a little bit more north. People get more Yankee-like, right? You go a little bit more north, get more Yankee-like. Oh yeah, and then there's me in Boston, and then there's New York City, right? You go a little more north, and they get less Yankee-like. And then you get up to Maine, rednecks, dude. Oh yeah. Yeah, rednecks. Oh yeah, there's a bunch of blue-collar, hard-working people up there. Strangest thing. You would never guess it. I went up. I mean, I had some friends from Maine. They were hard rednecks. Like, and I don't mean that as a derogatory term. They're just blue collar working folks. They're not rocket scientists. They're friggin' plumbers, and like roofers and stuff like that. Oh yeah. Michigan is the same way. Michigan's the same way. You got southeast Detroit. You got a lot of city folk down here. You get up here. You get past Bay City. I mean, ask Astro. He knows. Strangest thing, dude. Yeah, there's snow rednecks. Oh man. Yeah, upstate New York, dude. All up in here. Oh yeah, even the northern parts of New Hampshire, man. Vermont. We don't talk about them. We don't talk about them. They make cheese and just damn commies. I'm just kidding. Northeast jokes. Oh yeah, Vin. They're all around, dude. You'd be surprised. All right, guys. I think that's enough. Vermont is cool. Burlington is the problem. I'm not touching that one, dude. Let's see who's still streaming, okay?